Welcome everybody to your JavaScript all-in-one video. This video takes the 100-part video series that I created and combines it all into one video. So this is good if you just want to watch it all of the way through. Now I also cut out the sponsored messages and the ending, so it's a little bit smoother than going through each video through the playlist. Whichever you prefer, it's totally up to you. I just thought I'd put both options up there for you. Now I would like to thank our sponsor of this all-in-one video, Call for Code, which is doing some great things with technology. Call for Code is a global challenge for developers to create open source technology to help in times of natural disaster. Created by the David Clark cause with founding partner IBM, Call for Code is bringing hundreds of thousands of developers together to build solutions using technologies such as blockchain, AI, and IoT. With winning projects receiving cash prizes, project support from the Linux Foundation, and more. Natural disasters are among the world's greatest challenges, with 2.5 billion people directly affected since 2000, and you have the power to help. Will you answer the call? Learn more by following the link in the description. And with that, let's get started, and if you enjoy the content, be sure to subscribe. Thank you.
Welcome everybody to my channel. My name is Caleb, and this is your first video in a 100-part series on JavaScript. Now, I imagine you're here for a reason. Maybe you want to learn to build websites, or maybe you're here for a class project, or maybe you just heard of JavaScript and people are saying it's cool and you feel you need to know it. Well, by the end of this series, you're going to have an intermediate to advanced professional working knowledge of JavaScript. You may have realized there's about 4 billion different video series on JavaScript, so what exactly makes this different than the rest of them? Well, first off, I got sweet graphic design skills, right? But the other two main things are, one, I want to make this entertaining. I don't want to bore you to death. That's not my main goal. I feel like that's most people's goals, but not here. And two, I actually want to teach you why we're doing things and the reason behind the code we're typing. I've seen my share of JavaScript videos. Half the time I'll leave knowing what to type, but having no idea how to transform that into something useful for me. So this series is for the kind of person who really wants to understand the JavaScript language and not just wanting some code to copy and paste. There are a few things that JavaScript is used for that we're going to be talking about. The first one is for front-end web development. So JavaScript powers literally almost all of the internet, and it basically allows us to have functionality like dragging and dropping, cool things happening when we click something, all kinds of stuff like that. So for example, here's a website, Google Drive. All the capabilities such as dragging and dropping and being able to have things pop up on the screen with options real nice and pretty, this is all done with JavaScript. That's one of the primary uses. The other one is for backend development, and this is done with Node.js. So Node.js is basically a way to make a website functional. So JavaScript on the backend can access the database, it can manipulate data and send that back to the front end through an API. Once you have a pretty good understanding of the JavaScript basics, you can pick up JavaScript frameworks. So frameworks allow us to build more scalable web applications. Some of the common ones are React, Vue, Angular, and what these do is they basically simplify the web development process. Well, honestly, when you first start using them, it's kind of a pain in the butt, but as you get going and start understanding how they work, it can help build more large-scale applications. These frameworks can even be used to make mobile applications, not just a web app that you access through a browser embedded in an application, but we're talking native applications. So for example, there's something called React Native. So here's React Native, and you can use it to build applications that run natively on iOS and Android. Basically what I want to show you guys here is that JavaScript is one programming language, but we can use it to build the front end of a website, we can build back-end applications, and we can even make mobile applications with JavaScript. So by learning one language, you're able to do a lot of different things. If you're coming from a different language, you might think you know JavaScript because the syntax is very similar to something you might see in some of the other languages like C# or Java. But let me tell you up front, JavaScript is not the same thing, and it's fundamentally different in the way it works and how the code runs. These are all the things we're going to talk about through this series because I want to make sure you guys have a real good understanding of how the programming language works. Some other things you guys should know throughout this series, there's always going to be useful information in the description, specifically a link to the sponsor, as well as a link to blogs on my website, and a JavaScript crash course I'll be working on, which is basically going to take this information and condense it in a nutshell version for job prep. By the time you're watching this, that course may already be done, but in the meantime, I'll leave a pre-order link in the description below if that's something you're interested in. You'll also definitely want to make sure you get new videos sent to you, so please be sure to click subscribe as well as clicking the little bell notification button. Thanks guys, Looking forward to this series, and in the next video, we're gonna get our first app up and running. It's gonna be super exciting, so I'll see you there. Welcome back, everybody, to your second video in your JavaScript tutorial series. At this point, you probably understand what JavaScript is used for, mainly for websites and backend and even mobile apps. But you may or may not have ever developed in JavaScript. But by the end of this video, you're going to have a working application and you're going to have your development environment all set up for the rest of this series. So let's get started by writing our first JavaScript application. And this is one of the most easiest things to do. The reason it's so easy is because we need something to run our JavaScript, and everybody has one of these programs installed, a web browser. So inside of a modern web browser, they have a JavaScript engine. So this is Google Chrome. I also recommend Firefox, but you can use Safari or Edge or Internet Explorer. The easiest way to get started with Java is go up here in the web address and type in JavaScript and then a colon. And then you can just say something like alert, put some parentheses, and then inside of these parentheses, put 2 double quotes. Inside of the 2 double quotes, put a string, hello world, just like this. Now, the syntax, that's gonna take some time to get used to if you're new to it, but just type it in just as is and it should work. Press enter, and you can see we get a message saying hello world. Boom, you just created your first JavaScript program. You didn't have to install nothing. That's what makes JavaScript so cool, because you make something in JavaScript, more than likely 95 or plus% more of the world is going to be able to run your application. That's a huge plus, but the downside is they don't have to go download something new. So a lot of these people are going to be running your JavaScript code in like ancient browsers and crappy smartphones or video game consoles. Basically, with JavaScript development comes the consequence that we have to be able to consider our application to be ran on any of these devices. And throughout this series, we're going to be talking about some of the ways to make sure our code works across browsers and across systems. So as you get into some of the more advanced JavaScript capabilities, all of those are not necessarily going to be supported across all the browsers. So I'm going to do what I can to call those things out and tell you what you need to do to get it working. All right, but enough blabbering, Caleb. Just shut up and make an app. So we typed an app up here in the address bar, but that's not the ideal way of developing a JavaScript application. That would literally be torture. So eventually we're going to switch to a code editor or a text editor or an IDE, whatever you prefer. I'm going to go with something called Visual Studio Code. So this is Visual Studio Code. If you guys have heard of Visual Studio, it's different. It's lightweight, easy to download and get started. So this is what I would recommend, but you guys are free to use whatever you want, whether you want to use Emacs, Atom, or Sublime, or Notepad++, or even Vim, whatever you decide. All right, the other thing you guys need to know is that inside of a browser, there are tools to make developing in JavaScript a lot easier. So if you go to any web page, and let's just go to a new tab page just so it's nice and clean. If you right click and click inspect, well, this is going to bring up a bunch of junk, and one of these buttons in here is console. So if you click the console tab, you should be able to type stuff in here just as if we're writing a JavaScript program. So for example, we could say alert and do the same exact thing. We press enter, and it pops up and says hello world. So that is another way you can test out JavaScript. This is good for that REPL feel, which is read, eval, print, loop. So basically, the web browser is going to read what we're saying, it's going to evaluate it, it's going to print the result, and then it's just going to keep doing that. So I'm opening Visual Studio Code now to write our first application in a file. So I'm going to click open folder, and then find some pretty place to make a folder, and then open that folder inside of this editor. All right, so I'm just going to put this in full screen because this is what we're going to be focusing on for a couple minutes. We can exit out of that welcome because now we have this JavaScript folder open over here. So the first thing you're going to need is an HTML file. HTML defines the structure of our website. If you don't know HTML, it's really not that big of a deal. It's fairly easy to pick up. I don't recommend you go watch an HTML series unless you want to bore yourself to death. So just follow along, and I'm not going to do anything too crazy. So index.html. You can hit that little plus button if you didn't see me do that. That's how you create a new file. If you can never remember the structure of an HTML file, just look up HTML shell, and it'll give it to you right there. So copy that and paste that right here. So the first thing we have is this doc type with this exclamation mark HTML. It just tells the browser, hey, we're working with an HTML file. Then we have this HTML element, Inside of that, we have the head and we have the body. Inside of the head is where we put our metadata and titles and all kinds of extra stuff that isn't actually going to show up on the screen, but is still important. Now you can write JavaScript inside of this HTML file, and if you want to know how to do that, go ahead and look it up. But I'm just going to jump to the recommended way, which is an own JS file. So what we're going to do is we're going to actually put that in a new folder. We're going to call it JS. And then in this folder, we're going to create a file. I'm just going to call it youtube.js. It has to end in a .js because it's a JavaScript file. And what we're going to do is we're just going to put that alert we did earlier inside of here. And we'll typically end this with a semicolon. So as we're developing, we're going to want to run this in the browser to see if it's working and to test things. And in order to do that, we need to open this index file inside of a browser. So over in your Explorer, you can right click and say reveal in Finder. That's going to open up the file. And you can double click it if it has a little Chrome icon, or you can right click and say open with. So open, and wow, that is pretty. So the first thing you're probably going to notice is that nothing is happening. And the reason nothing is happening is because we have this JavaScript file and we have this HTML file, but they're not connected in any way. Anytime we want to run our JavaScript, we need to tell the HTML file to include it in our page. Now I'm going to do this right before the closing body tag. So where it says /body, right before that is where I'm going to include our JavaScript. And the way you do this is you put script source equals and then double quotes js/youtube.js. So the js/ that's the folder, and then youtube.js is the file. And then we put the closing caret, and it'll automatically populate this closing tag. Alternatively, you can put this in the head. I prefer to put it at the end of the body. The reason is if we want to reference stuff in our HTML, it just makes more sense to put it at the bottom of the body so all of that stuff's already rendered. And if you're really curious about all that stuff, you could look up the best practices. You could also look up loading JavaScript files asynchronously using async, but this is going to work for most of our purposes, so I'm going to leave that right here. Now, anytime you make a change, you need to make sure you save all your files. In this code editor, if there's changes that need saved, there will be a little dot. So I always make sure that that dot is not there, and then I'll open the browser, and you have to do a refresh. So refresh, and then you'll get the pop-up. So there you go, guys. That is your first JavaScript program. Obviously, I didn't teach you how to do anything except set it up, but that is probably the hardest part. No, I'm just kidding, guys. It gets much harder, so be sure to stick around. If you've enjoyed this content, please be sure to subscribe as well as check the links in the description. Thank you, guys, and I'll see you in the next video. Don't quit, guys. Seriously. Most people are going to quit here. I'm telling you guys, persist through the series. You will not regret it. Wow, you guys made it to video 3. You know, most people probably don't even make it this far. So thank you guys for bettering yourself, learning how to code, and sticking with my video series. That means a lot to me. Really appreciate it. This video is going to get really juicy. We're going to do some really cool stuff. As a forewarning, if you're new, some of this stuff might not make sense right away, and that's totally cool. What I recommend is literally just copy what I'm doing, and in the upcoming videos, we're going to be explaining all of the details, and then you'll be able to come back and understand all this content perfectly fine. My goal in this video is just to show you how JavaScript can interact with our web page and make it dynamic and pretty and cool. It's not really pretty. It's actually going to be pretty ugly because I'm not going to style it. So this video, we're just going to be talking about how to use JavaScript to interact with some of our HTML elements. So back in our HTML file, all of these things with the carets and then the words and then the closing caret, these are known as elements. And the one we're really going to focus on is this body element because everything we're going to do is going to be inside of this body element. So there are all kinds of HTML elements. If you put that first caret, you can see some examples. One we're going to be using is the P, which is a paragraph. So you can use this if you want to put some text in there. We can close that P, and now we have PP. Gosh, Caleb, grow up. You're so immature. So this element has an opening tag and then a closing tag. In between these two tags, we can put the content. So let's say we're building an app where you can buy junk and then you have to confirm your purchase. We might have something in here like confirm purchase with a question mark. And then we might have a button that says, yes, confirm. So to make a button, you just use the button tag and then you can say confirm. So I brought the web browser up here so we don't have to continue switching windows. When we refresh, we get hello world, that's in our JavaScript. And then we have this HTML that says confirm purchase with a button that says confirm. Now with JavaScript, we can make these things actually do things, which is exciting. In order to do that, we need a way to reference these elements in JavaScript. So typically that's done with an ID. So we can say confirm, and then the button can have an ID. Let's just give it something really creative. Button. So now we should be able to reference these elements using these IDs, confirm and button. So going back to our JavaScript, I'm going to get rid of that alert because it's annoying. I'm going to show you guys the code to get a reference to an ID. You say document dot get element by ID, and then in parentheses you're going to pass a string which has double quotes and the name of the element. So we're going to get button. So that's going to get the element. And then what we want to do is we want to say when we click this button, we want something to happen. So we say dot on click. And in this pop-up window, you can see it's a property. So that's how you know if you need to put the parentheses or not. In this situation, we don't need parentheses. So we're just going to set this equal to something. Basically what we're going to do is we're going to make a function. So when we click this, this function is executed. Basically, we're going to make a section of code so that when you click this, it's executed. And you can do that with a function. And it looks like this. Now inside of this function, what we're going to do is when we click this, we want to get a reference to the confirm purchase text, and we want to change this to say something like order placed, and then we want to get rid of the button. So we can follow a similar pattern of document.get element by ID, then we can pass in the other ID, which was confirm, and we can change this text using the property inner HTML and set that equal to order placed, check email for confirmation, something like that. And then a semicolon at the end. If you don't like the way this scrolls, you guys can turn on word wrap. So if you want to do that, you go to help and type in word wrap. So let's try that. Let's save it and do a refresh. When we click confirm, it says order placed, check email for confirmation. The only issue is this button still is there. So we need to get rid of this button. So what we can do is say document.get element by ID and pass in the button. And then we can use a property called style, which is going to affect the CSS of this thing. This CSS is used to style this stuff. And then we could set the display of this to none, like so. This is going to make the button disappear. So let's do a refresh, confirm. It goes away and it says order placed, check email for confirmation. One thing I did want to show you guys though, back in the index file, I have this script at the bottom. If I wanted to put that at the top here, and let's save this and do a refresh. Now, when I click confirm, nothing's happening. And you can actually see errors by going to the inspect, right-clicking inspect. And I want to get this on the bottom, so I'm going to click these three dots and go to this button right here. Going to the console, you can see we get an error. Cannot set property on click of null. And the reason that's happening is because we're trying to reference that element, this confirm button, before it exists, because our JavaScript code is being executed before we get down to this body section, because this is going to go one line at a time. So it hits our JavaScript file, goes to our JavaScript, starts executing it, tries to grab the button, nothing works because it doesn't exist yet. If you want to fix this, you can leave it at the bottom, or you can throw in a keyword here, defer. Do a refresh and you can see it does work. So the defer keyword allows us to asynchronously, meaning behind the scenes, grab that file. And then once everything is done loading, it's going to execute that file. There's also a keyword async, which is a little bit different because it's going to grab that file and start executing it immediately. It's not going to wait for everything to load, which is not what we want. We want to use defer. So you guys can think of our application as a SPA, a single page application. Very, very limited, but basically we're able to change the content of our page without changing the web address. The web address just stays index.html. And that's what's really cool because we're able to process our page really quickly because we don't have to make a request to any kind of server. You know, if we had to go to like, order and then order processed, well, all these different pages is going to be load time. But with JavaScript, we can do all that behind the scenes. And later on, we could figure out how to make that order button actually place an order behind the scenes using what's known as asynchronous JavaScript. You may hear it as Ajax. I would say that's probably enough information for this video. Hopefully this is everything you needed to get started manipulating HTML and JavaScript. So now that you're a pro manipulator, be sure to check out the next video and also the links in the description. Also guys, please don't forget to subscribe to the channel as that would tremendously help me out. All right, peace out. Hey yo everyone, welcome back. This video is the fourth video in the JavaScript tutorial series. Good job sticking through it so far. We got a lot to learn though, and this is going to cover some of the basics in JavaScript. Let's go back into our JavaScript file and see what we have. This is what we use to manipulate the HTML. That was really just an illustration and we're not going to build off of that, so I'm just going to get rid of this. One of the things we're going to talk about in this video is variables. So a variable allows us to store some data, and this is really important when we want to make dynamic applications. And what do I mean by dynamic? By dynamic, I mean the content of the application is not always the same. If we execute it once, it might be a little bit different than if we execute it again. And this is made possible by things changing, such as variables. The easiest way to see this is by getting user input. So for example, we can get user input by asking them what their name is. And then we could make the app say, "Hello, Caleb." Well, this is going to change depending on what your name is. So that's one way we can make our application dynamic. It's by printing someone's name. So since we're going to be focusing in the JavaScript file, I'm going to be closing this Explorer and Xing out of the index.html. All you got to know is that we're including this JavaScript file over there. So we're going to be using this thing called prompt. And you can see that prompt is an example of a function. A function is something that we can call. It'll execute some stuff or do something for us, and it will usually give us a value back, like the output of the function. So to call a function, we use parentheses. So if I was to just leave it like this, we ran the application, we get a pop-up that says, "This page says," and there's an input here. When we say okay, nothing really happens. In fact, nothing happens at all. That's because we're not using the value that we typed in there. So if we want to use that, we can store it in a variable. And the way we create a variable in JavaScript is by saying the keyword var and then naming it something. So for example, we could name it username. So this is known as the identifier. It's what we call the variable. It's the variable name. And we can assign it a value using the equal sign, which is known as the assignment operator. So what we're going to do is we're going to backspace and see that we're assigning the value of this to username. So this prompt function is going to execute, and whatever the result is going to be assigned to username. That's how that works. So now we can save and refresh. And when we put something in here like Caleb, still nothing happens. And the reason nothing happens is because we're still not doing anything with username. So we could output it or we could do some operations on it. But what I wanted to show you guys is that you can actually use this console inside of Chrome or Firefox or whatever browser you're using, and you can dynamically ask the browser questions. So for example, I could say username. And you can see it says Caleb. So this basically means that there is a variable in existence called username. And this is all going to reset when we do a refresh. So if I refresh this, and let me just cancel that, and now I say username, it says null. So this stuff doesn't persist. It changes every single time we get this web page. As we build more complex JavaScript programs, what's going to happen is we're going to actually connect to a backend, which allows us to save stuff and persist data into a database. But for now, when you're just learning JavaScript, everything is basically going to restart to 0 every time we refresh. There are ways to have local state in JavaScript to where it kind of memorizes who we are or what we're doing, but we're not going to be getting into that right now. So all you need to know is if we do a refresh, we're restarting from square 0. Is that a word? Square 0? Square 0 is similar to square 1, it's just 0 base. All right, so let's cancel this. And what we're going to do is we're actually going to output this name. And you can do that with another function, which is alert. And we just pass in the username. This scenario, we don't actually have to assign anything because alert doesn't return anything. You can see when we hover over it, at the very end, it says :void. That's how we can tell that it doesn't return anything. Void is nothing. If we do that with the prompt, you can see it returns a string, which any sequence of characters is a string. So Caleb is a string. So because this is void, we just call it by itself. Let's save and run. I typed in Caleb and then it alerts Caleb. Now, as you get better at JavaScript, you're going to be better at knowing where to put semicolons and parentheses and curly braces and all these things, but these rules are known as the syntax. Every language has a syntax, which basically defines what's legal and what's not legal. Basically, anytime we have a statement, which is when we tell the computer to do something, we end that with a semicolon. Now, you should also know about white space, which is just spaces or tabs or new lines. These are okay, and in general, JavaScript is white case insensitive. So we do a refresh, and it still works just the same. That means you're allowed to be pretty flexible in how you type things as long as you don't break up a keyword into multiple words. Like this is not okay. See, we get an error. But basically everything else is okay. So we can space this out however we like. That being said, no one really spaces stuff out like this. We follow conventions, which are things people have agreed upon. So I'm going to try and help teach you the JavaScript conventions, what's common, what people use in the industry. And let me tell you, it's definitely not this. So let's go back to how we had it. There we go. Like I said, you'll pick up on the syntax rules over time, but I'll try to call out anything important. Next thing, you should know how to do a console log. So a console log is similar to the alert in that it will tell us something, but it's less annoying because the alert pops up and you can't do anything until you click it. And that's like basically a virus. So we don't want to do that. At least not for testing stuff, just because it gets really old. So instead we can do console.log. And then inside of the parentheses, we can just put the same thing. So I'm going to get rid of this alert. And now I'm going to run it. Put in a name. And it's actually going to output our name down here, right here, Caleb. Last thing I want to talk about is comments. You can create a comment which is ignored using this double /. This is really important. So you can call things out or clarify things using comments. You can also make a multi-line comment using a /*, and then ending it with an asterisk /. So this is not going to affect how our application runs. It's going to work exactly the same way. This should give you a pretty good basic understanding of JavaScript. We learned what a function was, we learned about whitespace, we learned about comments, and we learned about variables. Pretty good start. Thanks guys for watching. Please be sure to subscribe. If you like this content, that would really help me out. Also check out the description for some useful links, and I'll see you in the next video. Hey everyone, welcome back to your JavaScript tutorial series. This video, we're going to be talking a little bit about web application architectures. Now, it's not going to be too crazy. I'm not going to whip out no architectural diagrams or anything crazy. I just want to give you guys enough to really understand where JavaScript fits in to the developer ecosystem. What we've been building so far is the application front end. So if you go to your web browser and look at this file // blah, 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 blah. And we're literally just opening a file on our local computer. We're not using a web server. Sometimes when you're developing, you'll see something like localhost. And the way that works is you're feeding your files through a web server. And it's basically simulating the environment you would get when you go to a website. So for example, when I go to calebcurry.com, I am making a request to a web server. So when you go to this website, you're making a request to a server. And the server is basically listening for incoming requests. And when it gets a request, it sends a bunch of files down to the client. We're the client here, because we're requesting this content. All of the stuff we're seeing here is part of the front end. The back end is what's responsible for communicating with the database. So I can't just go to this website and start editing blogs and deleting stuff, not without some server-side processing. So consider the server like this gatekeeper between the front-end pretty content stuff and the very serious database stuff. The back-end can be programmed in basically anything. This is PHP. If I was to build an app from scratch, I would consider JavaScript. You could also use something like C#. Whatever it is, it doesn't really matter. All you need to know is that that is definitely different than the front end. The front end consists of JavaScript, HTML, and CSS, and I like to tinker around using this inspect capability. One thing that's super important to know is that all of the stuff on the front end is not secure. It's completely accessible to the user. All of it is visible right here. All the code, boom, right here. See these scripts? Yeah, you can right click, open a new tab. Look at that, bunch of scripts. So you definitely don't want to be storing anything secure in JavaScript. The other thing is that everything is editable. So for example, I can go to this email address button, I can inspect that, and it comes up right here. And you can see there's this attribute type equals text. I could go in here and change it to password, for example. And now all of our content is supposedly hidden. So when you're typing in passwords into websites, it's really just a mask. It's to protect people from seeing your password who are looking over your shoulder. But don't trust any of the front end content to protect something sensitive, because you can see it's all editable. So the overview of the structure is there's the database. The database is going to store all of the data for our application. So user accounts, transactions, profile settings, chat logs, whatever you might want to store is going to go in the database. The backend is going to take requests from people going to the website and get certain things from the database and act as a gatekeeper between the two. The front end is where the users see things and are able to interact with your website. When you request a website, a bunch of stuff gets sent down from the server. So if you click this network tab and do a refresh, you can see basically the entire process of how a web application is downloaded. And you can see there's a lot of stuff. And this is the biggest thing that slows down websites, is just downloading the information. And as a result, a lot of stuff is done to improve the speed of download. For example, you can minify or uglyify your code, which basically takes a bunch of JavaScript and condenses it down as much as possible by shrinking variable names, getting rid of white space, and then you basically get this jargled mess that no one can really read, but it still does the same stuff. So if you wanted to start a web app, a common way to do this is through a software as a service kind of system. So what is software as a service? Basically, if you go to a website and you sign up and you're paying like a monthly fee to access their content and their website, that is software as a service. And typically this is going to be stored on some kind of platform that offers hosting for these websites. So some of the most common ones are AWS or Amazon Web Services. There's Microsoft Azure, there's the IBM Cloud, and a variety of other ones out there. This is if you really need fine-tuning of your website and a lot of other capabilities. Sometimes it's cool just to go to a really simple shared hosting platform like Bluehost. This you can pay a couple bucks a month and you get a PHP website up and running. What you choose is up to you, but right now in the series, I'm not really interested in talking about deploying an application. I just want to start getting applications written. So that's all I got for this video. Hopefully that was a good introduction to the server client structure. And in the next video, we're going to be going into some more JavaScript concepts. So be sure to check it out and please be sure to subscribe. Hey everyone, welcome back. This video, we're going to be talking about JavaScript variables, just the basics here, just to get a better understanding. We created a variable in the previous videos. You can see we got user input using this prompt, and this is a good way to get user input for now. But honestly, the prompts are really super annoying. So hopefully eventually we're going to be able to make a more pretty, less obnoxious way of asking people for information, such as a form on the web page or a nice modal that doesn't disrupt the page. Because like right now, if you refresh this page, like it's just like go away. It's like a virus, man. But anyways, it's a good way to start getting information and just being able to practice working with data. So for example, we can get a username like this. This is an example of a variable. In JavaScript is known as a dynamically typed programming language because the variables are not given data types. So we're going to get into data types soon, but basically it's a way to classify different data. So we've talked a little bit about strings, but there's also numbers and there's objects, and many other programming languages will require you to put that up front. So you might say something like int, but JavaScript does not work that way. This means you can assign anything to a variable, and then later you can assign it a different type. So for example, this is going to be a string. Well, then later on, I could say, hey, username is now a number. And that's totally legal because JavaScript doesn't restrict a variable to a specific type. This also shows that you can reassign to a variable. It's not a permanent thing. You can do this as many times as you want. And you can see we're not getting any errors. Once again, this equal sign is known as the assignment operator, and it basically takes anything on the right and assigns it to that variable username. So username now refers to hello. And one of the huge benefits of variables, well, we talked about one, it allows our application to be dynamic because we can get user input and we can just make things change on each execution. But another thing is it makes coding a lot easier because we can reference this name throughout our program. So for example, if we had a variable age and it had the value 5, well, we might want to print this 3 times. So we might say console.log, and what we might think is, oh, we just have to put the 5 in there 3 times. But now let's say I want to change this to 6. Well, now it's like, oh, I got to go in here and change 3 occurrences. That is like, whew, my hands are getting tired. So instead, what we can do is we could assign it to a variable and we can use that variable in our code. So anywhere that was expecting that value, we can replace it with a variable. This will just make our life a lot easier and reduce bugs. It makes our code more general, so it works with multiple cases. Because previously, these console logs only worked with the age 5 or 6. But now we can go in here, we can change age to whatever we want, and the code is going to work just fine. Here, I'm going to get rid of that prompt. It's so annoying. All right, see, it prints 50 3 times. Now, when you create a variable, it's actually a 2-step process. So let me just clean this up a little bit. Let's say we have age again, and we set it equal to 50. Well, this is actually 2 steps in one. There's a declaration and then there is an initialization. So if we wanted to break this up into their individual steps, it would look like this. So we create age. This is the declaration. We're declaring that age exists, and then we're initializing or assigning a value of 50 to age. So it's 2 steps, and when you put it on one line, it's just doing both at once. Sometimes you might know that you're going to use a variable in the future, you just don't have a value for it. So in that situation, you might just declare it, but you might not actually initialize it with a value, and that's totally fine. The important thing to know is that until you initialize it, it's going to have the value undefined. So if I comment this out, do a little refresh over here, I type in age, it says undefined. If we were to go in here and type a variable that doesn't exist, it's going to give us an error. So this undefined only happens if the variable has been declared, but it hasn't yet been initialized. The other thing you should know about is that you can assign to variables using other variables. So let's see an example of that. Let's create a new age. And this is just some casing things. This is called camel case, where the first word is lowercase, and then any other whole word is starting with an uppercase. That is how you should probably tend to create your variable names. And what we're going to do is we're going to assign this age. I'm going to put these a little closer together. Now I want to go over here, do a refresh, and let's just work with these a little bit. If we print the value age, we get 50. If we print new age, we also get 50. So what happens if we assign age a different number? Now the question I have here, is this also going to update new age? Well, let's see. When we type out new age, it's still 50. So doing this assignment like this makes a copy of the value, meaning these 2 variables store their own data and they're not connected in any way. Once we get into more complex JavaScript and we're working with objects, this can get a little funky. Sometimes we can have variables pointing to the same data, the same object, but in the situation of numbers, it's always going to make a copy. The next thing I wanted to talk about is an expression. So when we do some complicated stuff that ultimately evaluates to a value, this is known as an expression. For example, we can go down here and we can create a variable called message. And this is inside of a string, so we're not doing an assignment. We are just printing this value later on. And then we could use a plus sign and say new age. So what's going to happen is it's going to print this string new age equals, and then it's going to print the value of new age. Well, this is an example of an expression. It ultimately evaluates to one string, one individual value. So you could go in here and type in message over here, or you can console log it. You'll probably see me do a little bit of both throughout the series. So when we console log this thing and do a refresh, we get new age equals 50. So this is a string. It's one individual value. So you can literally think of it as new age equals 50. So that's an example of an expression. It evaluates to a value. We're going to be using expressions all throughout this series. Now that we're done with expressions, we can move on to something else. And let me tell you, I cannot express how thankful I am for you guys watching this series. Hopefully so far it's been a good level of enticing, but not too overwhelming, but also not like, wow, this is super simple. I'd say we're starting off pretty beginner, but it's going to get pretty intense here pretty soon. But we'll keep it simple, don't worry. So thanks guys, please be sure to check out the links in the description and consider subscribing if you've enjoyed the series. I'll see you in the next one. Yo, what's up everyone? This video is actually going to be extremely important to understanding JavaScript. We're going to be talking about global variables and how those work. This is really important to understand if you're going to make scalable JavaScript applications, and it's actually a really common mistake for beginners. Something that's definitely tripped me up as I was learning, but now I got it down pretty good, so hopefully you can pick up my understanding just by diffusion of watching this video. But I definitely recommend that you get some practice in by typing out the things I type in this video. So we're going to be working in the console in this video, and whenever we need to clear it, you can press this little stop button, and you can zoom in by either holding Control plus or Command plus if you're on Mac, or out using the minus sign. So what we're going to be doing is we're going to be using this console as like a dynamic application experiment tester thingy, a REPL basically. So I mentioned this in an earlier video, a read eval print loop. Basically we can tell JavaScript we want to do something, it's going to evaluate it, it's going to print out the result, then it's just going to keep looping and letting us work with this dynamically. So for example, we can create a variable age and set that equal to 5. Don't worry about this undefined. It's going to print undefined when there's no return value. So for example, if I do something like prompt, whoops, I got a little typo. Plus this is way too big, I'm zooming out. So if I do prompt and I type in a value, you can see the return value is Caleb. Assigning to a variable doesn't return anything, so it's just going to say undefined. You'll notice when we create variables, we use this var keyword, and this is going to become very important later on. So right now, we can create a variable without that var keyword. So for example, here's how many dogs I have. That works fine. It doesn't make a difference whether we use that var or no var right now, because in the context we're in, it's going to do the same thing. But later on, once we start working inside of functions, this is going to be a very serious thing, and you definitely want to understand what's going on here. So when we create a variable, that variable gets attached to something called the window object. So I can say window, and you can see one of the things in here is our variable age we created. You can also scroll down and find dogs, 30. So this window variable is also known as the global scope. This can be accessed anywhere in our code. Everything we use that's important to us is going to be attached to this window object. But we're not always going to want to use this window object. The reason we don't want to do that is because anytime we create a variable such as dogs or age and we attach it to that window object, well, since everything has access to this window object, different files or different parts of our JavaScript file can conflict with our variables and basically overwrite the content of our variables. So these naming conflicts are a very serious issue, so we don't want to make any variables inside of the global scope. So how do we avoid the global scope? Well, we actually have to put our code inside of a function. And then when we create a variable, it's in a new scope, and it's not going to be on this window object. So I'm going to show you guys how to do that now. And we are going to get into more depth on how to create functions and how they work later on. This is kind of like one of those foundational things that you got to do, and it's important to understand, but you don't necessarily have to understand all of the details. So I'm just going to delete everything here. And the way we create a function is we use the function keyword and then put parentheses. The next thing we do is we put curly braces, and then we put all of our code inside of these curly braces. After the curly braces, we put another set of parentheses and then a semicolon. So yeah, talk about some syntax for real. But guess what? We're not even done yet. The other thing we need to do is we need to wrap, this is crazy, the function all the way past the curly braces with parentheses. This is the structure to make something known as an IFI, which stands for immediately invoked function expression. Once again, don't freak out if you don't understand all this. Most important thing you need to know is that if you put your code inside of this function, you should be safe. So in here, I could say var age equals 5. When I come over to our browser and refresh and try to access age, it's like, what is age? I can't find age. The reason that's happening is because this function's executing and then it's done and then age goes out of scope and it's no longer accessible. What that means is there's not going to be any conflicts with our naming. So when we go into the window object, there's not going to be anything in here called age. Age is only going to exist inside of this function. So if we basically put everything inside of this function, it's going to work exactly the same way, but we're also going to protect our variables. But this is where that var keyword comes in, because if we forget to put this var, it's going to basically look inside of this function and see that, oh, age was never defined. So then it goes up one scope and looks there. And we're only one scope deep. We could have nested scope. So what that means is it's basically going to go up the scope chain and not find age anywhere. So it's just going to define it automatically on the window object. So now if I do a refresh, and I say age, well, hey, it exists and it says it's 5. So basically we defeat the whole purpose of doing this IFI, because then we're assigning our variables on the window object. We're making them global. What are we doing? So you definitely want to make sure you put that var keyword in. This is really closely tied to functions and variable scope. We're going to get into all of that in this series, but for now, know that once you're building serious applications, you're going to want to encapsulate all your code within a function. I might not use this IFI throughout the entire series because I really like being able to test our variables over here. It's really just important if we're worried about our variable scope and global variables. So key takeaways: when you don't use the var keyword, age is created as a property of the window object, which is global. So when declaring variables, make sure you put the var keyword if you don't want it to be global. That's all I got for you guys. Hopefully that was helpful. Once again, please consider subscribing and please check out the links in the description if you want some extra goodies. Thanks guys, peace out. What's cracking everybody? I am back in my classic studio, but my parents put this giant thing in front of it, so I just decided, hey, I'm just gonna talk this video. I wanted to do an on-screen video, but a lot of the stuff I wanted to talk about really has nothing to show. So instead of just making, oh yep, there's my dog Onyx just chilling. Say hi. Okay. I wanted to use a tripod too, but I don't have one with me, so I'm failing, I know. Let's talk a little bit more about JavaScript engines and environments. One of the problems with JavaScript that people have is they take on JavaScript and they realize the syntax, the structure, and where you put semicolons and stuff is very similar to other languages. So if you guys are coming from a different language, you might look at JavaScript and be like, oh, I know how this works. But the problem is you don't, because it's fundamentally different. It's fairly easy to pick up JavaScript and how it works, but if you just dive in expecting it to work exactly the same as Java or C# or something, it's not. And one of the differences is just how we execute things. Like I said in previous videos, JavaScript doesn't require us to install anything. And there's a lot of confusion on whether JavaScript is a compiled language or an interpreted language, and some of these things we're going to talk about today. You will often hear the term engine thrown around without really explaining what it is. Well, the engine is what takes our code and executes that. So it's what makes it possible for us to make human-readable code that works on a computer that doesn't understand anything. One of the challenges with JavaScript though is that there are numerous engines. There's not just one. So for example, there is V8, which is Google Chrome's engine. There's SpiderMonkey, which is Firefox's. There's Chakra, which is Microsoft Edge. And then there's also one for Safari, I forget. Nitro, I just looked it up. So one of the immediate challenges you're going to get with JavaScript is differences between these engines. How does one of these engines decide how to execute your code? Well, there is a standard, a basis that these engines follow so they know how to interpret your code. And this standard is known as ECMAScript, or ES. A lot of people say ECMAScript sounds like a skin disease, so a lot of people just say ES. So ECMAScript is just a standard, and JavaScript is an implementation of this standard. So the browsers that want to run our JavaScript code can use ECMAScript as the basis for how to interpret the code and how to execute it. So what happens when we type this, for example? It might look something like this. We have one thing of code, and what happens is we need to execute this on numerous browsers. So this one might be Google Chrome, this might be Edge, this might be Firefox, and Safari, for example. And this is our JavaScript code. Well, in order for these to interpret our code in some kind of consistency, they're all based on a standard known as ECMAScript. Boom, yeah, my handwriting has not improved. So if these browsers are trying to adhere to some standard, oh, it's Kavi! Hi! So yeah, this is probably the worst video you guys have ever seen. But if these browsers are trying to adhere to some standard, then there has to be some kind of way to measure how close they are to matching the standard perfectly, right? So like, let's say Google Chrome is really good, but I don't know, Internet Explorer is terrible. How can we quantify that? Well, there's this test that can be used to quantify how much these different, ooh, I can point to them, these different engines adhere to the standard. And this test is called Test 262. I know, really creative name, right? And the company, or the thing that made this test is called TC39, because these people are really good at naming things. Honestly, those names aren't that important and you could probably forget them. Honestly, I literally just looked because I couldn't remember. But what I'm trying to say is that this will give a percentage amount of how much these different engines follow the ECMAScript standard. But what I'm trying to say is that this will give a percentage amount of how much the engines follow the ECMAScript standard. And you can find this on Wikipedia. I'll end up showing you guys later on in this series. So these engines are part of the web browsers. So you can think of it like this. This is a web browser. And inside of this web browser, one piece of it is the JavaScript engine. This is what processes our code and basically makes our code do something in the browser. That browser is known as the environment. So there's an engine and then there's an environment. In other languages, you might hear the JRE, Java Runtime Environment, or CLR, Common Language Runtime. These are basically the environment or where our code is being executed. So the engine is part of that environment. But in theory, we should be able to take that engine, that core piece, and put that inside of a different environment, so no longer a web browser. And people have done that. And this is basically the birth of Node.js. This is what happened. So Node.js is a way to process JavaScript on the server side. So far, we've been processing all of our JavaScript inside of a browser. That's the environment we've been using. But in theory, we should be able to take this engine and put it somewhere else. So for example, we could have this inside of the backend server. And that is what Node.js did. So it used the Google V8 engine to basically allow us to process JavaScript, but no longer in the browser environment, but on a server environment. Yeah, basically a bunch of fancy words just to show you guys that JavaScript can be processed in different locations, and this makes it very versatile. The thing that processes it is the engine, the location is the environment. So a web browser or a backend server. Now the next question is Java compiled or interpreted? Well, if you guys don't know what that means, basically there are two categories of programming languages. This is one way you can categorize languages. Compiled, you take all your code and you compile it, meaning you transform it to something the computer can understand. And it's a one-time, you type it or click compile, and it will give you an object file or an executable that can be ran. The other side is interpreted, which will basically keep the source code, and when you run it, it's going to go through that source code line by line as you're running it. When you're first starting, it's not super important to understand which is which and why, as long as you write code and it works. That's really what matters as a beginner, but it is important to know as we get into some more advanced stuff. A lot of people think JavaScript is interpreted, but it's actually more likely to be compiled. And the reason that is because of the engines. Let's say we download some JavaScript code from a server and it goes to our engine. The engine could try to compile the JavaScript and then just have an executable, or it could run it line by line. And I'd say it's more towards the compiling part, and it's actually something known as JIT, just-in-time compilation. And basically what this means is that the source code will be available, and right when we need to start executing it, it'll be compiled and then executed. This can help improve performance and kind of make it act like an interpreted language, but it's really being compiled. And this would explain why sometimes in JavaScript, before you start even executing your code, you might get errors in the browser because it's being compiled and it notices some issues. But the real important thing to know before you guys argue with me and say that, oh no, JavaScript's interpreted, or oh no, it's completely compiled, or whatever, this is an implementation detail. And what that means is that this whole concept is tied with a specific engine. So if we go back up to our engine list, this engine could compile, this engine could interpret, this one could do just-in-time compilation, and this one could do who knows what, I don't know. Meaning, when we write JavaScript, we can't rely on this side to be doing a certain thing. We don't know if it's going to be interpreted or compiled or whatever. All we know is we need to execute our code, and the engine is going to do something with that code. So when your friends ask you if it's compiled or interpreted, just tell them it's an implementation detail, and it's completely dependent on the engine, and the engine can decide how to do whatever it wants to do. So this is the first time I've done a video quite like this. Hopefully it wasn't too terrible. Curious what it's going to look like after editing it. But thank you guys for watching. If you've enjoyed the content, really appreciate it. And don't forget to subscribe. I'll see you guys in the next video where we're going to do one more video like this, and then we'll get back into some hands-on stuff. So thanks guys, I'll see you then. Welcome back everyone. In this video we're going to be talking more in person. If you didn't see the last one, I'm in a little bit of a transition and don't have a tripod, and there's a bunch of junk in front of my chalkboard and I didn't feel like moving it, so. Alright, let's get started. Let's just talk a little bit more about variables. I know we've done it, but I wanted to talk a little bit more about global versus local variables and some various ways to create variables. First thing I wanted to mention is that we're going to be talking about some stuff that is in newer versions of ECMAScript, sorry. And what that means is because all of the job of processing our JavaScript is basically outsourced to these different browsers and different engine versions, we can't fully trust all of the browsers to know how our code works. What do I mean by that exactly? Well, if you write some code and expect it to work on an old version of Internet Explorer or even the newest version of Internet Explorer, it's probably not going to work. You need to keep this in mind, and there's tools to let you write newer JavaScript, and it will basically transpile that down to older JavaScript. We might get into that tool later on in the series, but right now, what we're going to be talking about isn't super cutting edge, and most of the modern browsers support it, so you should be good. So the first thing we need to talk about is when you create a variable using the var keyword, it creates that variable in the scope, the function scope that it's defined in. For example, I have this very important function defined right here, and if we say something like var x, well, that means outside here, x is not going to exist. If we don't use that var keyword, it's basically going to go up to see if we're in a nested function and check there. And it's going to keep doing that until we get to the global scope. And we talked about this in a previous video, so hopefully you guys have a pretty good understanding of how this works. Eventually, we're going to get to the global scope, which is the window object. So when we create a global variable, it's basically a property on this window object. You'll understand more about properties once we talk about object-oriented programming, but for now, basically know we're just creating a variable that's accessible anywhere. For serious production apps, you probably want to make sure you leave that var in there and try to define your variables inside of functions. But just for playing around, I like to just leave them in the JavaScript file plain as is, because if it's not in a function and you use var, it's still going to be attached to window. And when you put it on window, it's really easy to use browser developer tools as a REPL, which we talked about that. Basically, we can evaluate our variables, we can change them, all while still executing our program. There are two other ways to create variables that I wanted to talk about, and that is using the keywords let and const. This is let, not lef. Okay, so the other two ways are let and const. These are part of the newer JavaScript versions, and what these do is they allow us to create block level variables. So we created a function level variable, which is how variables work by default in JavaScript. They're tied to the scope of that function inside those curly braces. Right there and there. In other languages though, if you had like an if statement, we're going to talk about those soon, and you created something inside of that if statement curly brace, it would only exist inside of that block. For example, and just ignore the fact that this really doesn't make any sense, if we put code here using the var, it's still going to look up to see if it's in any other functions. But if we use the keyword let, it's just going to define it between these curly braces. And that's the primary difference. And the reason I didn't want to do a hands-on video to explain this is because I just wanted to talk to you guys just to give you guys an overview of all the different ways to create variables. And I think sometimes when you just go in and start typing stuff, you don't really process why or what behind the scenes, and you get confused. I get confused anyways easily. So I figured, hey, let's just talk about the concept, and then when we use it later on, it'll make more sense. So let is going to create a block level scope, and same for const. The only difference is that with const, and we would want to use that in here as well, it will not let you change the value. So if you have a variable that you won't want to change between the curly braces, you'll want to use the const keyword. These make it a lot easier to protect our variables without having to always make complicated functions. You can just use block level scoping. And we're going to get into that a lot more in future videos, but just wanted to talk a little bit about the concept. So just to review, there are 4 ways to create a variable in JavaScript. 1, just putting the name of the variable. Onyx, you be quiet now. Put the name of the variable and you set it equal to something. That'll automatically go up the scope chain, basically nested functions, until it finds that variable, and if it doesn't, it'll create a global variable on the window object. Second way is using the var keyword, and that's going to create the variable inside of the function you're in. If you're not inside of a function, if you're just on an empty JavaScript file, it's also going to put it on the window object. Third is with let. That's going to make a block level scope so we can define variables inside of if statements, for example, and they are not going to be accessible outside of the if statement. The fourth is const. Very similar to let, it's just not going to let you change the value. So hopefully that gives you guys a good intro to the concept of creating variables inside of JavaScript. With that, we're going to go back onto the computer, get some more hands-on coding, and move along. All right, thanks guys. If you've enjoyed this content, please be sure to subscribe.
So let's check out our sponsor.
Hey guys, welcome back everyone. In this video, we are going to continue our talk on creating variables. In previous videos, we talked about this iffy, immediately invoked function expression. And now I'm going to be talking about basically a potential replacement for this iffy, and something you're probably going to see in some newer JavaScript. Up until this point, we've used var to create variables, and in the previous video, I talked about let and const, and these are going to come up a lot in newer JavaScript. But first, let's talk about why we're using an iffy. If you guys remember, whenever we create a variable outside of a function, such as y, well, this is attached to the window object. So if I do a refresh, and I type in window.y, you can see it gives us the value 10. What this means for us is that our variables that are created outside of any functions are accessible globally. This means we're basically polluting the global variables and adding new variables that people can easily replace. Definitely not something we want to do if we're building complex applications or using different frameworks or libraries that might already have variables with the same name as the ones we have. Because of that, the pattern of the iffy was created. And essentially we encapsulate all of our code in one giant function. So that means when we go down here and try to access age, well, age doesn't even exist, because we go through here, we execute that function, we're outside of the function, we assign a value to y, and then we try to get the value of age. Well, we're outside of that function now, and it's already been executed, age no longer exists. So that is a good solution, and that is a great way to prevent global variables, but since I introduced you guys to let and const, there may actually be a better way. Once we deep dive into variable scoping, we'll definitely get into this some more, but for the basics, you need to understand that when we say let y equals 10, it works basically the same way. So we're creating a variable that is in the global scope. It's not going to be attached to the window object, so if we refresh and say window.y, it doesn't exist, but it is still defined in the global scope. And here's a good Stack Overflow question if you want to get all the details on that. But basically the conclusion is that both are still global, but vars is stored in window and lets are stored in a declarative environment. And he explains what all that is up here. But essentially what this means is that when we say let y equals 10, it's basically the same as doing var y equals 10. They're both accessible globally, and it still introduces the same issues. But the benefit of using let is that we can use block scoping. So a block is any time we have a set of curly braces like so. Here is an example of a block. So similar to how this function has a block, well, we can create a block anywhere, and we'll often see those with if statements. When we get into those, you'll see a block like so, and you'll see them lots of other places. Block level scoping essentially restricts our variable to just this block. So now if we say let y equals 10, and if we do y, nothing. You know, it's not there. Similar to the iffy. So in newer JavaScript content, you're probably just going to see these blocks, and all of the variables are going to be created with let or const. The variables can still be used, but only inside of this block. So if we wanted to print the values, we could do it like so. Now when we do a refresh, we get 10 and 20. That basically sums up the use of let and const and how it can be beneficial to us. But you know, just for fun, why don't we just see what happens when we use var? So let's say var z equals 100. Well, var is not restricted by the bounds of this block. It always looks for a function block. And you can see we're not in a function. We're just in a normal block. So this is actually going to be just like creating it outside of this block. So that means we should be able to access it on the window object. And you can see window.z is 100. So using blocks and then continuing to use the var keyword completely defeats the purpose of blocks. Typically what you'll see is maybe some older JavaScript applications will use the iffy and lots of vars, and then newer applications are going to use curly braces as a block using let and const. Either one you use, it's totally up to you, but I would probably recommend let and const, as this is a more restrictive, I guess might be the word, way of creating variables, in that you're only creating variables in the area that you need them. We haven't really talked about much scoping rules, but understand that we can nest blocks just like we can nest functions, and we'll get into that later on in the series. But this means when we create a variable in here, let's say let y equal 6, and what we're going to do is we're going to console log y in here, and then we're going to console log it out here too. And let's do a refresh. You can see we get the value 6, and then we get the value 10. So we're creating this inside of a different block, which masks that other y. So we're kind of going in the depths of variable scoping and masking and all that stuff. We're going to get into that in the future, but now the main thing I wanted to show you guys in this video is an alternative to the immediately invoked function expression, which is honestly very verbose and kind of makes me feel gross. So thank you guys for watching. If you've enjoyed this content, please check out the sponsor because that would really help me out. And please check out the next video and don't forget to subscribe. Thank you guys. I'll see you in the next one. Yo, what's up everyone? Welcome back. This video, we're going to dive into JavaScript data types. And let me tell you, this is going to be a lot of fun. With that, let's dive in. We're going to be talking about data types. And no, I don't want to update. Since we got rid of that boring iffy, we're going to be using these blocks to create variables. Throughout the series, I might just get rid of the blocks if I want to work with stuff interactively inside of the console in Chrome or whatever browser you're using. But for now, I'm going to be using the blocks here. First thing that you need to understand with JavaScript is that there are two main categories of data types. And let me tell you guys, anytime I can categorize things, I try to because it helps you memorize and understand. The two categories are primitive types and objects. We're going to be starting with the primitive types and learn all about them, how they work, and their differences between objects. This video is going to introduce you to the data types, and then the upcoming videos we're going to be talking about how to use them in a lot of depth and doing some cool stuff that you might need to use in your future career. When we create a variable, such as x, we give it a value, and we don't have to say what type of variable this is. In JavaScript, variables do not have types because it's a dynamically typed language. This is in contrast to a statically typed language, and I've talked to you guys about this before. Hopefully it's nothing new if you've been watching this series, but basically this is in contrast to some other languages where you might have to say something like int x equals 5 or 10 or whatever it may be. In the situation where you're in a statically typed language and you have to define that type, you couldn't do something like say x is equal to hello. This would give us an error in those languages because we're assigning a string to an integer variable. That whole concept does not exist in JavaScript, meaning we can assign anything to our variables. So right now, this is a number. But later on, I could say, hey, today, I want this to be a string. You need to understand data types in JavaScript because if you don't, you can get some weird issues. For example, there's something called coercion. Basically what this means is that JavaScript will convert between data types behind the scenes. So for example, I could create another variable, let b be assigned the value, I don't know, 10. All right, and let's get rid of this string assignment here. Okay, so right now these are both numbers, but let's say we made b a string with the value 10. And now let's say we wanted to add these together, so we could say x is equal to x plus b. When we console log this, we do a refresh, we get 510, which is odd. In other languages, you might get an error because you can't implicitly add a number with a string. In JavaScript, the number will just be converted to a string, and we're basically just going to concatenate them or append them one right after the other. So we get the value 5 followed by the value 10. So it's not doing arithmetic, it's doing concatenation. Some people don't really like the fact that you don't define the data type of the variables. They believe, hey, it makes it not as structured, it makes it not as secure, it makes it easier to make mistakes. Whether that's true or not is totally up to you. I think that comes down to opinion and experience, what you're used to. As a result, there are tools out there that will allow you to basically create JavaScript in a statically typed manner. So for example, there's something known as TypeScript. And TypeScript is a superset of JavaScript, meaning part of the language is JavaScript and then there's some other stuff added into it. And what this will do is it will allow you to give types to your variables, and it's going to transpile that, converting it to plain JavaScript. So if you want the protection of variable types in your JavaScript, check out TypeScript. It might be something interesting to you. But enough about that junk. Let's dive into the data types. Here on the JavaScript documentation, you can see that there are 6 primitive types: string, number, boolean, null, undefined, and symbol. Symbol is new. I'm not going to talk about that. You can find videos on it, I'm sure, if you want, but it's not going to be useful for us anytime soon. So we're going to be talking about the first 5 here and understand what they are. Let's talk about the easiest one first, boolean. This is just a true or false value. Simple as that. So if you wanted to create a boolean, you would just use the value true, no quotes, or false, no quotes. A string is a sequence of characters, where a character is an individual letter. In some languages, when you create a string, you have to use double quotes, but in JavaScript you can use double or single. For example, I could say let my name and assign that a value of Caleb. See, there's double quotes here, but if I use single quotes, this works exactly the same way and we're not going to get any issues. Now back to the data types, we have number, and this is one of the first one we're going to talk about in depth, so we'll just hold off on that, but basically it's just a number without quotes. You've seen it in this series. Now let's talk a little bit about null and undefined, because this can be a little bit confusing. So when we create a variable, let me get rid of this block here. And let's say we create a variable tacos, and we're not going to initialize it with anything. So all we have right now is just a declared variable named tacos. And when we go over here and we say tacos, we get the value undefined. You'll usually see undefined when the variable hasn't been used and there's nothing for it yet. Undefined basically means nothing. And there's a very similar data type called null, but the usage is a little bit different. So for example, we can assign the value null to this variable. Now, when we go to tacos, we get null. It means basically the same thing, but usually null is used when we want to explicitly say tacos has an absence of a value. Undefined, on the other hand, is given by default, meaning we haven't assigned to the variable. So usually let the computer use undefined and we can use null. That's the primary difference. You'll also see in the docs that primitives are immutable. This basically means they can't be altered. So when you reassign to a variable, you're basically throwing out the old value and giving it a new value. Sometimes it might appear like a value that is a primitive is changing, but they're immutable and they cannot change. This is in contrast to objects, arrays, and functions, which can be altered, and those are what we're going to be talking about now. So the other classification of data types are objects. So an array is an object, and a function is an object. So it's kind of like this container that fits everything else that's not a primitive. Let's create an object just to see how it works. So we might say let person equals, and then we use these curly braces. So an object is just a collection of key value pairs. For example, we can give this person a name. We can say his name's Caleb, and then we put a comma. We can give him an age, and we can say his age is 93. I have a young voice, and we can give this person a favorite food. So these are the keys, and these are the values. This is the basic structure of an object, and it's very simple to create objects inside of JavaScript if you basically just want to group variables together. Because in theory, we could have made 3 different variables. We could have said let name be Caleb, age be 93, and fave food be pizza, obviously. But then we have to keep track of all 3 of those variables. It doesn't really allow for scalable applications, and we really just need to encapsulate all of our stuff inside of objects for our sanity. The things inside of the objects can have lots of names. I'll call them by properties. So name is a property, and that's what this editor says here, property. But you might hear them as members, which is a little bit more general. You might hear them as fields occasionally, which are usually private properties, and we'll talk about that later. But in general, most of the time you're going to hear the term property. Inside of an object, you can even have functions. So if I wanted, I could create a function in here that will, I don't know, say yay. So in order to access the members or the properties of the person outside here, we could say person dot fun and then call it. And then when we do a refresh, we get yay. So that's fun. When we create a function inside of an object, it is technically kind of a property, but you'll often hear it known as a method. So this here is a method, and we've talked about methods. A lot of things we've used have methods on them, and methods are unique to objects. So the primitives don't have methods. We're going to dive in a lot more depth on objects, but now just get a good feel for how they work. We give basically key value pairs. The one on the left always has no quotes. The right could have quotes if it's a string or just a value like 93. It can even be a function. And just to review, you could say all of the stuff are the members of the object, or you could say, hey, these are the properties and this is the method. You'll get more familiar with the language as we go on, so don't be uptight if you don't have all that down perfectly. But just so you know, you can access the members of an object using the dot operator. So you put the name of the object and then you say dot and then you put the member name. If it's a method, you have to use parentheses. If it's a property, you don't use parentheses. So in this example, you can access the age like so. and you could print that or you could add to it, whatever it may be. There are other types of objects that we don't necessarily have to define every single thing by ourselves. So for example, if we get rid of all this, we could create a date by doing let now be new date. This is going to create a date object, and you can see now is a date. Over here you can see what that looks like. We also have arrays. Arrays allow us to store multiple values, like so. And you can also output that. You can see the value of grades. The thing I want to emphasize is that all of these more complex things we've created are all objects. If it's not one of the 6 primitive types, it is an object. The reason it's an object is because of what's known as the prototype chain. And this is basically JavaScript inheritance, which is basically a fancy word of saying, where in the world does this array come from? Oh, it comes from an object. And you can see that inside of the browser. If you expand grades as an example, you can see this proto property, which is an array, and then if you scroll down some more, proto object. So this thing ultimately inherits from object. So even though it's an array, it's also an object. Everything ultimately sources from object. So that is your introduction to primitives and objects. In the next video, we're going to go in a little bit more depth between some of the differences and just feeling them out, getting some more info, because right now we have a pretty good basic understanding, but I want to make sure you guys have a pretty solid understanding. So please check out that video and please be sure to subscribe. Hey everyone, welcome back. It is Caleb. In this video, we're going to be talking about some of the differences between primitives and objects. Okay, so what is the difference between a primitive and an object? First thing, which I mentioned in the previous video, is that primitives are immutable. So that means when we do something like x equals 10 and then x is actually 5, it's 5, well, it's basically throwing out the value 10 and giving it a new value 5. Even with strings, what this means is that if we're doing some kind of function to alter a string, it's not really altering the string, it's just throwing the old one out and giving you a new string of the new value. Pretty simple concept, but also pretty important to understand. Why exactly is this important to understand? Well, a lot of the methods we use in JavaScript that work on primitives are going to return a new primitive. For example, let's say we have let my name be Caleb. And we say my name dot to uppercase. Well, this isn't going to do anything. See, if we console log this, and I'm going to put this all inside of a block, if we console log my name, do a refresh, we still get Caleb in lowercase. What this function does is it actually gets a new string and it will return it. So that means we need to reassign it to something. So we could assign it to the same variable, and now it should work. So now Caleb is in all caps. Zoom in for you there. And hopefully you caught something. In the previous video, I mentioned that primitives do not have methods. Yet string is a primitive and we're calling a method to uppercase. Well, I'm not lying, I'm not fibbing. There's just something going on behind the scenes that we need to understand. And this is one of the big differences between primitives and objects. This happens for primitives, but it doesn't need to happen for objects. The primitives also have an object counterpart. So for example, if we get rid of this here, we could say something like let your name equal new string, like so. And then in here we could pass in your name. These are two different things. So for example, we can get the type of my name and we can get the type of your name. You can see my name's a string and yours is just a stupid object. Part of the reason that the primitives have an object counterpart that works similarly but is technically an object and not a primitive is because these can have properties, and properties allow us to do cool things. When we access a property on one of the primitives, such as myname.toUppercase or whatever you click, what's actually happening behind the scenes is that my name gets wrapped or boxed inside of an object. And then when it's done, it turns it back to a primitive. I know it sounds kind of stupid, but that's just the way it happens. So we start as a primitive, and then it converts it to an object, runs the method, and then converts it back. So this is kind of what's going on behind the scenes, if you wanted to think about the process. So when we call a method to uppercase, what's happening is it's boxing it inside of a string, it's calling the method, and then it's getting the primitive value back. We don't actually have to type these 3 lines. This is just for our back-end knowledge. So I'm just going to get rid of this. So to conclude, primitives do not have properties or methods. When you call a property or method on it, it's getting boxed as an object, it's calling that method, and then it's converting it back to a primitive. we talked about how we can create a primitive-like object, but not quite. It's still an object using the new string, for example, and you could also do new number and so forth. These are going to give us the object version of the types, and we can convert back to the primitives by using the method value of, and then you'll need to assign that to something. You can get the type of these just for testing using the type of method. So this might bring up the question, when should we use the primitive and when should we use the object? For example, should we do it like the way we did my name up here? Or should we do it the way we did this string down here, Claire? 99% of the time you're going to want to use the primitive. All the object stuff is going to happen behind the scenes, so there's not a lot of reasons to use the object alternative. That's all I got for you guys in this video. In the next video, we're going to dive into the numeric data type and get our hands wet with that. It's going to be a lot of fun. We're going to learn a lot of cool stuff. So be sure to check it out. Please be sure to subscribe if you've enjoyed the series, and I'll see you in the next one. Aw, yeah. Hey guys, welcome back. This video, we are going to be talking about numeric data types, get started working with those, talk about some of the gotchas and the important things to know, and all that fun stuff. Back to numbers, there's nothing too crazy about numbers. There's just some things you need to know to understand how they work in JavaScript. But they work basically like expected. So for example, if we have a number, it looks like that. You've probably seen that 1,000 times. But one thing you need to know is that you can also store decimal values. So for example, we could say x is 5.5. Internally, numbers are 64-bit floating point numbers. So this is known as a double precision floating point number and is in contrast to what's known as a float, which is just 32-bit. So 64-bit gives us a lot of memory to work with these numbers and allows us to store some pretty large numbers. But there's only one data type for numbers. There's not one reserved for integers, and there's not one for floats and then double and then decimal or whatever it is. There's just number. Why is this important? Well, sometimes when you're working with integer values, which basically are just numbers without anything with a decimal, it's important to make sure you are very precise and that the number you're trying to represent is 100% correct. But this is not always the case with a floating point number. Because of the way JavaScript stores numbers, you can occasionally get some odd things going on with your numbers. And this is going to happen when we try to go too high in our number or too low. So if you wanted to safely store an integer, how high could you go? Well, you can actually figure that out using number dot, and then there's this max safe integer and min safe integer. So let's print the max safe integer for a sec. We do a refresh and we get this huge value. Let me zoom out. That's the value. So if you're storing dollars to represent your bank account, congratulations. But this is the highest integer we can safely store. So what exactly do I mean by safely? Well, check this out. If we do something like we console log x, we should get that value. And now let's increase it 1. Print it, we get 2. Let's increase it 1 more. Do a refresh. Oh, what? Huh? We're still getting 2, even though we put the value 3. Oh, that's weird. We put 4. Now we get 4. Okay, so we can't put a 3 there? Exactly, that's what I'm trying to say. Not all numbers can be represented once we get into the large numbers. That's because we're given a limited number. That's because we're given limited space and memory to store our number, so we can't just create infinitely large numbers. We can test if a number is in the safe zone using number dot is safe integer and putting the thing we're testing inside of parentheses. Do a refresh, we get false. So anytime we get false for this, we know we're in the issue zone. If we bring this down to 91, we should be okay. And there we go. Now you can store really large numbers and you can store really small numbers, but sometimes you might want to just represent infinity. And you actually can do that with number because there's 3 special values with a 64-bit number. There is infinity, negative infinity, and not a number. So yeah, not a number is a possibility for the number data type. So for example, we're just going to go through a little application, say how many babies I want to have. And what we're going to do is we're going to raise this to a power. And what we're going to do is we're going to pass in babies. So you call math.pow with lowercase p there and pass in the value, which is the base value. So what do we want to raise to a power? Then we put a comma and then the exponent. So, I want lots of babies, so we'll raise it to the 200th power. And what's going to happen is when we refresh, we just get the value infinity. Same thing if I want a negative number, that's possible if you get these inputs correct. Boom, negative infinity. This works like normal infinity. For example, we can multiply it by 2 and it's still infinity. Now the other special value is not a number, and this will occur if we're trying to do math on something that doesn't really make sense. So for example, let's try to add 2 to console.log. So we're printing console.log plus 2. When we do a refresh, we get not a number. Which makes sense because how are we supposed to add 2 to console.log? It just doesn't make sense. Back to the positive and negative infinity, you can also get that when doing certain divisions. So for example, 1 divided by 0, refresh, and we get infinity. This isn't giving us an error in JavaScript. Other languages might try to bite your head off for trying to divide by 0. You can also get negative infinity from this as well. That's all I really wanted to talk about in this video. In the upcoming video, we're going to talk about more of the properties and methods for numbers. We've learned about some of them here, but there's a lot more we could talk about and some really cool stuff that you should know about. So please be sure to check it out. Also check out our sponsor in the link in the description. And thank you guys. I'll see you in the next one. Yo, what it is, it's Caleb. Today we're going to be talking about some numeric interesting things like basically operators and operator precedence. All right, so where do we even start? You know, we always have to use an example with pizza. So we're going to have a variable slices of pizza, and we're going to set that equal to 10. And we're going to use this throughout the program, but right now I'm going to make a comment section to list the operators. So we have the plus operator, the minus operator, the multiplication operator, the division operator, and one you may have not heard of, which is the modulus operator, and we're going to get into that. So let me just give a little space here. So these are the operators that are used for arithmetic, the arithmetic operators. You can use these operators to make expressions, and you can use pure values, so I could say 50 plus 50, or what I could do is I could use variables inside of these expressions. So I could say slices of pizza plus 10. Then this will show up in the console. Oh boy, I'm so zoomed in. Right there, 20. So that's the first one. It's pretty simple. Minus works the same way. Nothing too crazy. You guys should have learned this in like, I don't know, 10th grade. The only one that might confuse you is this modulus operator. It's much less common. The way this works is it will give a remainder of some division. So let's say we wanted to split this pizza between 3 people and you couldn't cut a piece in half. That means there's going to be 1 left over. So if we use the modulus operator and say 3 because we're splitting it amongst 3 people, we will get the value 1. One thing that's cool with JavaScript modulus is that you can actually use decimal values. Some other languages don't let you do this. This means we could split it with, I don't know, 4.25 people. Kind of a stupid example, but you can see that when we refresh this, we get 1.5. So if you're working in C, for example, you couldn't put the 4.25, you could only use whole numbers such as 4. The next thing I wanted to talk about was operator precedence. Oftentimes you'll have expressions with numerous operators in a sequence. Let's just go through some examples and see how this works. We're basically going to come up with a large expression that uses numerous values. So let's just go with this here. The precedence basically defines in what order these things get evaluated. We're not going to be using the modulus or the remainder operator in this example, but just so you know that it has the same precedence as the multiplication and division. But it is a very cool operator. You can do a lot of magical things, so it's definitely going to show up, so make sure you understand the basics of how it works. Alright, so we need to think of how this is going to evaluate. Let's just print it out. I'm going to get rid of this stuff up here, and we're going to console log this variable. When we do a refresh, we get 39. Let me zoom in. There we go. So the way this is getting grouped is, let me just show you with another example. The first thing that happens is the multiplication and division. So you can use parentheses to indicate that. You can put parentheses anywhere and they'll just basically force that section to be evaluated first. So when we refresh this, we still get 39. Oh, let me print the second one too. We refresh and we still get 39. So this is the default precedence. These are going to happen first, and then the results are going to be added with 5, and then that's going to be subtracted from whatever's left over here. You can force a different precedence using parentheses in different spots. So I'm going to go through another example and we'll print that. Let's say we wanted the addition to happen first, and then the subtraction. We could do that like so. And that'll force a different value. So multiplication and division and the modulus have equal precedence. You can see that on this operator precedence chart. So we have multiplication, division, and remainder all at 14, and then addition and subtraction is next. So when you have multiplication, division together in the same expression, it's just whatever happens left to right. So in this situation, this one's going to happen first, and then this one. The concept of whether it's left to right or right to left is known as its associativity. Most of what we're familiar with is left to right, and that's how all of these arithmetic operators work. My recommendation is to use parentheses whenever you can, even if it's not super necessary. Like in this situation, this does the same exact thing as this thing up here, but it's much easier on the eyes to be able to look at an expression and just visually see which ones are going to get evaluated first. Now there are some other cool operators I want to talk to you guys about. I'm going to be showing you guys that in the next video. That's going to be talking about how to increment a variable as well as do some cool assignments. So check that video out, and please be sure to check the links in the description for the sponsor. Thank you guys, and please be sure to subscribe. Also, just out of curiosity, do you believe it's okay to put pineapple on pizza? Leave a comment in the comment section below, but please keep it civil. You can put a comment for with it or without it, and the ones with the most likes will win. Thanks guys, I'll see you in the next one. Hey, welcome back guys. In the previous video, we talked a little bit about splitting pizza amongst our friends using some special operators. In this video, we're going to continue that discussion by increasing and decreasing our count of pizza slices. Now in the previous video, I left off basically asking, do you think it's appropriate to put pineapple on pizza? And I'm hoping that has intrigued some interesting thoughts and discussions. But I just wanted to ask that you guys put your differences aside and just get along for this one video so we can continue our discussion and not have to worry about fighting. And enough blabbering, let's just dive into more operators. So anytime you want to change the value of a variable, we can reassign it. So we could say slices of pizza equals 11, for example. We only have to use let or var one time, and then after that we can just reassign it using the name. And this is okay, but sometimes we don't want to just give it a concrete value. We want to give it a value relative to the value it already has. So for example, we could say, hey, assign a value one more than the value it already has. So if you wanted to do something like that, you basically have to use the variable and reassign it back to itself. So something like this, slices of pizza plus 1. This is going to work the same way. This side gets evaluated to 11, and then that's reassigned back into slices of pizza. So now slices of pizza is going to be 11. And look at that, I wasn't lying. This works and all, but this is like a ridiculous amount of typing. You have to type the variable like twice. And you know, as developers, we can't waste that kind of finger power. No, this sounds so weird. And as developers, we just cannot be wasting time rewriting variable names. So they have a shorthand way to do this, and that is to say slices of pizza plus plus. So I could take this and replace that previous statement right here, and now what happens when we do a refresh, we still get the value 11. There's also a decrement version. So we could say slices of pizza minus minus, and we get 10 again. So we increase it 1, then we decrease it by 1. These are known as the postfix increment and decrement operators. Postfix means that it comes after the variable. There's also a prefix version. So let's get rid of these. I'll show you the prefix version now. Plus plus slices of pizza. Very similar, and it gets the same result 11 because we just increased slices of pizza by 1. You will see both versions in code. Generally, I like to put them after the variable. I think that's what most people do. You might be wondering what in the world the difference is if they do the same thing. Well, there is a slight difference, and you can see that if you want to, say, reassign this back to a variable. So let's say we have a new variable, new pizza, and we're going to set this to slices of pizza plus plus. And on our console log, let's make this a little bit more organized. So we're going to print slices of pizza like that, and then we're going to print new pizza here. And I don't think we need this space here. I think it'll automatically put a space for us when we use a comma. So now let's do a refresh. So the first one, slices of pizza, is 11. So slices of pizza does get incremented, but new pizza is only 10. So that means a new pizza is getting the original value. So the increment is happening after the assignment. So when we get to this line, what happens is slices of pizza gets assigned to new pizza, and then we increment the value of slices of pizza. If we put the pluses on the other side, well, then the pluses happen first. So this gets changed to 11, and then we assign 11 back to new pizza. So this will give us both 11. This really isn't that important because you're really not going to see this a whole lot. And honestly, I just don't really like the code when something like this happens because even if you're a seasoned pro, it's really easy to mess this up and it's hard to remember which way happens. So I recommend if you're really wanting to do something like this, just break it out into more statements and make your life a whole lot easier. So this shorthand of the plus plus and the minus minus gives us a real easy way to increment our values by 1. But what if we wanted to increment it by 20 or, multiply it by 5? Well, we could always just write that out manually. So like let's say we wanted to multiply our pizza we could say slices of pizza equals slices of pizza times 5. And this will give us the value 50. So now we have 50 pieces of pizza, but once again, we have to write that variable name out, and that's no fun. So the shorthand way to do this is to delete this and put that multiplication symbol on the left side of that equal sign. Right there. Oh, yes. I could go for some 50 slices of pizza right now. So all of the arithmetic operators can be used this way. That means you could always do a plus equals, a minus equals, a multiplication equals, a divide equals, and even a modulus. Oh, even a modulus equals. Sorry, I messed up my typing there. So that means if we used a value like 4 here, this will give us the value 2, and slices of pizza will have 2. That's because 4 goes into 10 twice with 2 left over. This is a useful tool if you want to do something like count by a certain number. For example, you might use the increment if you want to count by 1, but if you wanted to count by 2, you could use plus equals 2 and not have to increment twice. Or if you wanted to count by 10, you could do this. Once we get into loops, you'll see this a lot more because you'll often see some kind of increment inside of the loop condition, but we're going to get into that. Right now, you just need to know how this works and be able to apply it to some examples. Hopefully I didn't get your cravings too high for pizza. I know the struggle is real when you really want something and it's not around, but I think you can get through it, and I really encourage you to check out the next video because we're going to be talking about number methods. Not the ones we've already talked about, we're going to be talking about some new ones. Specifically, I think we're going to get into parse int, which is a really cool method that you need to check out. So thanks guys, check out the next video, subscribe, and check out our sponsor. Peace out. Welcome back everybody. This video we're going to be talking about how to use number methods. Now you need to understand up front that there's 2 real ways to call methods. One way is to call it on the number object. So you could say number dot. And then there's all kinds of this junk you can use in your program. The other way is to create our own instance of a number and call our methods on that. For example, we might say let x equal 5, and then we could say x dot. And then there's all kinds of other junk we can use. We're going to start by talking about the ones called on the number object directly. If you come from other programming languages, you can think of these as static methods. And what that means is you don't have to make an instance of number, you can just use them right away. So there's parse int and parse float. What these do is basically take a string and try to convert it to a number. Ew, my dog is like barfing over there. You can use the float version, but I'm just going to work with int just because I think ints are simpler to work with. But once you got this down, the float version works exactly the same way. So let's say, for example, you wanted to add 2 numbers. So we have x is 5, and let's say y is 10 in quotes. So this is a string. When you add these, you're not going to get 15, you're going to get 510. So if we do x plus y, do a refresh, we get 510. That's because this is coerced to a string, and then they're concatenated. But what we could do instead is we could say, we're going to create a new variable, let's call it yint, and we're going to call number.parseInt. And inside of here, you can pass in y. So this is going to make it a number, which means we can use that inside of our code. And now when we do a refresh, we get the value 15. Oh yeah, doing math, that's what's up. Another way you could do this is just call the number constructor like so, and do a refresh. That works the same way, but the parseInt might give us some more flexibility. So I'm going to put that back in here. For example, we might have something like 10.923 is my fave number. Well, this will actually work because it's going to take the value at the beginning of the string. So when we add these together, what's going on? I think I broke it. Oh, that's funny. Oh man. Oh, I was literally going to talk to you guys about how when you do parseInt, obviously it's going to crop anything after the decimal. So it's cutting 10 off and just giving us the value 10, which is why nothing changed. Oh man, that just really stretched my brain. Okay, sorry I'm dumb. Let's talk about the next thing, which is how parseInt crops numbers. So if we had a number in here, like 10.9, the thing is that it doesn't round, it'll truncate this. So anything after the decimal is gone. Even if we're at 99999, it doesn't matter, it's still going to be the value 10. If you need to reserve those decimal values, then you don't want to use parseInt, you want to use parsefloat. There we go, that's what I'm talking about. So now when we have strings in here, it's still gonna work, and we're gonna get the same value there. So this was a very, very light introduction to parseInt. There's one more cool thing I wanted to teach you guys with parseInt, and we're going to be talking about that in the next video. That is a very specific application of parseInt. If you want to convert from decimal to binary, octal, hexadecimal, or back, you can do that with parseInt. So check it out, it's going to be a lot of fun, and this is one of those things where you can actually make some cool applications and have a little bit of fun. So please be sure to subscribe and check out the next video. Thanks guys, I'll see you in the next one. Yo, what's happening everybody? This video, we're going to get super nerdy converting between binary, hexadecimal, octal, and decimal. So it's going to be a lot of fun. If you don't understand these number systems, it's not a huge deal. You can still follow the video and just kind of put it in the back of your mind if you ever need it. We're not going to go deep into how all these number systems work. I have videos on that if you really care. The main thing here is just to see some of the versatility with the parseInt method as well as the toString method. So it's going to be a lot of fun. Please be sure to stick through and subscribe if you enjoy the content. So the first thing is, let's just get a prompt from a user. And we're going to start with them typing in a number, and we're going to interpret that number in 4 different ways. So basically the way number systems work is that you can have a number such as 1, and in decimal that means 11, but in binary that means 3. So basically when we use numbers like this, these can be interpreted different ways, depending on what base we're thinking in. So what we're going to do is we're going to ask a user for a number, and we're going to present that in 4 different ways, interpreting it as first decimal, then binary, then octal, then hexadecimal. All right, so let's just ask them to put in a number. So the very first thing is we're just going to spit it back out as decimal. So we're going to say decimal, and I'm going to put a colon here, and then we just print out input. So this will just copy exactly what they put in. So you put in 11, it prints 11. When we go to binary, this is when it gets a little bit more fun. So now rather than just putting input in here straight like this, we can use the parseInt method on the number object. So number.parseInt. First argument is going to be the input, the string we want to convert to an integer. The next argument is going to be the radix, or the base, so we could put the value 2. So now when we do a refresh and we put the value in 1, we get 11 and then 3. So depending on if you interpret 1 as decimal or binary, the decimal result is different. So I should probably clarify, the results over here are in decimal. So the value 1 in binary is 3 in decimal. We can do a very similar thing with octal and hexadecimal. Now let's do a refresh, put in the same number 1. Well, 1 in decimal is 11, 1 in binary is 3, 1 in octal is 9, and 1 in hex is 17. Okay, so that is how we convert from different bases to decimal. Also, I put a bunch of these spaces here to make it pretty, which I obviously failed. So this is how to convert from these different bases to a decimal value. But if you wanted to switch it around and convert to these different bases from a decimal number, that works a little bit differently. So let's get rid of this. And what we're going to do is now we are going to get a decimal number. And what we're going to do is we're going to output that in decimal, binary, octal, and hexadecimal. First thing first, I'm going to put the decimal value and then just put a little string. So we're converting from decimal to decimal. It's not going to do anything. And then all we have to do is just put the input value here. So right now, put in a decimal value, let's put in 11, we get 11. Shocker, right? Now let's do binary. By the way, whether or not to use pluses or commas is totally up to you. You could also use commas here. So now we're converting from decimal to binary. And the way we're going to do this is we're going to take input.toString. So right now you can pass in the radix here, so we could say radix 2. So we want it to go in binary, but you can see when we actually print it, it doesn't work. It's printing the same exact thing. And the reason is because we can't put a base when we're using toString on a string. And you can see input is actually a string. The reason it's a string is because prompt returns a string. So what we actually want to do is convert this to a number. Now when we refresh and try this, we put in a value 11, we get 1011, which is how you represent 11 in binary. You can do a very similar thing with octal and hex. So now let's do a refresh, put in the value 11, and if you don't like the way these look, you can replace the commas with pluses. Now throw in the value 11, You can see 11 in decimal is 11, 11 in binary is 1011, and 11 in hexadecimal is B. So there you go, guys. I know that was a little bit of a drawn out example, but basically you might need to use this for school or for just some fun. Hopefully it was useful for you guys. If you've enjoyed this content, please consider subscribing. And you know what? You need to check out the next video. Why, you might be wondering? Because we're going to be talking about number instance methods. So these are going to help us out a lot through our programs, and you don't want to be a butt and miss them. So check it out. I'll see you in the next one. What's up, my boys and girls? This video we're going to be talking about instance methods on any numbers. So you're also going to get a little bit of a taste of object-oriented programming in JavaScript, so that'll be fun. If you don't understand everything, that's okay, because we're going to deep dive object-oriented programming later on in the series, but I just want to give you a little taste of that. Okay, so there's two ways to call methods when it comes to numbers. So we can say number with a capital N dot, and then we get all of these different methods which allow us to do cool things. The methods are actually the purple boxes, and the blue boxes are the properties, which are just values. And I'm using Visual Studio Code, by the way. So once again, these are called directly on number, and number is actually a constructor. So what a constructor is, it's a way to create new objects. So when we do something like let x equal new number, we are using the number constructor. So a constructor is just a function. And in JavaScript, functions are actually objects. Because it's an object, it allows us to put properties on this object. That's a little bit different than what you might be used to if you're coming from different programming languages. So this means that we can call number, and on this constructor, there are all kinds of properties that we can use. The other way of calling methods is on an instance. So if we say let x equal 5, we can do x dot and access some junk in here. Numbers actually inherit from something called number.prototype, and prototypes are basically the way we do inheritance in JavaScript. If you want to see something like this, go into the console and create a new number. So we can say let y equal new number 10, for example. Now, when you say y, what happens is you can expand this and you can see it has this prototype number, which kind of defines our inheritance chain, our prototype chain. So when we call methods on this x over here, this primitive, it's going to automatically be converted to a number object. All of these methods on here are on that prototype, that number.prototype that we showed over here. Anytime things are attached to the prototype, they're automatically going to be attached to new instances. Yeah, definitely some confusing stuff, especially without going through a lot of examples of object-oriented programming. For now, just know that there's two ways to call methods. We've talked in the previous videos on calling things directly on number. Now we're going to be talking a little bit more about calling things on instances. One of them we did talk about is this toString, which we did to pass in a radix, so you could change the radix that you want to present something in. But there are a couple others. We're not going to dive in super deep. I just wanted to show you some basics, and then we're going to talk about another object called the math object. So the first one is toExponential. And what this does is it allows us to represent our number in exponential notation. So for example, if you want 5 numbers after the decimal point, we can just see what this looks like by doing a console log. And we get 5.0000e plus 0. Oh, come on, Claire. So this doesn't help us a whole lot when we're using a simple number like 5. Let's change this up just a little bit. So we could say we have a big number like this. And we can print this with 10 numbers, for example. So now we get 5.9, all of these digits, and then raised to the 11th power, which basically means we need to move that decimal point 11 times, which will give us the original number. If you lowered this, for example, let's say 3, we get the same thing, but now it kind of crops some of the precision. The next one is toFixed, which can be used to represent things like money, for example. So you can pass in here the number of digits you want. So let's say we want 2. Well, then we could say, let's say we have 5 dot some other junk, and we do a refresh, we get 5.60. So that can be cool if you want to format for money. So you could go in here, put a $sign or whatever currency, plus sign, and then you'll get 560. So the next one, I'm honestly not even sure how to pronounce. To local string. I'm not sure. This will basically print the number in a friendly manner depending on your region. So we can call that using the parentheses. And now let's print this. And you can see this is going to automatically put in commas in here. I imagine if you're from certain countries, it might put periods instead of commas, and that's the whole point of this function here. Next is toPrecision, which allows you to change the significant digits. So we could go in here and put 2, do a refresh, and you can see it's 5.6. That's all the significant digits it has. We talked about toString, so let's jump to value of. What this is going to do is it's going to return the primitive value of the specified object. Kind of silly because x is already a primitive, so let's change this up a little bit and say new number. So if you wanted to get the primitive version of x now, you could use x.valueof. So for example, we can throw this in the typeof function, like so. And when we refresh, forgot a console log, sorry. When we do a refresh now, we get number. If we didn't use the value of, what's going to happen is we're going to get object. All right, that's all I got for instance methods. Now I want to talk a little bit about the math object. Shouldn't take too long. I'm just going to go through some examples with you guys. So I'm just going to replace this with a little bit of text right there. All right, so what exactly is going down here? The way we use the math object is very similar to how we use the number constructor, where we just put number dot something. You do that with math as well. So you put math with a capital M, dot, and then the method. There's a bunch here that I just thought I'd throw in here rather than going through a million examples. You can just use this for reference. I'm just going to go through these real quick. Absolute value will give you the positive version of the number. Ceiling will always round upwards. Floor will always round downwards. Power will raise 3, or the first argument, to whatever the second argument is, in this case 2. So 3 to the second power is 9. Rounding will round up or down depending on the value of the decimal. Here's another example where we have 0.1, it goes down to 5. This one goes up to 5 because it's closer to 5 than it is to 4. The sign one is a little bit interesting. So if we go in here and we put sign, you can see a little bit more about that. It just returns the sign of x, indicating whether x is positive, negative, or 0. So in the case of negative infinity, it's going to give us a -1, which indicates that this is a negative number. Lastly, we have truncating, which is like rounding, except a little bit more not rounding. It just chops off the extra junk. So that's how you use the math object. Just thought I'd give you a little bit of a crash course in that. Thanks guys for watching. Hopefully this gave you some hands-on work with some instance methods as well as the math object. Please be sure to subscribe. Don't be a loser. Do that for me, and I'll see you guys in the next video. Hey, what's up guys? This video we're going to be talking about strings. Oh yeah, and we're not only just going to be introducing like the super basics, we're also going to be getting into string special characters, templatized strings, how to make long literal strings, and going into some other cool stuff. So this video is going to be lots of fun. First thing, strings are very easy to create. You can just say something like, hello? Why would I put my name as hello? That doesn't even make sense, guys. All right, my name is now Caleb. And it works the same way as numbers, that when we call methods on this thing, it's going to automatically convert to an object. You can create strings directly as objects if you use the new object constructor. So if you said something like your name equals new string, and then you pass the value in here, this one here is going to be an object, and this one is going to be a primitive. Works essentially the same way, so I'm just going to get rid of this one, and we're just going to stick with the primitive version. You can access the individual characters of a string using array index-like syntax. So for example, we can do a console log, and what we're going to do is going to say my name, and we're going to grab the third character using the value, the number 2, because it's 0 based. So C is 0, A is 1, L is 2. So when we print this, we should get the value L, and we did. See, I know a little bit of something here. If we go outside of the bounds of this array, we just get undefined. So that's cool. Other languages will probably bite your head off. Depends on if you like that. Some people don't like the fact that JavaScript doesn't really do anything. Other people really like it because, you know, we don't get exceptions. One thing that you need to know about strings, though, is that you can use special characters. So for example, we can go in here and put a \n, and this will be interpreted. So it's not going to literally print a \n. It'll print a new line character and go down to the next line. So that's one special character, but there's actually a whole list of them. So here are all the possibilities. I'm not going to go through all of these, but they all work in a fairly similar way. You just put a / before all of them. One that I am going to call out though is if you want to put a literal \, you just use 2 backslashes. So if we put 2 backslashes, it should just print one of them. There we go. The next thing I wanted to talk about is templatizing strings, which is pretty cool. So for example, in this console log, we could do some kind of concatenation, saying my name is, putting a plus sign, and then putting my name, putting another sign, and then putting something like an exclamation mark. So when we print this, we get my name is Caleb with an exclamation mark. And this is one way to make complex strings, but another way is to templatize your strings, which is a little bit cleaner on the syntax. You can see here we have a lot of plus signs. We have to open and close strings quite often. It can be a little bit verbose. So an easier way is to basically get rid of all of the connecting stuff, so it just looks like you would normally print it. And then instead of using double quotes, what we're going to use is a backtick, which is the character right above the tab key on the left of your keyboard. So you put that tab and then put a $sign and then curly braces around the variable. Yeah, it's a little bit of a challenge to convert strings to this, but in my opinion, it's much easier to read. And now when we do a refresh, we get the same exact thing. So if you're going to be printing a bunch of variables, I'd recommend using the backticks and then basically making a template where you can plug in the variable name that you want to display. Another thing you may want to do is create a very long string across numerous lines. You know, if you wanted to put the contents of a blog in here or whatever, I don't know why you would want to do that, but just in case you did, we're going to talk about how to do it. So we could say something like let text equal, and you might start writing this crazy long book. I'm going to come up with something very creative. Yeah, I got nothing. So we're writing this crazy long string. Obviously this is super ugly, and you know, we could put word wrap on, which would help, but you might also prefer to actually just break this up across multiple lines. But you see, now when we do it, it's not going to work. So if we want to do that, we need to put a backslash. And anytime we want to break a line, we just put a backslash and go down to the next line. So this should work exactly the same way. So when we print it, it's going to appear as if it was written on one line, even though it was not. So if we do a console log, printing out test here, you can see it prints straight. You'll notice this interesting thing here, and the reason that is because the line right after has to be immediately to the right, which is kind of silly. So let's try that. All right, there we go. And you can see the same thing for information, so we need to bring that to the left as well. Personally, I'm not a huge fan of the way this works. You can see I'm even having a hard time getting this thing formatted right. This is something I really never use. But if you're into this kind of thing, go for it. I would much prefer just to go up here and search word wrap, and then what's going to happen is you can just write your strings like normal, and it'll automatically go down to the next line for you. There we go. And now we don't have to worry about any kind of formatting. Last thing I wanted to tell you guys is just a property on strings, which is pretty important and will come up later on, and that is .length. So length is going to give us the number of characters in the string. So this is going to be a ton. So let's do a refresh. We get 109. If we did name, for example, my name, we're going to get 5 because there's 5 characters. Awesome, so that should be a pretty good introduction to strings and how to use them in JavaScript. There's nothing too crazy about them. In the next video, we're going to go into some string methods that you definitely need to know. That's going to be a lot of fun, so please be sure to check that out. And you know what, don't forget to subscribe unless you want to be like, a jerk. Yeah, because jerks don't subscribe. Alright, I'll catch you guys in the next video. What's cracking, yo? This video, we're going to be talking about string methods. So we can get rid of all this garbage. When we talked about number methods, there were some we called directly on number, like so, and then there were others we called on instances of number. Well, string works in a similar manner in that we could say string with a capital S, dot, and put some of this stuff. There's really nothing too fun inside of here, so we're not going to be focusing on these methods. We're going to be talking about instance methods. So this means we need to create an instance of a string, var fave food, and you know, I'm feeling a little creative today. We're going to go with tacos. Very first one I wanted to talk about is how to get a character at this string. We showed you in the previous video that you can just use array-like syntax using the square brackets, but another one you might see is .char at, or car at, however you guys want to say it. And then inside the parentheses, you just put the position. Do a refresh, you should get C. So that's a totally useless method. Moving on to the next one, concat. What this is going to do is it's going to take another string which will append to the previous one. So I could say is totes lit, and now it's going to say tacos is totes lit, which fail. There we go. This is also kind of useless because we could just use the plus operator, so we could just say fave food plus this string here. and you can see we get the same result. So if you prefer to use methods, they have methods for doing the concatenation as well as getting a character at an index. But overall, I like to use the techniques I've shown you so far. So I don't really see these methods as very useful. But I thought I'd share them with you guys because you might run into them when you're coding or picking up another application. Another note on the concatenation is it can take multiple arguments. So I could say, hey, comma, test, whatever you want to put in here, you can do it. You can even put spaces if you need. And there you go. There should be a space right there. This is going to return a new string, so favorite food is not going to be modified. That's really important to know, so if you need to save it, you need to store it in some kind of variable. Now we're going to get into some more useful methods. The first one is finding a string within another string. So I'm going to start fresh again. Let's say we have a variable. I need to make up my mind if I'm going to use let or var. Obviously let makes more sense in the context of this block, but it's not a huge deal, just when we're testing things out. But we're going to make this called content and just set it equal to some large value I wrote out. Now we're going to search for things in this string. So we're going to make a search term, and I'm just going to call it search1 and set that equal to string. So you can see the word string is in here, so it should work, but we're going to try another search, and that's going to be number, which is not going to work because it doesn't have the word number in it. So what we need to do is we do a console log just to get the output. This is going to be a method on the content variable, so content.includes. And the argument is the thing you're looking for. So we can just pass in search1. So when we run this, we get true because it found it. We can do it again with search2, which should give us false. So that's how that method works. It's kind of useless out of context, but this actually might come up if you're wanting to search for something within a string later on in your code. You can also pass in a second argument, which is the index to start at. So for example, I could say, hey, start at index 30. And now when I do a refresh, we get false, because I don't know where index 30 is, but obviously it's after the S. A more versatile function is called index of, and this will allow us to find where things are in a string. So I'm going to replace this with index of and pass in search1. Same thing here, search2. Now when we refresh, we get 29 and -1. The -1 means it was not found. The 29 will give us the index. Remember, it's 0 base, so we start at 0 here. So this is a little bit more useful because not only did it tell us, yes, it exists, but it also said where it exists. Same here, you can pass in another argument, which is the index to start at. Here's a little trick if you want to find the second one, for example. Let's say we are searching for the character A. So there's one right here. So let's see what this will give us. 3. So if we wanted to find the second one, all we have to do is put an index larger than that second one. We can see the value 16. If we put it at 3, what happens is it finds it immediately at 3. So we need to make sure it's larger. Obviously, we're not always going to know where the first occurrence is. So if you want to dynamically search for the second occurrence, you can do a search within this search. This is where it gets fun. So we could say content.index of search1. So this is going to return 3. And then what we can do is just add 1 to it. So we can say +1. I'm going to zoom out a little bit. There we go. It's a little complicated, but that'll give us the second occurrence. Now, if you want to find the last index, such as this one right here, if we're looking for A still, well, there's actually a special method for that. So that is going to be last index of. And it works the same exact way. So now when we do a refresh, we get 61. So that's the index of this A right here. You can do a similar thing if you want the second to last one. Just pass in this call to the second argument and subtract 1 from it. You need to subtract 1 because it's going from this end now, not the left. So those are some of the basic string methods. Hopefully that just gives you some examples of how we can have lots of fun with strings. Obviously, out of context, this can seem more of like a reference, and it kind of is, but hopefully later on when you realize you might need one of these, you can think, oh yeah, Caleb did a video of this, let me check that out. So thanks guys, if you've enjoyed the content, please be sure to subscribe and check out the next video, because we're going to go into some more string methods. And let me tell you, it's going to be sick. So, see you there. Hey guys, welcome back. This video, we're going to continue our discussion on string methods. I know what you guys are thinking. You're probably wondering like, dude, when are we going to get into the cool methods? Well, that's actually what we're going to be talking about today. As you can tell, my throat's a little rough. So hopefully I can get through this and survive. Very first thing I wanted to talk about is the substring method. This is going to take basically a piece of a larger string, such as this content here. We're not going to need these searches for now, so we're just going to get rid of them. So we're going to go content dot and then say substring. And the first argument is the index to start at. So we can say 6, and then the next is the index to stop at, and it's exclusive, so it doesn't include it. So if we put 6 and 11, what's going to happen is, let's find index 6 first. 0, 1, 2, 3, 4, 5, 6. So W is index 6. It's included. So the first argument is included. Then let's find 11, 7, 8, 9, 10, 11, which is this space here. That is not included. So inclusive, exclusive. So what we're going to get is just this wheel right here. So when we do a refresh, we get wheel, and there's no space. It's kind of a funny word by itself, wheel. Sounds like I'm saying like a normal wheel, but I'm not. So that's really cool. Let's move on to the next one. The next one is substr, which the naming here is confusing, but I'll do my best to make it nice and clear. The starting index is the same, so we just put a 6, but now the next character is the number of characters we want to include. So if we put 5, for example, we'll get the same thing, wheel, and you can see there's no space there at the end. So now this is more relative, where this one is absolute. So substring, absolute index, not included. Substr, just the total number of characters to include. If we had an 11 here, we're not going to get the same result as substring. This is actually going to grab 11 characters. So that is the difference between substring and substr. You may also hear of slice. So there's a dot slice. This is very similar to substring, just with some minor differences. If you want to know all the differences between the three, just look it up on the internet, because I don't feel like getting into the nitty-gritty. This is more of just intro material. But basically, you should be good just using substr and substring. Slice works very similar to substring. It does basically the same thing. It'll just give you some differences if you're working with negative numbers and some other things like that. So I'm going to stick with substring, and really that's going to give me everything I need, so I basically forget about slice. Next thing I wanted to talk about is how to modify a string. And these are always going to return a new string. So if we wanted to keep them, we would have to assign it back to a new string. The first one is to uppercase, which does what you would think. It just converts everything to uppercase. And then there's also a to lowercase, which works the same exact way, except it makes it lower. So now we have all caps. We're really excited, and now we're just a little bit depressed here. If we wanted to keep these, once again, you would want to assign them back to a new string or replace the old one. So we could say content.to uppercase here, and now caps contains the modified version. But we're just going to stick with console logging them. Next one is trim, and the point of this is to basically trim any kind of white space before or after the string. So it removes leading and trailing white space. So let's see this in action. Let's just go in here and put a bunch of junk. We can put spaces, we can put a tab, we can put a new line, and then at the end we can do another space, another tab, a new line. And now let's do a refresh. You can see the string printed has nothing at the end or at the beginning. If we got rid of this trim here, you can see what actually would be shown. You can see a lot of extra spacing in here. So that's useful for form validation, for example. If you want to make sure they're not putting any extra spaces at the end of their username or at the beginning, you can use trim. Equally so, there is a left trim and right trim. So there's dot trim left, which should do the same thing. And there's a dot trim right, which will get it at the end. You may also see trim start and trim end. So trim start, which works, and then trim end. They do the same exact thing, just another name for the same thing. Now this next method you're going to see is super awesome. It is absolutely useless, but it's a lot of fun. So for example, let's make a string TikTok. And let's say we just want to print TikTok a ton of times. Well, what you can do is you can say waiting, dot repeat, and then put in the number that you want to repeat it, how many times you want it to show up. So let's say we want it to appear 4,000 times, do a refresh, and boom, there you go. It says show 35,000 more. So yeah, not sure when you're going to want to use that, but definitely fun. Next one is actually very useful, and you probably will end up using this if you get into any kind of complicated programming, and this is the split method. And the way this works is it's basically going to take what we have and split it up by some delimiter. So a delimiter is something that separates things. So the delimiter for this string could be spaces. You might also see examples where the delimiter are commas, or it might be dashes or hyphens. It's usually some kind of special character like that. But if we wanted to split this into a bunch of words instead of a giant string with spaces, we could use this method. So let's put split, and then inside of here, we're just going to put a space inside of a string. So we're saying this is how we want to split it. Okay, sorry. I got to change this to content.split. Now do a refresh, and you can see now we have an array, and we're going to get into arrays if you guys don't know about them, but basically we have a collection of different strings. Every single one was originally separated by a space, but now they're just individual entities, and they're all in an array. This will definitely be helpful when working with comma-separated value files. This is how you can break up data and put it into an array. So that is actually pretty useful. It's not nearly as fun as the repeat method, and it's kind of boring honestly, but definitely more practical. Those are the basic functions you guys should know about. There's two more I wanted to talk about, but I decided to pass, and that is .search and also .replace. Maybe we'll talk about these later, but basically these take what's known as a regular expression. And a regular expression is basically a magical way to match things. So for example, you can make a regular expression to tell if something is a correct email or if it's the right format for a phone number. And using this regular expression, you can filter out things in your string, so we could replace different things or whatever you guys wanted to do. So if these seem of interest to you, check them out. They might be useful in upcoming projects. But that's all I'm going to be talking about in this video. In the next video, we're going to be getting into something really cool because we're going to be talking about creating basic functions and objects. We talked a little bit about it, but now we're going to go in a little bit more depth just to prepare us for the upcoming content. So thank you guys for watching. Please be sure to subscribe, and I'll see you in the next video. What's up, my nerds? This video, we're going to be talking about creating basic functions and objects. When we first introduced data types, we talked a little bit how there's primitives and then there's objects, and they're slightly different. So this video is going to give you a little bit more detail on the objects. We're not quite going to deep dive yet because I think there's a lot of more fundamental stuff we should know. The way we create an object in JavaScript is fairly simple. So we could say something like let position, and then to define an object you use the curly braces. So everything inside of the curly braces is known as a property. Now, within the classification of a property, you can also have functions. So some of the properties are functions, but we're just going to start with primitives. So for example, we can have an x, which can have the value 10, and then we can have a y, which has the value 20. You can console log the entire object if you want to get the information about it, 10 and 20. So these are the properties or the members of the object. A method is another type, and what a method is basically just a function that's attached to this object. In general, when I hear property, I tend to think of just values, and when someone says method, I think of doing something. We are going to get into adding methods, but for now I just wanted to talk a little bit about how we can work with objects a little bit more just to get some more practice. One of the big differences between primitives and objects is the way they are passed to different variables. So if I create a new variable and call it myPosition and set that equal to position, essentially what's happening is we're taking this and assigning it to this. This means if I go in here and console log myPosition, it should print exactly the same thing. So you can see two exact things printed in the console here. But the question is, are these printing the same object, or is it a copy of the object? Because if you remember going back to primitives, if I did something like let x equal 10 and then let y equal x, well, this makes a copy of the value. Objects work a little bit different in that if you assign a variable that contains an object to another variable, they both point to the same object. So any kind of changes are going to be reflected inside of both of the variables. So getting rid of these primitives, let's just see an example. If we go past these console logs and we say myPosition.x and set that equal to 10, that's not going to help us at all, 15. And now let's console log both of these again. Now when we run this, do a refresh, you can see in the first occurrence, they're both 10. I changed one and they both changed to 15. So that is the primary difference between primitives and objects, at least when it comes to functionality. There are some differences in memory and stuff like that, but that's all behind the scenes. Now when it comes to adding properties to here, we can also add methods. So if you wanted to see an example of that, all you have to do is give it a name. So I could call it print, for example. And then we just say function, put the parentheses, and then curly braces, and then anything inside the curly braces is going to be executed. So in here, I could console log the position. So here's how we do that. First off, I'm using the backticks, which allows us to templatize our string and plug in variables. Now there's this interesting keyword this, and this is a magical keyword that honestly is probably going to cause you numerous headaches. Basically the keyword this is going to be used throughout JavaScript, but it always means different things. In the situation of a function that's attached to an object, so in other words, in the situation of a method, this is going to refer to this variable, this instance of an object. So what that means, if we want to access this property X, we can prefix this dot, and then it'll know that we want to talk about the X inside of this object. To execute this, all we have to do is go down here and we can say position dot print, and then call it using the curly braces. We don't have to console log it or anything because all of that's being done inside of here. So this is going to do all of the work for us. We do a refresh and you can see it says X is 15, Y is 20. Cool. This is in contrast to creating a function outside of a class. When you do that, it looks very similar. There are some minor differences. So if you want to see that, I'm just going to copy this, paste it down here and show you what that would look like. First thing, the name is going to go after function. So we would say print right there. And then if we wanted to call it, we would just say print. But you might find something interesting happen here. When we do a refresh, it says undefined. And that's because this in this situation is not the same this in this situation. And we're going to get into this later. But just know for now, when you're in a method, you should be fairly safe to use this dot to get the properties. But obviously in this context, there's no such this that has an X property on it. If you wanted to see what this is, you could just console log this, like so. Now when we do a refresh, you can see it's the window object. The value of this depends on the way we call a function. The concept of what this means is known as the function context. So for the function context of a method, this is always going to refer to this instance of the object. This is in contrast to calling a function as a function, which sounds silly, but that's in contrast to as a method. So when we call it as a function, the function context is either going to be the window object as it is here, or when we're in strict mode, which we're going to get into, it's going to be undefined. So if in here we say use strict, in this situation it's going to be a little bit different. Now when we do a refresh, we get undefined. All of the rules for this, we're going to dive into those deep. There are ways to create copies of objects if that's something you're into, so look that up if you need that. Otherwise, just be careful you're not pointing things to the same object and changing it in a way you're not hoping to. There are a couple of other things I wanted to talk about. For example, you can create nested objects. So I'm going to give it some really creative name. I know, I'm clever. I need to make a comma after this one. So we can just put an object just right here and we can make the values whatever, like so. So that is a nested object. And if you wanted to access that, you just have to use another dot. So it'd be position dot my object dot sweet property. That's how you would basically traverse the nested objects. Last thing I just wanted to briefly mention to you guys before we go is something called JSON or JSON or JSON, whatever you think it might be. So what is JSON? Well, JSON is JavaScript object notation, and it's very similar to this in nature, but it's a little bit different. It's just something you should know about. You can find all kinds of examples of JSON on the internet. You can see it looks a little bit different in that the properties are quoted. There's a couple of other differences, but basically overall it looks pretty similar. The reason I'm calling this out is because when you're working with websites through an API, you'll often use JSON. You also use it for configuration in different frameworks, so you definitely want to be familiar of its existence. I'm not saying you should master it right now, but just when someone says JSON, you know it's this, and it's similar in nature to how we create an object in JavaScript. So that's JSON. I'd encourage you guys to do some more research on that. And yeah, with that, that's all I really have to say. So hopefully this video just gave you a good introduction. Remember that these things will get ironed out as we go on in the series, so don't pretend that you have to know everything right away. That's all I got for you guys, so I'll see you in the next video. Yo, what's up everyone? Welcome back. This video we are going to be talking about if statements. If statements are one of the first control flow structures. So the way an if statement works, it's going to take a section of code and only execute it if some condition evaluates to true. So that's a lot of jargon, so let's just go through an example. In this situation, we're going to get the name from the user, and then what we can do is we can say if, and then inside of parentheses, this is where the condition is going to go. But then we're also going to have a set of curly braces. So this is the general structure for an if statement. If you guys have done any programming before, you've probably seen this. It's nothing too crazy. So in here is where we put an expression. You gotta put that in there. In here is where we put an expression. An expression evaluates to a value. In this situation, it's going to evaluate to either true or false. If it's true, the stuff inside of these curly braces, this code block, will be executed. If it's false, then it's just going to skip right over it. So we could say that our condition is that name has to equal Caleb. Now, this might be interesting and new to you. We're using 3 equal signs. This is known as the identity operator. You may also hear strict equality. And what exactly do I mean by strict? Well, what this is going to do is not only compare the value, but also the data type. So what exactly does that mean? Well, if you had the value 5 and the value 5, these both represent the same thing, but they're in a different data type. This one here is a number, and this one here is a string. When you use the strict equality, these are not considered the same thing. This is in contrast to using 2 equal signs, which will do coercion or data type conversion behind the scenes and try to see if things contain the same value. So my recommendation is to always use the triple equals, the strict equality operator. It's safer, it's more predictable, and it's overall just better. When you use the double equals, you have to memorize a bunch of rules on how data types are converted, or you always have to reference a chart. It just makes it a little bit more error prone. So now that we get the basics, we can go in here and execute some code. So we can say welcome, do a refresh, say our name is Caleb with a capital C, and it says welcome. If we run the same thing again and type something else, such as Caleb with a lowercase c, it doesn't execute. An extension of this is to add an else clause, which will execute if the condition is evaluated to false. So in this situation, when we type in a name that's not Caleb with a capital C, it'll say you are not welcome. There is a third variation, the if else if, which allows us to do another comparison in another section. So for example, I can go in here and say else if, put another condition, and another code block. So the final structure will look like this, and we could say name is equal to Sally. In this situation, we might say something else. Close enough. All right, do a refresh. Now if we say Sally, it'll say welcome Sally. You can think of the else clause as a catch-all. So the if one will get Caleb, the else if will get Sally, and then if anyone else, you just go to the else. The else is not required. You could remove that and just accept Caleb or Sally. So that is your introduction to the if, else if, and else. It's pretty simple stuff. It may take some time to get used to it, and pretty soon we're going to be talking about different things you can use here just besides the strict equality. There's all kinds of different stuff you can do. You can make really complex conditionals and make things a little bit more exciting. So I'm looking forward to the upcoming content. I hope you guys are as well. Be sure to subscribe if you've enjoyed this series, and I'll see you in the next one. Welcome back, everyone. This video, I just wanted to talk a little bit more about the if statement and general control flow statements and why they are useful. And this might be super obvious to you if you've gone through this before, but if it is, just bear with me, or you can go along to the next video. But I think some of the challenge is to understand the use of an if statement, for example. Like, what is the benefit of using such a thing? So up front, the use case of if statements is pretty clear that, hey, you can do different things depending on the value of something. And up front, that makes sense. But the whole purpose of this is a concept known as generalization. The idea behind generalization, it's basically just a fancy word to say our program works in various situations. Right now, we are getting the name from user input. You may see that hard-coded like so, where the name is actually typed in here. And this is known as hard coding. You'll often see this for beginner code. They'll put something that's important and is likely to change. At the beginning, they'll hard code it, and then they'll deploy their application with that value in the code. And this is okay in some situations, but the problem is that the application is only going to work with the name Caleb. Yeah, silly example, but this might be some kind of configuration that is hard-coded and then used throughout the program. If we want to generalize our program, what we're going to do is we're going to basically extract any hard-coded stuff and put that in a database or in some kind of configuration file or text file of some sort. When we do that, we're no longer restricting the application to just using Caleb in this situation, or it might be some setting in some other situation. So with an if statement, we can basically catch all scenarios of possible inputs with only a few lines of code. The benefit of this is that our application becomes more useful. Oftentimes, you might want to create an application that does something in two different ways. And what you could do is you could basically extract this setting into a binary yes or no, 1, 0, and you could set that in some kind of configuration file. And the way the application is executed depends on that value. So for example, if you're building an application and you want, gold members to be able to do everything, but silver members only to be able to do some stuff, what you can do is with that user profile, you can say that this person is gold, yes or no. And then inside of our application, we can make it so that the same code is used for the gold and the silver, but in the situation where you're gold, you get a little bit of extra privilege. This is where math and computer science kind of mend, because the whole idea of formulas and functions and stuff in math is generalization. A function in math will basically take all possible inputs and give an output. Similar thing in computer science, we want to think very general in that users can come into our application and basically give us any possibility of input, and we have to be able to accept that. So as we go throughout the series, we're going to talk about ways to properly generalize so that we can not have to worry about breaking our application if someone were to put something that doesn't make sense. As you're learning, it's okay just to assume people are going to use your application the way it's supposed to, but when you're deploying a real application, you got to assume everyone's trying to hack your program. They're trying to type whatever they can. They're trying to click things they're not supposed to, and overall, they're just not very good users. If you assume everyone is like that and you generalize your program so that it accepts not only different settings, but also correct and incorrect input, then you are very good at programming. You get lots of jobs, you make tons of money, and you're a huge success. So that's the sum of it. This video may have seemed a little off topic, but I just think it was kind of important to clarify the purpose of some of the stuff we're talking about. Hopefully that was useful for you guys. In the next video, we're going to get into some more stuff, so please check it out and please subscribe if you've enjoyed this content. Appreciate it, and I'll see you then. Hey, what's going on, everybody? This video, we're going to be talking about comparison operators. So right now, we're comparing the value of name to some string literal. But sometimes you want to be a little bit more general. Like, what if I wanted to say less than 50 or like greater than 50 for numbers? Well, this is possible thanks to comparison operators. So that's what we're going to be talking about in this video. So I'm going to clean some of this up, get rid of that, get rid of this else, get rid of this. And then we're going to get this from the prompt. Boom. Documentation. I know, pathetic. In here, this is a list of all of their operators. So you can go to comparison operators, and you can see the whole list is right here. So far, we talked about the strict equal. We also mentioned just equal. The difference again is that the strict equal also compares type. For both the strict equal and the equal, there is a negated counterpart, which is not equal, and strict not equal. The only difference is that whatever this one evaluates as true, this one will evaluate as false. So if you want to make sure something is not equal to something else, you can use this here. So for example, if I wanted to say, as long as your name is not equal to Claire. So if you're anybody else, you're welcome. Do a refresh, we say Claire, nothing happens. Do a refresh, say Caleb, and we get in. The other ones on here are usually used for numbers. So for example, if we had an input of age, we might say, as long as your age is greater than 12, you're welcome. Do a refresh and say 14, we get access to the app. There's also a greater than equal to, which will allow the value 12. When I put a 12 in here, it still gives us access. The other ones are less than equal. So 12 and lower, put in a 4, we get welcome. And then lastly, less than, which will not allow the value 12. One thing I wanted to add is that when you're using these comparison operators, they're not using the strict equal, they're using just the double equals here. To see exactly what I mean, when you do a prompt, it's going to return a string. So age is currently storing a string, but we're comparing it to a number, and it's still possible to evaluate to true. If we did something like equals, 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 and then we put in the value 12, that's not going to work. You can see nothing happens. So overall, comparison operators are very simple and you're going to use them a lot. Now, if you wanted to do some kind of comparison, like if your age is under 13 or if it's over 65, then you need something known as logical operators. That is exactly what we're going to be talking about in the next video. It's going to be lots of fun, so check it out, guys. Please be sure to subscribe if you've enjoyed this content, which I'm sure you have. So Hey, what's happening everyone? Welcome back. This video we're going to be talking about logical operators. So back to the documentation here, we talked about comparison operators in the previous video. Now we're going to be talking about logical operators. There's three main operators: and, or, and not. They allow us to make more complex comparisons. So rather than just saying if this age is less than 13, we could say less than 13 or greater than 65 and so forth. So let's go and try some out. So let's say if age is less than 13 or age is greater than or equal to 65. Now let's try some values and see what we'll get. When we say 13, nothing happens because that's not less than 13 and it's not greater than or equal to 65. We try 12, it works. If we try 65, it works. So hopefully you guys can understand how the OR operator works. Basically, this one has to evaluate to true, or this one has to be evaluated to true. The AND operator is a little bit different in that they both have to evaluate to true. In this situation, this is never going to be true because your age can't be less than 13 and greater than or equal to 65. So this doesn't make sense, but we could do a different comparison. So let's add a name in here, and let's say this has to be equal to Caleb. I know, I'm conceited. And what we're gonna do is we're gonna ask for an age, and then what we're gonna do is we're gonna ask for a name and store that in a new variable name. All right, now what happens is we put in an age. Let's say we put in 11, and then we'll say our name is Caleb. That evaluates to true. But if either of those are false, such as, let's say our age is 66, and our name is Caleb, now only the second one's going to evaluate to true, and it's not going to output welcome. So that's how the AND works. Lastly is the NOT, and that's going to negate anything you put it beside. So usually there's an operator you can use instead of using the not operator, but sometimes you'll see it. So for example, you could use the not equals to, but let's just go through an example. You can put this whole thing in parentheses and put an exclamation mark right before it, and that'll work exactly the same as the not equal to operator. Now when we do a refresh, we could say our age is 12 and our name is Claire, and it works. That's because name is not equal to Caleb. So those are the three logical operators. As you can see, you can use multiple operators inside of the same expression. Here we have an and here we have a not. The only warning I have is I would highly recommend not mixing ands and ors in the same expression. That's because it can appear a little bit ambiguous and it's hard to tell what's going to happen. So if you ever need to do that, you can use a nested if statement. So you could go down here and do another if statement in here, which would allow us to make more complex conditionals without putting a ton of stuff in one giant expression, because it can get really confusing and hard to think through what's actually being asked. I recommend if you guys are interested in this logic stuff, check out Boolean algebra. Really cool concepts on how we can take complex conditionals, simplify them, and it's kind of the basis for a lot of computer science stuff as well as circuitry. So it's really super cool. I'd highly recommend checking that stuff out. You don't actually ever need to use these logical operators, but they do help a lot. For example, if we wanted to ask if age is less than 13 and name is equal to Caleb, we could just take the second one here, put that in a second if statement, like so, get rid of those and signs, and it's the same exact thing. We just need to take this and move that inside of the if statement. Whatever you prefer. So now the way it's going to work is, let's say we put 12 here, and now let's say Caleb. So what's going to happen is this evaluates to true, we jump down to line 5, and this one evaluates to true, so we jump down to line 6. That's another way you can visualize it. Which way you prefer is totally up to you guys. So thank you guys for watching. Hopefully you've appreciated this content, and if you do, please click that subscribe button. Definitely helps me out, and I'll see you guys in the next video. Hey, what's going on everybody? This video, we're going to be talking about how to create a switch statement inside of JavaScript. So what exactly does a switch statement look like? Well, first thing we're going to do is we're going to ask a person for their name, and we're going to give a console output that's different depending on what they type in. So first what we need to do is we need to get that name. So I'm going to say let name, and then we'll just get it from a prompt here. We can ask them, what is your name? Now what we do for a switch statement is we put the variable name inside of parentheses, such as name, and then what we're going to do is we're going to do different things depending on what the value of name is. So for example, we can have the case where the name is Caleb, and then you put a colon. Now here is where you put the code for this case, what exactly you want to happen. Now you want to end this with a break statement, and this basically prevents fall through, which we're going to talk about that in just a second. So the actual code goes between the case label and the break statement. So we can just do an output, let's say console log, and we'll just say welcome, because obviously I'm going to be welcomed. All right, now let's do another case. So let's say the case is your name is Claire, which is a bad thing. Then what we need to do is we need to do console log and say something like, get out of here. Okay, and then we need to have another break. And then maybe we want to do a catch-all case where if your name's not Caleb or Claire, and just anybody besides these two people, then we'll have a case for that. And that's known as the default case and looks like that. I guess these people can be welcome too. Awesome. So this is a way we could implement gating for our application, but maybe not the most practical example, but it'll definitely show how the switch statement works. So let's give this a try and see what happens. So what we do is we put our name in here, Caleb, and when we run this, we get a welcome as a console log here. And then if we put the name Claire, you can see we get out of here. And then if we put anything else, we get I guess you're welcome. Now to talk a little bit about this break statement here, what this does is it prevents fall through. So if we get rid of this, what's going to happen is it's going to execute this line, and then it's going to automatically go down and execute this line, even though that doesn't really make sense. So to show that, let me do a refresh. We'll put the name Caleb. You can see we get welcome, and then we get out of here. So that break is important to keep because it prevents that issue there. Now, the break on the default, you could get rid of that if you want. So even if I do a refresh here, you're not going to get any errors. It's going to work just fine. But as a general rule of thumb, I like to keep that there. One, because for other programming languages, it's required. And two, because if we were to rearrange the order of these cases, like let's say 99% of the time it's just going to be the default case, so we might want to put that up top. And if we happen to not have that break in there and we forget to add it back in, what could happen is that we move that default to the top and then we get fall through. So if we do a refresh now and click OK, we get that first message saying, I guess you're welcome. And then the second one happens, which says welcome. So we want to avoid fall through in all cases. So just as a best practice, I decide to leave that break in there. It's up to you what you want to do. And in general, I like to keep the default at the bottom, as I think is kind of standard anyways. So that's what I would recommend. Now there's one more thing, and that is if you want something to happen for numerous cases, what you can do is you can actually get rid of all the code between the cases. So we just have case Caleb, colon, case Claire, colon, and then when we do a refresh, if we put Caleb, we get the get out of here, and if we put Claire, we get out of here. So that's the only circumstance in which you wouldn't want to put a break between. You just want to have them one right after the other, and then this code block here is going to execute for both of these. So that is an introduction on the switch statement. Fairly simple. It's usually ideal for very few options. If you have a menu and you can select 1 through 5, or if you have very few options on the guessing of some code or password or whatever, then a switch statement might be useful for you. Now, if you want to get into logical operators and comparisons and all of that stuff, then I'd highly recommend just sticking with the if statement. There's nothing you can't do with the if statement that you can do with the switch. The if statement can do everything the switch can do, so if it's just mental clarity, just don't even worry about ever using the switch statement. But you will likely run into it in code, so you definitely want to know how to use it. That's all I got for you guys in this video. Be sure to check out the next one. It's going to be a lot of fun, and I appreciate you guys coming to stop by and watch my videos. Peace out. Hey, what's going on, everybody? This video, we're going to be talking about the single line if statement. That's right, it's like the normal if statement, except it's much more simplistic and does much less. So it should be pretty easy to learn. Definitely want to know of it because you're probably going to run into it in code. So that's what we're going to be diving into today. All right, now let's dive back into what we were originally diving for. And that is the single line if statement. So it looks very similar. You're going to have if, and this is really small, so I'm going to zoom in a little bit. And you have an expression in here. So for example, we can say if name is equal to Claire. Now the thing is, you just have one statement after the if expression, so you can't have two. Some people will put this on the next line like so. My recommendation is to put it on the same line. So we're going to say console.log, and we're just going to say something like hello, just anything really, honestly. And when we do a refresh, we can say Claire, and you can see it gives us that output. Now that's basically it. There's no else clause. It's all it does. The thing is, if you don't put in Claire, you put something else, it's not going to execute this line here. It can look a little funny when you're first getting used to it because you don't see the curly braces, so it's almost hard to associate this with the if expression here. But they're definitely associated, and I believe that's actually where a lot of confusion comes from, because a lot of people will put this down on the next line, like so, and then they'll think, hey, I actually want to do something else. I want to create a variable inside of this if statement. So they'll just say, like, let x be 5. And what they don't realize is that only the first statement is associated with the if and not the second one. So this one here is going to happen every single time. So for example, if this was a console log, this is going to happen every time. Yep. So when we do a refresh, and if we put someone who's not Claire, you can see we still get that output. So it's a very common mistake. I've done it. Maybe I'm just a total noob and I don't know what I'm doing, probably. So what I recommend to basically help prevent this, 2 things. First thing, by habit, you should take the statement and put it on the same line. So then when you see a second statement like this, something's not up, it shouldn't be indented there, and it's actually its own statement, not part of the if. So that's the first thing. If you always put this on the same line as the if statement, it'll help reduce mistakes. The second thing is to just not use a single line if statement. That's the easiest way to reduce confusion. But as you get better at coding, it shouldn't be too crazy. But if you're either a really early beginner or you're working with beginners, then you might just want to consider always using curly braces for an if statement, even if that means putting them on the same line. But then you know that it's very clear that only the stuff within the curly braces is being executed. So that's a single line if, very simple, nothing too crazy. Hopefully that will enlighten your life and your soul and give you peace and happiness. So that's all I got in this video. The next video we're going to be talking about something else, so be sure to check it out, and don't forget to subscribe, because that, really helps out my channel here. Thanks guys, and I'll see you in the next one. Oh, my battery's almost dead. Yikes. Hey, what's going on everybody? Welcome back. This video we are going to be talking about the ternary operator. Now, what exactly is the ternary operator? Well, we've talked a lot about operators in this series, and there's basically 3 categories that you need to know about. There's unary operators, binary operators, and ternary operators. And these categories basically describe how many operands that these operators work on. So for example, the plus operator, this is a binary operator because it will add 2 things, 5 plus 5. And there's the not operator, which is an example of a unary operator. And now we're going to be talking about the ternary operator, which takes 3 operands. And now I'm going to explain the syntax for this. It's a little bit confusing at first, and it takes some time for it to be intuitive. Even I still look at it and I'm like, what's going on here? But you will see it in code, and it's definitely important to know how it works. So basically the way it works is we put some kind of expression. So let's say we're creating a game, and instead of asking the person what their name is, I want them to ask what my name. I want to ask them what my name is, and they have to guess it correctly. So what we do is we say name is equal to Caleb. And when you read this, you can kind of think of it as a question. Is name equal to Caleb? And you end it with a question mark. That is how I remember the syntax. Then what comes next is what happens if it's true. So if it's true, we're going to say the person gets 10 points. If it's false, we're going to say they get 0 points. So you put a question mark, what happens if it's true, a colon, and what happens if it's false. And then you end the whole thing in a semicolon. Now these values will be returned depending on the expression here. And since they're returned, we have to do something with them. So for example, we can store them inside of a variable. So let's say let points equal, and then we assign it this entire ternary operator here. Now, this is going to be evaluated, and if it's true, points is going to have the value 10, and if it's false, points is going to have the value 0. So what we're going to do is we're just going to output points and see what we get. And we'll just throw it in there like that, do a refresh, Now let's guess the name correctly, and we get 10 points. Now let's guess the name incorrectly, we get 0 points. That is the basis for the ternary operator. Basically, we have an expression, true and false. Very similar in nature to an if statement. We could in fact express this as an if statement if we wanted to. That would look something like this. If name is equal to Caleb. And then if it is, we're going to set points equal to 10. Otherwise, we're going to set points equal to 0. So this is basically the if statement alternative, which should work exactly the same way. Now you don't have to use the ternary operator to return values. In fact, you could just put statements here. So for example, let's get rid of assigning it to points and let's get rid of this console log. And instead what we're going to do is we're just going to put that console log in here directly like so. And what we're going to console log is 10. And then the alternative is false, and we're going to console log 0. Just to show you guys that you can put statements in there directly. So now when we refresh, if we get Caleb, you can see it console logs 10, and if we put something else, it console logs 0. So not only can you return values here, but you can basically call statements inside of the true and false sections. So very similar to an if statement block, it can work just the same way. So that's the ternary operator. Definitely a confusing beast, but it's definitely important to at least expose yourself to it a little bit so you understand the basics of it. The main key things I got for you guys to memorize this is that think of this question mark literally as you're asking a question. So name is equal to Caleb, and then yes it is. And then alternatively, no it's not. So there we go guys, that's the ternary operator. Hopefully that was nice and juicy and helpful. I'll see you guys in the next video. I think we're going to be talking about something new, so hopefully you're prepared to have some fun. Thanks guys.
Hey, what's going on everybody? This is an in-person video, conceptualize concepts and stuff. Now I wanted to do some of these in-person videos earlier on in this series, but circumstances did not allow it. Also known as I didn't feel like it, and here I am to redeem myself. So what are we going to be talking about? We're going to be talking about loops. Yeah, nothing too crazy. So there's a few types of loops you should know about, but they're all essentially built off of the same principles. And those principles consist of 3 things. So the first, by the way, I remember it with this acronym, ICU. We have an initialization. So this is where we set some variable equal to some value. So we have the initialization, then we have a condition. It's usually a comparison, but basically this is where we compare that original variable to some other value. Then we have an update. And this is where we change the original variable, usually to get closer to that condition to where it's no longer true and we stop. So yeah, a bunch of conceptual words and garbage that aren't that important until we go through an example. So let's talk about a while loop. The way this works is we're going to start with a variable. Let's just call it I, and we'll set that equal to 0. This is a convention. I is typically used for loops. The variable is just known as an iterator or iterator. No, I'm just kidding, but I'm just going to call it I, and that's pretty common. So you're going to see I a lot. And we're going to initialize it to 0. So that's step 1. Then we have a condition. So we do something like this. While, and then in parentheses, we put some kind of expression that's going to either evaluate to true or false. So basically the code is only going to execute on certain conditions. Cool, so we can do something like while I is less than 10. Then we use curly braces to make a code block. And in here we put our code. So this is what we want to do numerous times. So this is going to keep happening, this code block right here. But at the end of the code block, we need to update that variable because if there's no change, it's just going to be a loop that runs on forever, which we don't want to do. So what we need to do is we usually do something like I++. So that's going to increase I to 1 after the first iteration. Iteration is the word to describe one time through the loop. So the first iteration, at the end of it, I is going to be increased to 1, and then that comparison is going to happen again, and then it's going to go through the code. I is going to be increased to 2, then that comparison, then the code, and then 3, and it's going to keep doing that.
So this is the syntax to create a loop that's going to execute 10 times. And the thing we want to execute 10 times is in this code right here. So whatever we put here in this code section, we just have it as a comment right now. This is what's going to execute 10 times. You should also know, if someone's mowing, they always decide to mow when I'm in the middle of something pretty important. So if you hear that, I apologize. So we can actually access this I variable inside of this code. It's just a variable like any other variable. So this means we can use loops to do things like count. For example, if we output I, it's going to basically show the value of I each iteration and put that out on the console. There's lots of things we can do inside of this code area. We can access arrays and all kinds of fun stuff. What we're going to be doing is we're going to be going over some examples of these loops. First video, next video, we're going to just go through the syntax. There's while loops, for loops, and do while loops. And then the video after that, we're going to basically go through some examples of what you can use loops for. So some hands-on practical purposes for these loops. So pretty fun stuff. Pretty fun stuff. So this is a while loop. There's also a for loop, which does essentially the same thing. It's just structured a little bit differently. And basically it's going to take all three of these pieces and put it inside of a giant parentheses. So it'll look something like this. For, and then we have the initialization. So we say something like I equals 0. Then we have the condition. We can say I is less than 10. And we put semicolons between these. And then we have the update I++. Then we have our code block and we put our code here. We don't have to do that increment at the bottom because that's going to happen automatically for us. So this is basically a syntactical sugar for this, because this is very verbose, where we're able to get all of that in one pretty line here. So generally I prefer for loops, but the purpose of them, they can do the same thing, but generally when you have something that's going to go on indefinitely until like the user says stop or something, I will use a while loop. If we have something that's going to go on a certain number of times, such as 10, I will use a for loop. That's just a personal preference, but I'm sure everyone out there has their own preference and everybody's right and according to their point of view. So that is your introduction to loops. Very, very fun. This allows us to create cool applications because we can make things happen more than once, essentially. So if you had any confusion, make sure you watch this video on loop, on repeat. And then be sure to subscribe, and I'll see you guys in the next video where we're going to code out some of these loops, and it'll be a lot of fun. There's one more loop I forgot to tell you about, which is the do while loop. The only thing that's different between a while loop and a do while loop is that the do while loop will always happen at least once, where a while loop doesn't always necessarily have to happen. And we'll go over examples of those, so don't worry about it. Thanks guys, and I'll see you in the next one.
Hey, what's going on everybody? This video we're going to be talking about loops inside of JavaScript. Now this is a follow-up to the previous video, so if you want the conceptual part of this video, go to the previous video. But overall, this video will cover most of what you need, so it's not too hard. But if you're struggling with this content, then you might want to check out the previous video. So the three types of loops, we have a while loop, a do while loop, and a for loop. And all of these loops usually have three pieces. And I remember these using the acronym ICU, as I mentioned in the previous video. So we have an initialization, we have a condition, and then we have an update. So let's go through an example with a while loop because it follows these steps in order, very easy to see. We start with a variable. We'll just create I. This is also known as an iterator sometimes, basically a variable to keep track of where we are in a loop. And we start it at 0. Ugh, if I could type. There we go. Then we say while, and then we put the code block, like so. Now inside of the parentheses is where we make a condition, so we could say I less than 10. And what this will do is it'll make a loop that goes 10 times. Because at the end of our while loop, what we're going to do is we're going to say I++. So basically we start at 0, and then every single time through the loop we increase I by 1, resulting in a loop that goes through this 10 times. Then our actual code goes here. So the actual pieces, this is the initialization, this is the condition, and this is the update. So now you can kind of see the steps. And the code, we can do whatever we want. Let's just do a console log.
I can hear my dog outside of my room getting into trouble, so I might have to step away in a second. So what we're going to do is we're just going to console log I, and each time through this loop, it'll print I, and we'll see which loop iteration we're in. So let's do a refresh, and you can see it goes from 0 to 9. So this loop will actually go through the process 10 times, 0 being the first, 9 being the 10th. You can alter these different pieces to make the loop function in different ways. So for example, if we wanted to go from 1 to 10, we could start I at 1, and we could say less than 11. Do a refresh, and we get 1 to 10. You can also change the operators here. So for example, if you don't like the less than operator, you could say less than or equal to, make this 10, and now it's still going to go up to 10. Works exactly the same way, it's totally up to you. By personal preference, I like to keep everything as the less than or greater than, and then I like to just change the numbers accordingly. You can also do whatever you want inside of the code, so this can be great to go through the elements of an array, or if you want to print something a certain number of times. This is what loops are for. And as we go into some more of the examples of loops in the next video, it'll become more obvious of what you might want to use these loops for. But now it's just important to understand the structure. So that is a while loop. Now let's talk a little bit about the do while loop. So I'm going to comment this out. The do while loop looks like this. You say do, and then you create your code block. So this is where your code goes, and then you say while, and you put the semicolon. Now remember, you need to have that semicolon there. That's one of the things that takes some time to get used to, because with this while loop here, you don't really put a semicolon after that. You just put the curly brace, and there's not really a semicolon anywhere besides where your code is. So it can take a little bit of time to get used to and make sure you remember that semicolon, but you don't want to forget it or you'll get fired. Okay, so now what exactly is going on here? Well, we're going to start with an initialization still, so we'll say let I equal 0. And then what we can do is we do something at least once. So if we do console.log and we put I in here, and then what we do is we do the comparison down here. So we'll say while I is less than 10. So when we do a refresh, oh shoot, yeah, you gotta do the increment, don't forget that. So at the end of this, you gotta do I++. So here's the initialization. Here's the code. Here's the update. Close enough. And here's the condition. All right, so the things are just a little bit out of order. So let's do a refresh. There we go, guys. Sorry about that. You definitely want to make sure you have that update in there, or you will produce an infinite loop, a loop that goes on forever until your computer basically explodes. So the only difference here is that these steps are a little bit out of order, and this do is going to execute always at least once, meaning if we set I equal to 1,000, you can see that this condition is not going to evaluate to true, so it's not going to go back and execute this section. But the do comes first, so that's always going to be executed at least once. So let's do a refresh and see what happens. When we do a refresh, we get it printed once, and then the while is evaluated to false, and it's done. So that's the difference between the while loop and the do while loop. The last type of loop I want to talk to you guys about is the for loop. So I'm going to go over that now. I'm going to bring this down here. So comment that out. Now the for loop is nice because it kind of puts everything in one spot. It's a lot easier to read over time when you get used to the syntax. At least in my opinion, I like for loops. They're nice and concise. So we basically follow the same steps: initialization, condition, and update, but they all go one after the other inside of these parentheses, separated by a semicolon. So we can say, let's create I, which is equal to 0. I is less than 10, I++. And could say lat there. Console log, and in here we're just gonna log I. Let's do a refresh, and you can see 0 to 9. Boom. Simple as that. So I like to use the for loops for things that I know how many times I'm going to do them. Like I know I want to do 10 times here. And I like to do the while loops when I don't know, so indefinitely until I say stop, basically. And then I like to use the do while loops for things that happen at least once. So those are the kind of different use cases for each of these loops. In the next video, we're going to go over some useful examples of what these loops can do beyond just counting from 0 to 9. So hopefully you guys are looking forward to the next video. I'll see you guys then, and don't forget to subscribe because that'll help out this channel. All right, peace out. Hey, what's up everyone? This video, we're gonna go over some examples of what we can do with loops. Now, if you need a little bit more context on, the syntax of loops or how they work, then you need to check out the previous video. So first, let's talk a little bit about the do-while loop. It's kind of confusing, like why would you want to do a do-while loop? Well, as a reminder, the do-while loop will do something at least once. So one example I have is in a guessing game. So you can ask the person to guess something, and you're going to do that all of the time. But you only want to ask them again if they get it wrong. So we can create a do-while loop to always ask at least once. So let's do the structure first. Like so. And remember that semicolon. I'm not going to lie, there's plenty of times I forget semicolons, but I know that I always try to remember this one. All right, so what we're going to do is outside of this, we're going to create a variable. And I'll explain why we're doing it on the outside in just a minute. And we're going to make a guessing game for like a password, right? So they have to guess the password. And we're just gonna declare it. We're not gonna assign anything. And then inside of here is where we're gonna do the assignment. So we're just gonna say password, and we're going to get the guess from the prompt. So we're gonna ask the user what they think the password is. Like so. Now, while determines how often or when we're gonna do this. So what decides if we wanna do this again? Well, if they guess the password wrong, then we want to ask them again. So we need to do a comparison. So as long as the password they guessed is not equal to, and then here's where we're hard coding that password. In more complex applications with real passwords, you're not going to be hard coding them into the code. You're going to be getting that information from a database, or you'll be like encrypting the password and seeing if it matches what's in the database. But here we're just having some fun. We're just making a little guessing game. So we're just going to hard code it. We're just going to make it let me in, because that's just what we're doing. We do a refresh, put some jargon in there, nothing happens. As soon as we say let me in, it doesn't ask us anymore. So that's how the do while loop works. If you want it to be case insensitive, then you can use a method for that, to lowercase, like so. Now we can put any casing and it should work. Yep, still works. So that is how we can use a do-while loop. That's pretty fun. Now, what are some other stuff we can do? Well, I wanted to go back and talk a little bit about for loops, and I guess this would apply for all the other loops. But basically, you can vary the three pieces of a loop. So we talked about the initialization, the condition, and the update. You can change how those work to change the functionality of the loop. So you're not always going to be counting from 0 to 10, for example. So let's go through some, before we dive into that, let's talk about why we define this on the outside of the do here. Well, the reason is because let makes a variable tied to the scope it's defined in. Meaning, if we put the let here, and then we commented this out, well, let's do a refresh. When we put something in here, we get an error. It says password is not defined. That's because once we go out of this thing, once we go out of this code block and into the while comparison, that password no longer exists. So this variable is not a thing inside of here. In order to fix that, we define it in the outer scope right here. So now it's declared in this outer scope and it exists inside of the do and inside of the while portion. So that is why we do it on the outside. Alternatively, you could use var, and I think that should work too. So if we commented this out, and now when we put something in here, it seems to be working just fine. But as we talked about in previous videos, using let over var is recommended, as var ties things to the global scope unless it's in a function. So let's just stick with let, and let's just get rid of that var and keep that declaration on the outside of the do. Awesome. Now let's talk a little bit more about just loops. So let's create a for loop, and we're going to say let I equal 0, I is less than 10, I plus plus. So this is kind of like the basic loop that we talked about. You can do the same thing with the while loop, but this is just much more easy to see because everything is one after the other. Now we can vary these things. So one example I wanted to show you guys is you can actually change the assignment here. So instead of incrementing, we could actually assign a new value. So we could say I is equal to I plus 2. And that's going to basically increment twice. So you could do this if you wanted to count by 2 instead of counting by 1. So that's a simple variation of the original loop. Now we're counting the even numbers. If you want to count the odd numbers, you could start with 1. And now I get 1 through 9. So that's one thing you could do. You could also count down. So in that case, you're definitely going to be able to do I minus minus. But before you run this, because if you're running, you're going to get a forever loop, a permanent loop. What's going to happen is it's comparing to see if I is less than 10, and it is all the time as we continue to get less and less and less. So I actually need to change this and do something like, let's say I is equal to 10, and we're going to go as long as I is greater than 1. And then I minus minus. So now it'll count down from 10 all the way up to down to 2, I think. Yeah, so 2. So if we wanted to go down to 1, we could just put a 0 there. Another thing we can do with loops is to go through an array or any list-like data structure. So for example, if we had a list up here, let's just say let list equal, and we'll just put some data points in here, like so. Nice and pretty. Well, what we can do is in here we could say I is equal to 0, I is less than list.length, and then I plus plus. So this is going to stop 1 before the length, which will grab that last index. And then instead of console logging I, what we can do is we can actually console log list index I. So now when we do a refresh, we get all of those elements, 1, 3, 4, 6, 7, 5, 4, 2, 3. We can do something similar in nature to this, but with strings. So for example, let's say we have a string and we want to search for a particular character inside of this string. Well, oh, that's not what I wanted to do. Let's just delete all this, and we'll just say, search this string, baby. And we want to search this for a particular character. How are we going to do this? Well, let's create another variable, and we're going to call this char to search, so basically what we're looking for. And let's assign this the value C. There we go. And let's just do a lowercase c because there's only lowercase c's in this string. Now let's do the for loop. So we're going to start as 0, and this time we're going to go to list.length, but let's actually change that to my string, and we'll change it here, my string, and we'll just get rid of this right here. So this should go through every character of that string. If we wanted to see that, we could just say my string index I, and that'll print every character. Yep, right there. Search this string, baby. So now all we have to do is we have to check to see if the character that is currently being printed, in this case, is equal to the char to search for. So we can do that inside of an if statement. So we'll just say if, put the curly braces. So we'll just say if my string of I is equal to char to search, then what are we going to do? Well, let's console log it. So we'll take that and put it inside of this if statement right there. Let's do a refresh. And you can see it does in fact print C. Let's print the index. So we'll say is found at index plus I. So C is found at index 4. Let's see if that's right. 0, 1, 2, 3, 4. Indeed. So we just created an algorithm to search a string. We could, if we wanted, extract this into its own function and basically have a search function. There is one optimization I wanted to tell you guys about, because if this is just a simple yes or no, like yes it's found, or yes it's found at index 4, but it's not going to search that entire string, well this is currently a waste because we're going to go up until the entire string length no matter what. So if we have a really super long string and we find C at index 4 and we're done, that's a big waste. So that's what we're going to be talking about in the next video, how to mitigate that using 2 keywords. We're going to talk about continue and break. So it's going to be a lot of fun. I'll see you guys in the next video. Yo, what's up everyone? This video, we're going to be talking about the break and continue keywords. So what exactly are these for? Well, let's take a look at what we have here. And if you don't know what this code is, it's from the previous video if you didn't watch that. But basically, it's a search algorithm. I was going to say function, but it's not quite a function. You could easily take this and basically extract it as a function, but we're not doing that right now. We're just focusing on the functionality. So what's going on? We have this string here and we're searching for the character C. And then we go through every single character, and if the character in the string is equal to C, then it's found, and it says what index it's found at. 4 in this case. The downside here is that if we're only looking to know yes or no if the character is in the string, this is not very optimized. Because for example, there could be C's throughout this entire string, and it's going to basically tell us for every single C. And in some situations, that's exactly what we want. So if you want to know every single index for a particular character, then here you go. There's your algorithm to do that. But more than likely, you're going to want to create an algorithm to basically say yes or no and at what index it was found at. Because oftentimes we just want to know the first occurrence of a character. So it depends on what you want. Whatever you want, you're going to do. But if you want to just find the first occurrence, then this is not the optimized way to go. And the reason that is because it's going to search all the way up until the end of the string length, even if it's found at the very first character. So if we have a C here, well, it's going to waste its time searching every single character of this entire string. So the way to fix that is the break keyword. So when we say break, it's going to break out of whatever loop we're currently in. So in this case, we're in a for loop on line 4, and it ends on line 9. So once this break is hit, it's going to jump to line 10 and start executing right here, whatever code we have there. So that's going to basically prevent it from going on and searching the rest of this string. So let's run this and see what happens. You can see it's found at index 0. And it depends on if there's C's in other locations, it'll just go up until the first occurrence and it will stop. So that's the break keyword. It's used to exit the function we're currently in. Now there is another similar keyword, but definitely different, and that is continue. So what continue will do is it won't break out of the loop altogether, it's just going to break out of the iteration that we're currently on. So what does that mean? It means that if you want to do something consistently for every single iteration, every single time through the loop, except for very few occurrences, then you will want to use continue. So like let's say we wanted to go through this string and we wanted to print every single character, but we wanted to skip vowels. So we wanted to skip A, E, I, O, and U. Well, we could do that with the continue keyword. So let's talk about how to do that. Basically, instead of searching this string for C, we're going to be searching for any vowels. If it's a vowel, we're not going to print it. If it's just a normal character, it will be printed. So let's go into this if statement, and instead of searching for that character, let's search for the character A. And let's say it is A, then what we're going to do is we're going to continue. Otherwise, what we're going to do is we're just going to print that character. So we're going to do a console.log, and we're going to say my string of I. Yes, you could do something very similar using else rather than continue. So if you wanted to do that, you would just say else and then put this console log inside of there, like so. Oh, I hate how it does that. And then you would get rid of that continue. So that's another way you could structure this code. It's just personal preference, what you prefer. There might be situations when a continue would make more sense. So in this case, we're going to use continue. So let's get rid of that else clause. And we're going to keep that console log at the bottom. So there we go. We're back to normal. So what are we going to do? If it's an A, we're going to continue. Otherwise, we're going to print it. So that's just one vowel, but we'll see how we can expand it to more vowels. So let's do a refresh. And you can see scrolling up, it gets rid of that A in search, and it gets rid of the A's in baby. So cool. If you want the other characters, well, you just have to use or, and then you have to repeat the expression. So my string I's compared to, instead of A, it's going to be E. And then we just have to do this like for every single character. So it's kind of annoying, but whatever. My string I equal to AEI. My string of I equal to O. And then lastly, we have my string of I equal to U. And then we can end the if right here, and that should work. So now it's going to skip all the vowels, and it just says search this string B. There you go. So that's the break and continue keywords. Very useful, very common, and you definitely need to know what they do. So thank you guys for watching. If you have any questions or comments or concerns or aspirations, let me know what your life goals are in the comment section below. And I'll see you guys in the next video. I think we're gonna be talking about nested loops, which will be a lot of fun, but you know how I change my mind every now and again, so we'll see. Thank you guys, I'll see you in the next one. Hey, what's going on everybody? This video, we're gonna be chatting about nested loops. And let me tell you what, these are important and they will come up in your coding career. So make sure you understand the concepts in this video. So let's just create a for loop and we'll just create the iterator to be I, and we'll say less than 10. So this is gonna go from 0 to 9, and then we'll just increment I. Now, just like we're using I here for this iterator, well, if we have a nested loop, there's a convention to use either like a K or a J. So we're gonna use a K. So we're gonna say let K equals 0, and then make sure you use K for all of these. K is less than 10, and then K plus plus. And then what we're gonna do is inside of this other loop, we're going to console log I comma K. So we can see the state of the variable for each console log. So what this is going to do is it's going to console log 0 through 9 every single iteration of this outer loop. So it should print 0 through 9 10 times, 0 through 9 of the outer loop. So let's do a refresh and let's just go through what's happening. So here's the first iteration of the outer loop. All of the zeros on the left here, that's the I variable. And then the ones on the right is the K variable, 0 through 9. Then I is incremented and it does it all again. Then I is incremented and it does it all again, the 2's. And then it's incremented to 3 and it goes all the way again from 0 to 9. So you can see the pattern here. Basically, this for loop is going to execute every single iteration of this for loop. That's the way nested loops work. And oftentimes, you can use the variables, the iterator up here, inside the for loop down here. So for example, we could set K equal to I. And because I changes every single iteration, it's going to change the way the loop works each iteration of the outer loop. So if we do a refresh now, let's take a look at the top. It goes from 0 all the way up to 9 for the first iteration. And then it starts at 1 because I is 1. And then the next one it starts at 2. And then the next one it starts at 3. So you can see that by referencing I in this inner for loop, we changed that inner loop to start at a different number each iteration of the outer loop. So it can get pretty complicated, and it's kind of hard to visualize here in this console just because it's like a bunch of numbers. So what I thought would be cool is if we get a little bit more practice working with HTML, and I'm going to go over some stuff on how to modify the HTML. We're going to get into this in more detail later on in this series, but for now you can just follow along and see what we can come up with. So let's create some code to basically create like a pyramid-like structure, and you can do that very easily with nested for loops. So here's what we're gonna do. Oh my golly. So let's go through an example where we want to create a loop that for the outer loop, it's going to go from 0 to 9, and then the inner loop, it's going to count down from whatever the outer loop is. So when you look at the big picture, what's going to happen is it's going to print 0, and then it's going to print 1 0, and then it's going to print 2 1 0, and then 3 2 1 0. You guys get the picture. And basically it's going to make a triangle-like structure. So it's a little weird to visualize in our brain right now, so what we need to do is we need to work with the HTML to make this print out on the screen here. So go over into the index.html, and what we're going to add in the body here is we are going to create a div, and we're going to give it an ID. We'll just say destination. And what we're going to be able to do is get a reference to this div to allow us to append information right here. So make sure you save it, and then back in the JavaScript file, what we need to do is up top, we can say let d, that's just the name that we're going to use to reference that element. And then we call a function document.getElementById. And we pass in the ID of destination. So that is how we get a reference to that element. Now we can talk to that element using this d variable. Now what we need to do is we need to change this inner loop a little bit because we want to count down from I. So we need to set k to I, and then k is greater than or equal to 0, and then count down. Awesome. So let's just do a refresh and see that console log. make sure it's doing what we want. So it does 0, and then it does 1, 0, and then 2, 1, 0, and then 3, 2, 1, 0, and then so forth. So it seems to be working. So instead of doing a console log here, what I actually want to do is I want to append to that element. So we can say d.append, and then we can just put whatever we want in here. So we could put k, and then we'll just put a space like so. Awesome. Now let's do a refresh. Let me get rid of this a little bit. All right, so we do a refresh, and it seems to be working, but it's not quite there. What we need to do is we actually need to put a break, because this should be on its own line, and then this should be on its own line, and then this should be on its own line. So what we can do to do that is in here, after the for loop, after the inner for loop, because we want a space after each iteration, we could say document.createElement, and then inside of parentheses, BR. So this is how we create a break, and we need to assign that to a variable. So we're just going to assign that to BR, and then we just say d.append child and pass in that variable. So that is the syntax to create a break, do a refresh, and there we go. So it goes 0, 1, 0, 2, 1, 0, 3, 2, 1, 0, and so forth. So that's a little bit of fun with some nested loops. It seems kind of pointless right now, but later on it will make more sense once we have nested lists and so forth. Lots of useful information here. Make sure you guys understand how this works. Nested loops was one of the hardest things I had to get over to really become better at programming. But once I got it down, I finally understood that they can be used for lots of different things. So make sure you understand this inner loop, how it references the variable here, and how each one of these is printed out in what order. So thank you guys for watching. If you have any questions or comments or concerns, let me know in the comments below, and I'll see you in the next video.
Hey, what's up my nerds? This video we're gonna be talking about arrays in JavaScript. So yeah, finally something a little bit new. All right, so what exactly is an array? Well, you can think of an array as a collection of things. So the way you create an array is like this. And then you give it a name, and typically all the stuff in the array is going to be related in some way. So typically it'll be of the same thing. So for example, we could have ages. So every element is an age. And then you create the array with square brackets, and then you can put the items in here. So we could say 12, 34, 15, whatever we wanted to put. And then we close it with the square bracket, and then you put the semicolon. So square bracket, elements, square bracket, semicolon. So the things inside of it are typically known as elements. Now you might also hear items or members. I believe the official term is elements, but you don't have to be super anal about that. Just pick something. Usually it's elements. So when people are talking about the elements of an array, they're talking about the members or the items inside of the array. Now, every single element gets an index. So an index is basically a way to describe what position these elements are in. So the first item has index 0, the second has index 1, and the third has index 2. So it starts as 0 and counts up. So it's always one less than the item number. So if we're talking about the third item, then it's the second index. And you can reference that item using that index. So if you wanted to get that item, you just say ages, and then in square brackets, you would just put a 2. And this is going to basically give us the value 15. So it's a dynamic way of grabbing that element. So rather than hard coding 15, we can store that in the array and then just reference that position. So that's going to come up a lot, especially when we're talking about loops, because you can use a variable in here. So for example, you could do something like ages I, and that I can come from a for loop, for example. So there's a lot of stuff you can do with the indexes. Now there's another thing with arrays you need to understand, and that is the array length. So if we do ages dot length, this is a property. And what this is going to do is it's going to tell us how long the array is. So in this situation, it would give us 3. So we can use that to make sure we don't go beyond the end of the array. So if we need to make sure we stop at some point. So for example, if we just kept increasing I, we need to know when to stop. And we can use that length to figure it out.
So you also got to keep in mind that the index is always one less than the number of elements. So this is 3, but the highest index is 2. So you want to make sure you don't go to I equals 3. You want to stop at I equals 2. So you can always use ages.length minus 1. So in general, if you do ages.length minus 1, that is going to be used to grab the last element. Now, one gotcha with JavaScript arrays is that there can actually be gaps in the array. So what exactly do I mean by that? Well, we might have ages.length being, let's say, the value 30. But there might only be 3 elements in there and then 27 undefined. Yeah, so JavaScript arrays are kind of annoying in that way, but you just kind of got to get used to it. So for example, here's something we could do. We could take ages.length and we could assign that the value 30. And that didn't actually add any valuable data points in the array. It just changed the value of this property. So other languages might have this same property, but it's probably read-only. In JavaScript, you can write to that property, meaning you can change the length. And then all of those extra spots that get added onto this array, they're just empty, so undefined. So this means that there can be gaps. The other thing is we can actually assign a value to an index that doesn't exist. So if we did ages of 100 and assigned that the value, hey, for example, well, this is actually going to do the same thing. It's going to extend that length to 101. Why 101? Because the length is always going to be at least 1 more than the highest index. So those are 2 things you got to know about JavaScript arrays. 1, you can change the length property, putting gaps in the array. 2 is that you can assign to an index that does not exist and it will extend that array. So JavaScript is very loose in this nature, so you just got to make sure you know what you're doing. For example, if you're using a for loop to go through all of the elements, well, it's going to hit every single index, whether or not there's an item there or not. So in order to fix that, there are other ways to go through an array, or you can do a conditional inside of the for loop. There's different ways around that, and that's what we're going to be talking about later on in the series. But for now, just be aware that the arrays can have gaps. That's all I got as an intro to arrays. What we're going to be doing now is in the next video, we're going to briefly discuss multi-dimensional arrays, how they work and what they look like inside of JavaScript. And then we'll be getting on the computer, typing some of this stuff out and getting some hands-on experience. So hopefully you guys are excited for the upcoming videos. I'd really appreciate it if you would take the effort to subscribe to this channel. It means the world to me and definitely helps me out a lot. So thank you guys. I'll see you in the next video where we're going to be talking about multidimensional arrays. Hey, what's up everybody? Welcome back. This video, we're going to be talking about the concepts from multidimensional arrays. Now, do me a favor and check out the previous video if you need array foundations, and check out the next video if you need the code for arrays. Now, what do I mean by multidimensional? Sounds fancy, sounds scary, it sounds like we're getting into some like parallel universe junk, but not really. All we're doing is we're just talking about arrays inside of arrays. So arrays can contain anything, meaning we can create an array. We'll just call it stuff because, you know, it's just stuff. And in here we can put a number. We could even put a string. In fact, you could put a custom object in here, or you could put a function in here. So what we could do is we could say function, and we could basically just make a function on the fly like so. So that's a function that does nothing. And another thing you can put in here is an array itself. So you could put an array like so. So here we're adding an array with 3 elements, and that's all inside of this bigger array called stuff. So the only way to get to this would be through stuff. So typically when you're using multidimensional arrays, it's not going to be just a bunch of junk thrown into a variable called stuff. Like that's a very bad thing to do. More than likely there's going to be a structure where every single item has some kind of meaning. So a better way to use multidimensional arrays would be to think of a table. So a common example that people use is a grade system. So if we wanted to do a single array, we might have something like let grades, and this might be, you know, some grade percentages. So 36%, 12%, 44%, and you know, my typical high school grades. So these grades might represent grades on a test, but whose grades are they talking about? This means if you wanted to have grades for multiple people, you would need to have multiple variables. So this might be grades for Caleb, and then we have another one, grades for Claire, whatever it is. But that's really not the ideal way to do it, because we don't want to just introduce variables, because it's not easy to make things dynamic, right? Because then we're basically hard coding that stuff. We're not storing it in a data structure. So a more appropriate thing to do would be to make a multi-dimensional array. So ignore all this stuff and let's start from scratch. So we have a variable grades, and what this is going to do is it's just going to serve as a container for all of the grades. So we can just open it, and then when we're done we can just close it. I don't know if you guys can see that, but I definitely closed it. Let me move that up a little bit. There we go. Now inside of here, all we gotta do is we create more arrays. So we could have one in here, 36, 12, 44, and then end it. Then we can use a comma and put another array. Like so. And you can keep doing that to add more students' grades. And because JavaScript's very dynamic, you could have like the first element be the student's name or their student ID or whatever. You can basically come up with some kind of convention, and you can follow that to basically understand how to interpret an array like this. Now I mentioned earlier, if you wanted to access one of these arrays that's inside of another array, the only way to do that is through the original array variable. So if you think about these as individual elements, so just kind of giant blobs. And let's say we want to grab the second blob. So this blob right here. How would we do that? Well, we would say grades, and then inside of square brackets, we would use index 1, because this is going to be index 0, and this is going to be index 1. Okay, and this is essentially going to give us this element, which just happens to be an array. So, since it's an array, why don't we just add another box and say what element we want to grab of that? So if we wanted the entire array, boom, we got it. If we want an individual element in this array, then we just add another square box, square brackets, and we could say 2, for example. So grades 1, 2 is going to grab this element right here. So that is how multi-dimensional arrays work. It just works the same. Just remember, if you don't want the individual element and you want the array, then you leave it at that. If you want an element, you add that extra square bracket. So that is how multi-dimensional arrays work. Yes, it can get more complicated. You can have arrays of arrays of arrays, of arrays of arrays of arrays, and just arrays for days. So there's so many different ways you can do this, and not every single array is going to have exactly 3 elements. That's just convenience. So you got to be careful. You don't want to assume everything is nice and square. JavaScript is nice because it's so easy to work with. You can put basically whatever you want in here. But the consequence of that is that when we're working with it, we have to be more concerned that the data structure is not appropriate for what we're trying to do. So keep that in mind, and we'll be going over some examples of how to work with arrays in the upcoming videos, and it's going to be something you're doing forever. So make sure you understand arrays. Super, super important. Thank you guys for watching. If you've enjoyed the content, please do me a favor. Just hit that subscribe button and share this video with 5 of your friends, if you got that many. I'm not saying that in a mean way. I just think of like how many friends I have, and like I might be able to come up with 5. Yeah, probably about 5. Yeah, so not to get all depressing and stuff, but 5 is plenty for me, and it's more about depth than quantity in my opinion. So I'd rather have 1 really good friend than like 10 shallow friends. And if you consider family members, then that number is much more, because like I consider myself pretty close with a lot of my family members. So I would consider them my friends, you know what I'm saying? But what does this have to do with multidimensional arrays? I don't know. So peace out, guys. I'll see you in the next video.
Hey, what's going on, everybody? This video, we're going to be going over JavaScript arrays. Now, this is kind of a follow-up of the previous two videos where we talked about arrays conceptually. Now we're going to be going over some examples that I have here in my notes just to start working with arrays and see how they work. All right, so where do we even start with arrays? Well, let's just talk about how to create an array. We'll just say let grades, and we'll just put some values in here. Anything can go. So that's an example of an array. And we can console log this array very easily. Just like that. And there you go. Now you can see we define it using these square brackets, but whenever you're talking about the array itself, you'll never use those square brackets. So when you see square brackets, that's usually used to grab an element inside of that array. So for example, if you want to grab that second element, you put a 1 because it's 0 based. Do a refresh and we get 43. So this one's index 0, this one's index 1, and this one's index 2. Awesome. Now it doesn't have to be just numbers, so just to show you guys some examples, we can put whatever we want in here. We can put a string, we could put an object, we can put a function even. So here's a function that does a console log, and it's just going to console log hello. So if we wanted to call that function, for example, it would be index 0, 1, 2, 3. So all we would do is say grades of 3, and then call it using the curly braces. So do a refresh, and look at that, we get hello. Now the reason we're getting this undefined here is because we're calling the function inside of a console log, meaning it's console logging the return, and because console log doesn't return anything, it's just doing undefined. So to get rid of that, we would just get rid of this console log right here, and there you go. Now it's just saying hello. So there's just some examples of what you can do with arrays. So it's very versatile, you can be very creative. And another thing I wanted to mention is that you don't actually have to put all the elements in here. You can actually add them one at a time. So for example, let's just say we have an empty array like so. What you can do is say grades of 0 and set this to some value, let's say 12. And then you can go grades of 1, set that to some value, say 43, and so forth. You can just keep going. Now the thing is, you can put any index in here. So you could go grades 40 and set that equal to 2. So now when we do a console log of grades, it's going to have a bunch of gaps. So you can see it's empty times 38. So those are just undefined, meaning that there's nothing in those spots. So we have 12, 43, and then 38 undefines, and then we have a 2. So that means in a for loop, if we have for let I equals 0, I is less than grades.length, and then I++, well, this is going to hit all of those undefined. So if we console log, and what we're going to console log is grades of I, this is going to go through each element and write it to the console. You can see a lot of undefines are going to be written, 38 of them exactly. So the thing to know here is that if you want to avoid gaps, make sure you always count by 1. So this would need to be a 2, and there you go. So you can see that you can just write to the end of the array whatever index you want. No worries about that. It works perfectly fine. JavaScript does not care. Another thing JavaScript does not care about is if you change the length property. So you can do grades.length and set that equal to whatever you want. And now when we do a refresh here let me scoot this up to the top. Now when we do a refresh here, it's just going to put a ton of undefineds, and I think it's loading still, so it might take a little bit of a while. So setting the length to some giant number just fills the array with a bunch of undefineds. One thing with the length is that it's at least going to be one more than the highest index, meaning that if there is some index we create that's higher than the length, so let's say we manually set the length to 300, and then we say grades, and then we say, let's make 350 equal to some value. Well, if we console log length here, it's going to be 351. So I'm going to get rid of this for loop because we don't need that anymore. So now when we do a refresh, we get 351. So you can see that the length is always going to be at least one higher than the highest index. I say at least because it can be more. So if we manually set the length to something really big, such as 300, well, in that situation, it's a couple hundred higher than the highest index, which is 2. So now you can see a little bit more about working with the indexes as well as with the length. The other thing you should know is that the length can also crop the array. So if we have an array of a bunch of elements, let's go in here and just fill it with stuff. Well, like so. And then we go in here and set the length to 3. What's going to happen is it's going to crop that array to the length of 3, meaning it's going to be 3, 4, 4. So when we do a refresh, you can see that's what we get here. And this can go, we don't need that anymore. So this is what will happen when you make that length shorter than the highest index. So that should give you some basics using arrays. In the next video, what we're going to be doing is we're going to be talking a little bit more about iterating through the array, but we're going to go through some cool applications, specifically searching an array, as well as finding like the biggest element or something like that, if that's what you want to do. So be sure to check out the next video, and I'd really appreciate it if you guys would be willing to subscribe to help out this channel. It means a lot to me, guys, and I'll see you in the next video. Peace.
Hey, what's going on, everybody? Welcome back. This video, we're going to be talking a little bit more about arrays, just to go through some examples. We're going to go through a couple of examples in this video, and then a couple more in the next video of just what we can do with arrays. Specifically, we want to talk about looping through these arrays with for loops, and just some different algorithms we can do. So we're going to search for stuff in an array. We're going to take the average of an array. We're going to get an array elements from user input. Lots of cool stuff. Say hi. The first thing I want to talk about is just iterating through the grades array. Now we have talked about this a little bit in this series, so this might be a little bit of a repetitive thing. If it is, that's fine, just get some more practice here. So let's go over the syntax for the for loop again. It's going to have 3 pieces. We're going to have an initialization, so we'll say let I equal 0. And this is going to, the second piece is the condition, so I is less than grades.length. So this is going to go through all of the elements in the array. And then we just increment I each iteration. Then we can just console log each element by doing grades of I. Awesome. So when we do a refresh, we get all of these pieces. Now the thing is, this will also print undefined. So if we do something like grades.length equals 30, or if we do like length or grades of some index that doesn't yet exist and set that equal to a value, that will also put undefined inside of this array. So you can see here we have 24 undefined. So if you want to skip those inside of your array, the easiest way to do that is to just put a conditional in here. So basically we're just going to check to see if it's a legit value. The way you do that is by seeing if it's not undefined. So if grades of I is not equal to undefined, then it's legit. And what do we want to do when it's legit? Well, we're just going to console log it. So paste that right there. Do a refresh, and you can see those undefined go away. So that's the first thing I wanted to show you guys, is how to skip the undefined. Next thing I want to show you guys is how to search an array. We did something similar to this with strings earlier, but now I want to show you guys with arrays. This might also be some review. So we're going to have 2 variables. First, we're going to have a flag, which is just found. So this is going to be false by default, and we're going to basically search. And if it is found, then we're going to set this to true. We're also going to have a variable search, which is just going to be what we're searching for. So like, let's say we're searching for 43. And this is a number, so we don't want to quote that. Sorry about that. So now what we're going to do is we're basically just going to iterate through every single thing. And if grades of I is equal to, so replace that not equal to with equal to search, then that means it's found. So in this case, we found the item, and we can just console log the value there. So when we do a refresh, you can see we get the value 43. If you want to get the index, you could just say something like at index and then put I. So do a refresh, 43 at index 9, which should be right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So yes, that is correct. Now this will go and count any 43s we find. So no matter however many there are, it's going to print each one. If this is not what you want, this is where the break keyword comes in. And we talked about this when we talked about break and continue. So if you put break, it's going to stop after the first one and just do that first one there. So that is how you search within an array. Now you could also put found equals true in here, which is why I have this flag up here. So found equals true. In this case, that can be a flag that you can later use. So after the for loop, you could do something like if found do something. So that's if you need to reference whether it was found or not later, you can do that way. So that's basically how you do searching in an array. That's pretty fun. Next thing I wanted to do was talk about finding the biggest element in an array. You could also modify it to find the smallest or something like that. So the way this is going to work is I'm going to look for the largest number. So let's say 66 in this case. The way we do this is first let's get rid of these variables. We're going to create a new variable and call it largest. And this is going to keep track of the largest number. And at the beginning, we're basically just going to start at the beginning and just scan through this for any large numbers. So we're just going to assume the first number is the largest. So we'll just say grades of 0. And then we're going to basically check to see if any ones are bigger, and if they are, replace largest with that new number. So we're going to continue, and we're going to continue looping through the entire array. But instead of this equals equals here, what we're going to do is say, if grades of I is greater than largest, what we need to do is we need to replace largest. How are we going to do that? We're just going to say largest and assign it the value grades of I, like so. Awesome. Then down here, we could actually console log the largest. Do it refresh, and you can see we get the value 66. So that is how you would do that. You could do the same thing with the smallest by starting at the beginning, changing up the comparisons, and so forth. Now, I have a challenge for you guys. So if you guys want a little bit of a challenge, I want you to rewrite this code, but instead of keeping track of the largest number, I want you guys to keep track of the index of the largest number. So instead of getting 66, you would get 0, 1, 2, 3. So rewrite this code so that you get 3. And then just change it up to make sure it works and that you got all your code correct. This stuff's pretty important. It seems just kind of like challenges for no purpose, but later on you're going to build complex code that you can basically extract into functions and build a function library of useful stuff for your program. So definitely something you want to understand, especially if you want to get more into algorithms and data structures. This stuff is very important. The next video, we're going to do some more of the same stuff, but we're going to actually do a challenge to find the mean of this entire list. And we're also going to talk about how to fill an array using user input. So very cool. Hopefully you guys are excited. If you've enjoyed this content, please consider subscribing, as that really helps out my channel, and I would be forever grateful. Thank you guys, and I'll see you in the next one. Hey, what's going on everybody? This video, we are going to be talking about how to average a bunch of numbers in an array. And on top of that, we're going to be talking about how to fill an array using user input. So we're basically going to create a loop that just keeps on going forever until we tell it to stop. Each iteration through that loop, it's going to add an element to this array. So it's just a little bit more practice with arrays if you still need a little bit of, sharpening them array skills. All right, so let's go into this and let's first do the average. So how do we do an average? Well, we add up all the numbers and then we divide by however many there are. So the one issue with this that I'm just going to deal with up front is that there can be gaps, and we don't want that to skew our result. So what we're going to do is inside of the for loop to loop through the array, we are going to check to see if the value is undefined. So let's just clean this out and get what we absolutely need. So we're going to have an if statement inside of here, like so. All right, so nice and clean. That was just some code from the previous video. So we have a grades array defined, and you can console log grades if you need to see how that looks. Basically, there's a big gap where we have a bunch of undefineds because we set the length, and then we used an index that doesn't yet exist. So there's about 24 or so indexes that are not being used by legitimate values. So when we iterate through this entire array, we need to check if it's a legit value by saying grades of I is not equal to undefined. If this is true, then it's a legit value. So we want to know how many elements are in the array, but we can't use the length because length counts the gaps. So we're actually just going to create a new variable. We're just going to call this, I don't know, count. And we're going to set that equal to 0. And every time there's a legitimate value, what we're going to do is we're going to do count plus plus. So that's going to count how many things we need to divide by. So once we add them all up, we can divide by count to get the average. So now for adding them all up, let's create another variable, and we're just going to call this total. Set that equal to 0. And each iteration through the array, we're going to do total plus equals grades of I. And that'll add the value of whatever index we're at to this total. And then later we'll just take total and divide it by count. Down here, we can console log the output. Let's actually store it in another variable. So we'll just say let average be total divided by count. That should give us the correct thing. And then we just console log the average. You could just put total divided by count inside of the console log. Totally up to you. Refresh, and we get 24 point something, something, something. So let's just add this up to make sure it's legit. When we add them all up, we have to remember this 40. I was adding it up and I could not get the right answer. That's because I was only looking at this list up here. So what we get is a total of 317. And then we have to divide that by a total of 13 to give us 24.38. So it looks like it did calculate it correctly. So awesome. We're not complete failures, just partial failures. So that is the algorithm for calculating the average. You could definitely extract that into your own function and take some arguments and return a value. I'd encourage you to try that if that's something you seem interested in, especially if you want to get some more practice with functions. The next thing I wanted to talk about is how to fill an array from user input. I decided to save that information for the next video. So the next video, we're going to be able to go into that a little bit more detail, spend a little bit more time on it because we're going to be creating a new type of loop. Still a while loop, but it's an indefinite loop, and you're going to learn some new words like set no value and a bunch of cool stuff like that. So check it out, guys. If you've enjoyed this content, please let me know and be sure to subscribe. It really helps out this channel and means a lot. Thanks, guys. I'll see you in the next one. Hello, everyone. This video, we are going to be talking about how we can fill a JavaScript array from user input. And the way we're going to do this is with an infinite, or I guess I should say indefinite loop. Meaning this loop is going to go on for as long as it will until we tell it to stop. So how are we going to do that? Well, we're going to use a while loop, and we're going to put true in the parentheses. So this means it's basically going to continue as long as this is true. And because we put true there, it will always be true. Now let's talk a little bit more about this loop here. This is an indefinite loop, meaning we need to tell it when to stop. First, we're just going to build an infinite loop, and then we'll talk about how to make it stop. So what we're going to do is we're going to get user input. So we're just going to say let input equal, and then we'll just get it from a prompt. And we're just going to say add a grade. Golly, my dog is annoying in a good way. What are you going to do with this grade? We're actually going to add it to the array using grades.push. So this is a method that is available to arrays, and it's just going to basically append whatever you put inside of these parentheses to the last position in the array. So we'll just put the input right here. Now the thing is, if we do this, it's not going to work quite the way we expect. Let me show you. First, let me comment out this loop so we're not stuck in an infinite loop. And then we'll just console log input. Actually, let's console log grades so we just get the entire array. When we do a refresh and we add a grade such as 5, you can see it's stored as a string. Maybe not the end of the world, but in general, we want to store them as numbers because they are numbers. So the way we can do that is pass input into the number constructor. So this will take anything and give us back a number. Awesome. So now when we do a refresh, put the value 5, you can see it's stored as a number. So that's the first step. Now we can get that loop back. So we have a way to continually add items to the array, but we need a way to tell it to stop. So what we're going to do is we're going to get a value from input, and if it's a particular value, we're going to stop the loop. This is known as a sentinel value. It's basically a way to cancel. So what we're going to do is we're going to say if input is equal to, and then let's just go with Q. This is basically short for quit. So if the user puts a Q, it's just going to stop. And then we just put a break. That's going to break out of that loop and it's going to be done.
So we'll do a refresh, put a 5, put in a 4. You can see it's adding to the array, but as soon as I put a Q, it stops. Perfect. So the only other thing I would say about this is that we also want there to be null. So if we say input is equal to null, now when we do a refresh, if we press cancel, it'll also be done. Without this input equal null, what's going to happen is it will just continue to ask us. Frick. Oh, I got to save. And you can see when I'm clicking cancel, it's going to continue to ask us. So we got to make sure that we have that in there. Now let's get out of that with Q. Awesome. So that is basically the syntax for creating an indefinite loop with a sentinel value. If we press cancel, the input is going to be null. We can also put Q to cancel it. You could put whatever you want. I just decided on Q. Later on, I think this could be converted into a very pretty user interface where maybe there's an input and you can continually add a grade and it'll list the grades in a nice pretty fashion on the side. Whatever you want to do. But right now, my focus is just on loops. We're just going over the concepts. Later on, we'll get into manipulating the UI and maybe we'll go back and implement that. So let me know what you guys think, if you think that'd be a good idea. Let me know in the comments. And yeah, that's all I got for this video. I'll see you in the next one. And if you're wondering what we're talking about, well, you see this push method here? Well, there's actually a lot of different array methods. We're gonna be going over some of the most popular important methods to know. Thank you, and now I'll see you in the next one. Yo, what's up everyone? It is a new day here, and let me tell you, I am ready to make some more tutorials. So hopefully you guys are ready for some cool new stuff. We're gonna be going over lots of different array methods. This will help us work with arrays a little bit better. Now, where are we gonna go with these arrays? Well, I was thinking maybe it'd be kind of cool if we went a little bit more onto the console side here and just worked with things a little bit more dynamically. So I'm gonna try that for a bit. So what we're gonna do is I'm gonna drag this code editor over just a bit, expose my hedgehog here. Over here, we can dynamically code. So what we can do is we can create arrays on the fly. So I could say let grades be an empty array. I could go in here, I could put values in here as well. And when we press enter, it will give us whatever return there was. And an assignment doesn't have any return, so we get undefined. When we call methods that return things, we will get that value here. The first method is push. We actually used this in an earlier video. The way this works is you would just say grades.push, throw in a value inside of the parentheses. And what this is going to do is it's going to change the original array. And that's important to understand. So when we do this, the original array is being changed. Meaning when we talk about grades, it's not going to be 1, 2, 3, it's going to be 1, 2, 3, 4. When you press enter, it's going to return the new length of the array. So if you do grades.length, you're going to get 4. Now when we do grades, you can see the new array is changed. We get 1, 2, 3, 4. Now when we type out grades, you can see we get a new array 1, 2, 3, 4. So the actual original variable has been changed. A similar method is .pop. And what this is going to do is it's going to pop off that last element. So when I press enter here, we get the value 4. So it basically popped off that 4 that was at the end and gave it to us. If we were using this inside of code, because it has that return value, we're probably going to reference that and use that. So we might want to do something like let popped value equal grades.pop, something like that. And then that 4 is going to be assigned to this variable popped value. That's only if you need to reference that value. Assigning it to a variable is not required. You could just call grades.pop if you're just trying to get rid of that value. So let's just do this with a couple more examples. Let's push some stuff on here. Let's push a 4. Let's go 5, just so we can get some different numbers in here. Push a 60. Push a 603. And now when we do grades.pop, what's going to happen is it's going to first pop off 603, then 60, then 5. So we do a pop and we get a 603. Do it again, we get 60, and then do it again and we get 5. This is a first in, last out technique. So the ones that you put in first are the last ones to be removed. All right, so two very similar methods we're going to be using are shift and unshift. Now, these are going to work very similar to push and pop, but instead of at the end of the array, it's going to go at the beginning of the array. So just like push adds an element, unshift is going to add an element at the beginning. Pop removes an element from an end. Shift removes the element from the beginning. So it's easier just to see that. So let's see what grades is right now. grades is 1, 2, 3. If I do grades.unshift and pass in a value like 40, what's going to happen is it's going to give us that new length, and grades is now 40, 1, 2, 3. So very similar to push, but it goes at the beginning. Shift works in a similar nature to pop. It'll get that element off the beginning. So we just say shift, and it's going to return us that value 40. I also wanted to show that you can put multiple items in at once if you just separate them by commas. So now the new length is 7, and the actual grades array is 1, 2, 3, 40, 20, 10, 40. Great, so you can use pop and push, as well as unshift and shift to work with the end and the beginning of the array. But what if you want to work somewhere in the middle? Well, the first thing you need to understand is that when you have an array, you can access any element using the index. So we could say grades, and let's say we're trying to grab the 40 here. It's going to be 0, 1, 2, 3. So 3 is going to give us 40. And we can assign this any value we want. So that is how you change a value inside the middle of an array. But sometimes you don't just want to change one value, you want to change a section. And that's where the splice method comes in. So splice can be used to add and remove elements from the array. So first we're going to talk about deleting with splice, and then we're going to talk about adding with splice, and then we're going to go into replacing with splice, which is similar to what we did here. We replaced 40 with 40,000. You can do that, but at a whole new level using the splice method. So let's talk about delete. The way this works is we say grades.splice, and then let's say we pass in a 2 and a 3. What this is going to do is it's going to start at index 2 and delete 3 items. So 0, 1, 2, it's going to delete 3, 40,000, and 20. And it's actually going to return a new array of those deleted items. So if you wanted to use this array in code, what you could do is you could pass this method call as an argument to something, or what I would recommend is just assigning it back to some variable. For example, it could be called grades removed, and then it's going to contain 3, 40,000, and 20. Now the original array is modified. You can see that those elements are indeed removed, and now we only have 4 length. So we have 1, 2, 10, and 40. Now to add to the array, it's a little bit more confusing. What we need to do is we need to say grades.splice, and we're going to pass a bunch of stuff in here. So the first is where to start at. So we could say 2, and then the next is if we want to delete anything, similar to how we did up here. So we'll just say 0 because we don't want to delete anything. And then the next data is the information we want to add. So for example, we could add 5, 6, 7, and 8. And then when we press enter, we get what was removed, which was nothing. So then when we say grades, what happens is we get 1, 2, 5, 6, 7, 8. Then we get 10, 40. So you can see that the start of the data we wanted to add is indeed at index 2 because we get 0, 1, 2. So here's where that data starts. So after that data, it just continues with what the array used to be. Now I want to challenge you guys to try to replace something using the information we talked about here. What if we wanted to replace the 5, 6, 7, 8 with zeros? How would we do that? Pause the video, maybe give it a try. And now I'm going to give you guys the solution. All we would do is say grades.splice. The first index is going to be 2, and then instead of leaving this as a 0, we're going to delete 4 of them. So we would say we're going to delete 4, and then we're going to replace that with 0, 0, 0, 0. So running this, we get the deleted items, and then grades is now 1, 2, 0, 0, 0, 0. So that is how you do a replace with splice. In the next video, we're going to be talking about how to use functions to sort an array, reverse an array, and all kinds of other variations. It's going to be a lot of fun. Hopefully these things seem useful. Later on, you might run into using these things. Right now, it just kind of seems like a reference, and it kind of is just a reference, but it is helpful to know that these things exist. So thank you guys for watching. Please consider subscribing if you enjoy this content, as that really helps out this channel and means a lot to me. All right, I'll see you guys in the next one. Hey, what's going on everybody? This video, we're going to be continuing our discussion on array methods. We're going to go over some pretty cool array methods in this video, so I'm hoping you guys are excited. So the first thing we're going to be talking about is sort. Very simple. We just say grades.sort. And we run this, you can see we get things sorted, right? It seems to be working. But let's go in here and let's put some more data. So let's say grades is equal to, actually let's just push stuff on here to make it longer. So we're going to push on just a bunch of numbers. There we go. And now let's do grades.sort. Awesome. So you might be wondering, like, what is going on here? This doesn't seem sorted. It kind of looks sorted because it goes 0, 1, 2, 3, but you can see it has like 23 and then 3 and so forth. Well, the definition of sorted is all depending on how you define sorted. By default, this is going to sort almost as if it was alphabetically. So the ones are going to come, well, zeros are going to come first, then ones. 1 comes before 1 0, 1 3 comes before 1 5, and you can kind of get the picture here. So this is not looking at the size of the number, rather it's looking at the first digit in the number, and then putting all of those together, and then sorting again by the second digit, and so forth. So this can actually be changed the way this works. So for example, you can do a callback function, which is basically just a function that gets called for every single element in this array. And the way this is going to work is we're just going to define a function inside of here. So we're just going to say function, and then inside of the inside of the curly braces here, we're going to say return a minus b. And where's the a minus b going to come from? Well, it's going to come in as arguments to this function. So we're just going to say ab. Awesome. So now it should be working the way we expect. And if you don't understand what all this junk is, well, we're actually going to be talking about callback functions, and we'll probably go through this example in a little bit more depth later on in the series. And just in case you're dying to know, whatever the return of this is, if it's negative, it tells us to flip the numbers. So doing a minus b will tell us if the numbers are in numeric order. But once again, we'll get into that more later on. The next method I want to talk to you guys about is the reverse method. So what we can do is first let's put grades here. And that is what grades is right now. What we can do is put grades.reverse, and in this situation the last will be first and the first will be last. Do keep in mind that for the methods we've been calling, it alters the original array. So that's why we're calling grades here, and they stay in this reversed order from this reverse method call. So keep that in mind, it's very important. Not all methods work that way, so you need to understand when methods alter the original variable and when they just return the new version. Alright, now I'm going to be teaching you guys a method that I honestly am not really sure what you do with it, but it's kind of cool, so let's just learn it anyways. So we have grades, and here's what we're going to be doing. We're going to say grades.fill, and what this will do is it will fill a section of the array with a particular value. So what value do we want to use? Let's say -1. Where do we want to start? Well, we could start at index 0, and then we could go all the way to grades.length. Like so. Now it's important to understand here that this third argument is actually the index to stop at, not including that index. It's not the length of how many you want to change. In this situation, we're starting at 0, so it's going to be the same either way. So if we did a 4, it's going to stop at index 4 and change 4 of them. But if we started at a different index, say 3, it's important to understand that this is not the same thing as saying we want to change 4 of them. This is just saying to stop at index 4. So try to keep that in mind, and now let's go back to the original, which was grades.length. Another thing to understand is that this is the index to stop at, but it doesn't include that index. So for the beginning one, it's inclusive. For the ending one, it's exclusive, which is why we're using grades.length and not grades.length -1. This is going to allow us to change the entire array. And you can see it replaced everything with -1. So yeah, that might be useful for something. The next video, we're going to go over arrays for just a little bit longer. There is one more method I wanted to mention to you just for fun if you wanted a little bit of a research project, and that is copy within. So when you call that, you would want to call that on grades, so it'd be grades.copyWithin. This method can be used to copy a portion of an array to another portion of the same array. So if that's something you might be interested in, go do some extra research, maybe get some practice with that. That's all I got for you guys in this video. Be sure to check out the next one because we're going to be talking about concatenation, checking if elements exist in an array without having to manually do that with a for loop. We're going to get the index of elements, and we're going to be talking about all kinds of other cool stuff. So that one's definitely going to be helpful when you really want to check that out. So I'll see you in the next one. Oh, and don't forget to subscribe. Hello everyone, welcome back. This is your third video in array methods. So make sure you check out part 1 and part 2, which were the previous 2 videos. Now, I'm pretty sure this is going to be the last video on array methods, so if you're about sick and tired of them, trust me too, I'm ready to move on to something new. So let's go over some of the last essential array methods, and then we'll be basically array pros. And you know what? The #1 way to be a pro in software development is to check out our sponsor, DevMountain. DevMountain offers classes in JavaScript-based web development as well as iOS and other topics that you might be interested in. DevMountain offers classes in JavaScript-based web development, so we're talking JavaScript, React, Node.js, how to put all these pieces together to build real-world applications and get a job in the industry. They are very career-centric, so their goal is to help you succeed in the industry. When you go through this bootcamp, you're going to get years of information condensed in a matter of weeks, so it's very intense, but it's definitely worth it if you want to kickstart your career. So check them out, guys, link in the description. In this video, we're going to be working with an array called grades, which we're going to have numbers in here, and you can use other data types, so you can put strings in here or functions or whatever you want it to be. We're just using numbers for consistency and for simplicity. So we're going to assign this to grades, so now grades contains these three elements. The first method we're going to be talking about is concat. So what we're going to be doing is we're going to be creating another array. Let's just call it grades B and fill this with some information. You can put whatever you want in here. And the way this works is we're going to say grades.concat and then pass in grades B. And what this is going to do is it's going to return a new array with all of the information put together. So we press enter and there's that array. So if you wanted to use that, you would need to assign it to another variable. So if we wanted to do that, we could just say let tacos equals grades.concat, and then tacos is going to contain that array. Very useful, good variable names. All right, what else? Well, the thing here is that this is very similar to the push method. So for example, I could take tacos and I could say tacos.push, and I could pass some elements in here separated by commas, like so. And what that's going to do is it's going to change the tacos array. And you get that fuller, the extended array where we put all these extra elements in here. So what is the difference between push and concat? Well, the thing is that push will change the original array and return the length. Concat does not change the original array, and all it does is it returns the new array. So that means if we scroll up here and look at grades, it's going to remain the same as well as grades B. So if we go down here and type out grades, you can see it still contains three elements. So if you want to change the original array by adding elements into it, then you'll want to use the push method. If you want to create a new array by combining multiple arrays, then you will want to use the concat method. Now you may think to use the plus operator as you might do in strings. So for example, you might say grades plus grades B, but this is not going to be what you expect. You see that this is actually a string. So if you want to create a string from arrays, this might work. But the actual return here is not an array, it's a string with all of the elements separated by commas. So not quite the same thing. So you might want to only use that plus operator with strings and with numbers. Unless you're trying to, of course, get a string. Then you might want to use it for arrays. The next method I wanted to talk about is the includes method. And what this will do is it will return whether or not an array contains a particular value. So we are going to type out grades just to see what's inside of it. We got 20, 22, and 39. So what we might do is we might say grades.includes and then pass in 22. And it's going to give us true. So it's a simple yes or no answer if it contains an element. So if we put something that doesn't exist in here, we're going to get false. A more useful method is the index of method, because this is actually going to give us the index of that element. So if we say 22 and instead of using includes, we say index of, well, this is going to give us 1, which indeed is the index because we have 0, 1. So not only does this tell us that it exists in the array, but it also tells us where it exists in the array. So it's a little bit more useful. And if you put something that doesn't exist in the array, you're going to get -1. So you can check to see if it exists by seeing if the value is -1 or not. And on top of that, you can tell where it exists by referencing the return number there. So -1, it doesn't exist. Anything else, it's the index of that element. So in this case, 220, we get -1. 22, we get 1, because that's the index. The next method I want to talk to you guys about is the join method, and this can take an array and produce a string. So let's go through an example of this. We're going to say grades.join and just press enter. And you can see we get a string here, 20, 22, and 39. Grades itself stays the same, so this does not change the original value. It basically just converts it to a string with a delimiter. So what is a delimiter? Well, it's just a way to separate different elements. We can specify a different delimiter by passing in an argument. So we could say join and pass in a string with a space in it like so, and we get 20, 22, 39. So you can see it's very versatile, meaning we can change this up however we want. We could put no space, we could put a comma, and so forth. This might come up if you're working with a comma separated value file, for example, because they're going to look a lot like this. So definitely make sure you understand the join method. I also like to add that I did put the comma in there, but that actually is the default behavior. So if you just don't put anything, it's going to use that comma there. The last method I want to talk to you guys about is slice. And what this is going to do is it's going to extract a section of an array and return a new array. So let's go through an example. We have the grades array, but it's a little short, so let's just make it a little bit longer. We're just going to add some more data in here. Got some pretty high grades up in here. Dang, that smart kid, I tell you what. All right, so that's the grades array. And what we can do is say grades.slice. And then if we don't put anything in here, it's just a normal array. That's not useful. But what we can do is put the start index. So let's say we want to start at index 3, and then we want to go up to index 5. That's going to give us two values, index 3 and index 4. You got to know that the first is inclusive, but the stopping index is not inclusive, so it's exclusive. So what that means is it's going to start at index 3, so we have 0, 1, 2, 3, right here, and then it's going to go up to 5, but not include it, so it's just going to get these two right here. So that is how the slice method works. Now if you leave off that second index, it's just going to go to the end of the array, so from wherever you start up until the end. That might be useful for you guys as well too. Awesome, so we've talked a lot about arrays, but we haven't really gone through much on iterating through arrays. Yes, we did talk about for loops and some different things we could do, but there's actually different ways to iterate through arrays. For example, there is the for each method. It's a very important method. Yeah, it's another method, I lied, but the purpose of it is much different than what we've been talking about so far. This is part of a category known as iteration methods, which are basically methods that do something to each element. So very, very important and essential to know if you want to succeed with arrays. So check out the next video because that's going to be tremendously helpful. Thank you guys, I'll see you then. Hey, what's going on everyone? This video, we're going to be talking about iterating through an array using the for each method. Very, very useful. Highly recommend that you understand this material. But first, please do me a favor and check out our sponsor, Dev Mountain. I'll leave a link for you guys in the description. You might want to check them out if you're interested in jump-starting your career. Basically, they are a boot camp that offer classes in JavaScript-based web development. So if you want to learn JavaScript, React, and Node.js, as well as some other things, and learn how to integrate them all together to build real-world applications, then Dev Mountain is for you. They offer classes online and in person, so there's really no excuse as to why you can't go. Let them know I sent you their way. They'll give you $250 off. Once again, the link is in the description. Now let's get started. Now, what exactly is a for each method? Well, you may also hear for each loop, and part of the confusion there is that some other languages have a dedicated loop for a for each. And what is a for each exactly? Well, let's first go over the for loop and then see how the for each is different. So if we have an array of grades, we can iterate through these using a for loop. Let me zoom in just a little bit for you guys. So we can say for, and the way to iterate through an array is just go to grades.length. So I is less than grades.length, I++. That'll get every single element. And we can write these elements out using grades of I. So this is the standard way to iterate through an array. Do a refresh and we get all those elements. I'm going to change that one just so it doesn't put them together like that. Bothers me. All right, anyways, the downside here is that it is going to do undefined. So if we say grades.length and set that equal to 30, for example, we're going to get a bunch of undefineds here. So the only way to get around that is to go inside of here and say if grades of I is not equal to undefined, then we'll console log, like so. So now it should work. It gets rid of those undefined. But there's actually another technique that you're probably going to run into quite a bit. And oh, does that just drive you crazy, like having one semicolon on the next line? Because of word wrap. I guess you could turn word wrap off, but whatever. Anyways, there's another way you might see this, and it's really common, and it looks like this. So you're going to have grades.forEach.
And inside of here, we're going to pass in a function as an argument. So when you do this, it's known as a callback function. So it looks like this: function, you put the parentheses, and then you put the curly braces. So we're just defining a function on the fly here. And my dog is here to say hello.
Hi, dog.
So specifically for a callback function, when we pass a function as an argument, it gets called on the inside, meaning the for each function is going to call this function we put here. That means we can go in here and we can make it do things. So we can say console.log and say hello. Now, when you have it all like this, it can be a little bit hard to read, so I'm going to space that out a little bit in a second. So you can see that for every single element, 6 of them to be exact, it console logs hello. So let's space this out just a little bit differently just so we can see it a little bit better. Like so. Awesome. Now in this loop, we can gain access to the elements of this array. So we can just call it whatever. We could call it element. And we can use this element variable inside of the function to do things with the elements. So if we just console log the elements in here, like so, watch what happens. We do a refresh and we get a lot more data here. So I'm going to comment out this earlier for loop we did, and we're just going to see the for each method. So that is the exact way to do this here with this for each. You'll notice a difference though is that we don't have to check for undefined. So the for each is only going to work with elements that are not undefined, which is a huge plus for us because that's one less check we have to do. Another thing you're going to notice here is that we're working with the element directly and we're not using an index. So we don't have to say grades of I. We can name it whatever we want, and each individual element is passed in this function into the element parameter. So we can access that element using that element variable. There's a lot of elements going on here, but you can name this whatever you want. So you could call this E if you wanted. You could call it item, whatever's easiest for you guys to understand that this is referring to each individual item. So each iteration, item is going to be a new element, specifically whatever item we're on currently. So the first iteration it's 12, then 13, then 32, and so forth. So it's a lot cleaner on syntax. It does take a little bit more time to understand the callback function and how that works, but it definitely works. Now, the biggest thing to know is that you're working with the item directly and you're not using indexes. If for some reason you need to use an index, you can do that. You just need to you need to add another parameter here, and we could just call it I. That's going to get the index passed to it. Let's say we print I there, do a refresh, we get the index as well. So that's awesome. There is a third possible parameter, and that is the actual array, which is kind of pointless, but you might use that. So you could pass in the array there, and you're going to get the entire array each time. So if you need to access individual items, it's the first argument. If you need to access the index, it's the second argument. If you need to access the entire array here, then it's the third argument. But you can just use grades, so I'm not entirely sure the use of that here. I'm still trying to learn that one myself. So if you got a reason why you would want to pass in the array here, then let me know. So that is the for each method, a lot cleaner than the for loop up here, at least in my opinion, specifically because you don't have to do any of this setup crap. It just does it for you, which definitely reduces errors and helps prevent you from going one over the length of the array or one too short or whatever it might be. So I would recommend you start using the for each method. Definitely helpful for all kinds of situations. Thanks guys. In the next video, we're going to be talking about doing this, iterating through arrays, but for multi-dimensional arrays. So it's going to be a lot of fun. Be sure to check it out, and please be sure to subscribe if you've enjoyed this content. Thanks guys. Welcome back to Caleb Curry's tutorials on the intertubes. I am your host, Caleb Curry, and in this video, we're going to be talking about doing this junk, but for multi-dimensional arrays. So how exactly do we iterate through a multi-dimensional array? This is super useful if we need to access each data point inside of a multi-dimensional array. So first thing, we got to make a multi-dimensional array. So we're going to start with a square array. So we're just going to go down here, change grades a little bit. So that's the first row, essentially. And we're just going to put some other stuff in here. We're going to start using for loops, and then we're going to talk about the for each method for multi-dimensional arrays, which is equally as useful. So we're going to go through both options. All right, so there is our multi-dimensional array, and we're just going to get rid of this.
we're going to assume the best, that no one messes up our array and makes gaps. So let's go over a for loop for a multi-dimensional array. And I'm just going to get rid of this. We're going to do it from scratch. And we're going to just get rid of that too. Let's just get rid of everything. There we go. Nice and clean. So the first thing, we need to make a for loop for the outer elements, so the rows. So we usually use I for that. So we'll just go I through grades.length, I++. This is going to iterate through the rows. So if you just console log and do grades of I, each one is going to be a row. So we'll get this array and then the next array and so forth. Do refresh and you can see indeed that's what happened. So each one of those seems to be right. Awesome. So if we want to go through each element, we need to do another for loop inside of this. So that's going to look like this. Let me get rid of this console log here. For, and then by convention, we use K or J or something like that. I'm going to go with K. I like K. In fact, some people call me K. So yeah, K is less than, okay, here's a question. What do we put here? Less than what? There's two approaches. One is best and one is fallible. And I'm going to tell you which one is best, but I'll show you both of the options. The first one is to do grades of I dot length. That works. And basically what that's going to do is it's going to get the length of each row depending on what row we're on. That is the best way to do it. Oftentimes though, you'll see grades of 0 dot length, which will just grab the length of the first one here and just assume that we're in a square. The benefit of using I is that it's going to work for jagged arrays as well. So we're going to go with I and go to that length. And then we're going to do K++. Now, inside of this loop, we're going to do the console log. So what are we going to console log? We're going to console log grades, and then we're going to use two squares. The first one is the row, so we'll just grab the I for the row, and then K for the column, so which element of that row. Now when we do a refresh, it should be 12, 13, 32, 43, 42, 23, and then that's the end of the first row and it goes down to the next one. So it seems to be working. If you wanted to see a little bit more visually, you could console log a space or something here just to make it separated. So now it's going to separate each row with a little squiggly, so you can see it a little bit better. Okay, so that works. And the cool thing here is that this should work for jagged arrays, meaning if certain ones are longer than the other, it's not going to cause any problems. Like so. So you can see it seems to still console log everything appropriately. If you use grades of 0 here, it's going to just grab that first length and it's not going to work the way we expect. So you can see the second one's too short. This one's undefined. Yeah, definitely not what we want to do. So we want to use I there. So this is one of the hardest things for me to adapt, and I think I went over using nested for loops earlier on in this series, but it definitely doesn't hurt to go over it again because this was really confusing for me when I was a beginning programmer because the nested K's and the I's and the letters, and yeah, it was just gross. So I'm going to teach you guys a better solution, which is to use the for each method. So how exactly does that work? Well, we say grades dot for each, like so. And then in here, we pass our own function. So we say function. And then inside of the curly braces, we can define our function. You can set it up to look like this. Sometimes I'll put it like this just to save some space, and I'll put these on the same line as well. So it'll end up looking like this. Now in here, we can console log each row, which will be basically an array of its own. So we need to get the element, like so. You could call it element. I'm going to call it row actually. And we can console log that row. And let's comment out this for loop just because. And I'll do a refresh and you can see we get each one of those rows. So it seems to be working. But what if we wanted to do this with a multidimensional array where we want to do each element rather than each row? Well, we actually have to do another for each. So the way we do this is we access that row, which is an array itself, and say for each, and inside of here we pass another function, so it's going to look like this. And then inside of here we're accessing that element, so we could say console log, we need to get, we'll just call it column or call, we need to get that, and we're just going to console log it. Now when we do a refresh, we get all of those elements. After each individual row, I'm going to just do a console log with some squigglies just so it's nice and easy to see. Like that. And you can see we get that original output. So this here is the same thing as this here. And I think this needs to be back there. Yeah. And this needs scooted back one too. Yeah, sorry about that indent error. So you can see it's a lot cleaner because you don't have to worry about I's or K's. You just have to worry about figuring out how to set up the callback functions. It definitely can be confusing at first, but in the long run, this is the cleaner, better solution. So try to get used to this when you're going through arrays. You also see that we don't have to worry about undefined here, and we didn't in this case, but if we wanted to be proper, we would need a condition for the rows and then another condition for the columns. So lots of checking there. We're saving some time by using the for each here. So that is all I have for you guys on multi-dimensional arrays and how to iterate through them. Hopefully that was helpful for you and just got you some more practice working with arrays. In the next video, we're going to be going over break and continue. And you might be thinking, what? Didn't we already talk about that? Well, indeed we did, but now we're going to be talking about labels, which labels allow us to basically do something a little magical. So you'll definitely want to check it out. And it's definitely an important thing when we're dealing with nested for loops. So I'll see you guys in the next video. Hey, what's going on everybody? Welcome back. This video, we're going to cover a topic that I actually haven't seen a whole lot. So either you're going to learn something that's like this secret magical knowledge that not a lot of people use, or you're going to learn something that's really not a whole lot practical. Well, I guess that's up for you guys to decide. So hopefully this video is not a waste of your time. But you know what is never a waste of your time? Yeah. You guessed it, going to a coding bootcamp. Specifically, you want to go to Dev Mountain because Dev Mountain is my sponsor and they are awesome. What do? Well, they help you get up to speed with JavaScript-based web development. So you're going to be going in there, studying JavaScript, React, Node.js, and take all these pieces of application development, put them all together, and build real-world applications. So if you want to fill out your portfolio and get some experience and go to a career-centric bootcamp, I'd recommend Dev Mountain, and you know what? They're giving $250 off if you let them know I sent you their way. So check out the link in the description, and now let's get back to labels for break and continue. So what exactly are labels? Well, it basically allows you to label an outer for loop and use a break or continue to go to the outer for loop instead of the one you're currently in. So what I'm going to do is I'm going to get rid of this stuff down here. And we're going to focus on this for loop we already have. So let's get rid of this comment. And what is this for loop currently doing? Well, let's just save and do a refresh. You can see it's actually just printing each one of these elements in the array. And then after each of the elements, it puts a little squiggly to separate the different subarrays. So what we can do, let's say we're looking for a particular value. Let's go with 54. Why did I choose 54? Well, I just wanted to show an example where it's not existent in the first array, but it is in the second array. So what we might do is we might console log those values, but then we might do a case where if grades of I and K is equal to the value 54, I'm going to use a triple equals there, then we might do another console log and say like, you found the value. So you might get that value, you might search for a value from input or whatever, totally up to you. I'm just hard coding that value there and do a refresh and it says you found the value. So it seems to be working, and what you can do is you can use the keywords break and continue inside of loops. And as a refresher, what exactly do these do? Well, the break is going to break out of a loop altogether. So if we're inside of this if condition and we say break, it's just going to break out of this for loop and go to the next iteration of this for loop. So that means it's going to skip the rest of this array. So it's going to skip these ones right here. So when we do a refresh, you can see you found the value is the last thing it says here, and then it just jumps to this next iteration of the outer for loop right here. Now, if this stuff is a little bit much with all the for loops and stuff, I've released a bunch of videos over for loops in JavaScript and working with arrays, so make sure you check out those videos because that's going to help you get the JavaScript syntax down to work with arrays with these for loops. So hopefully I'm not just skimming over this too quickly for you guys,
but I don't want to linger too long on this syntax here. But basically, the break keyword is going to skip out of this for loop here and go to the next iteration of this for loop here. Sorry, actually, all the way down here. So it'll just increase I and start again from line 9. Now the other keyword you should know is continue. And we've talked about this one too, if I can spell it out. This will actually go to the next iteration of the inner for loop. And currently it's the absolute last thing inside of this for loop, so it's not actually going to make a difference. But if we had another console log in here, I don't know, just doing stuff, well, what's going to happen is it's going to skip this console log here in the case that this is 54, because it's going to hit that continue. It's not going to do the console log because it's going to go to the next iteration of this for loop. So when we do a refresh, we see this doing stuff for every single element except the one with 54. It says you found the value. A similar thing could be set up with an if-else, because you can basically see it as, hey, if it's 54, print this, else print doing stuff. But that's just another way to get the task done. Now to step up our game to labels. So what is a label? Well, basically, we could take a look at our outer for loop and give it a name. So what if we called it outer loop, like so? And I'm actually going to use a capital L there. So we just gave a label to this for loop, and we can reference this label inside of our continues and our breaks to jump to that outer loop rather than the inner loop. So now if we say continue outer loop, well, this is actually going to reference the outer loop. So it's going to continue with the next iteration of the outer loop rather than the next iteration of the inner loop. So what is that going to do? Well, actually, using the continue with the outer loop as a label is going to be very similar to using a break, because it's going to stop doing this for loop. So once again, continue outer loop is very similar to just using break inside of the inner for loop. So what is the difference then? Well, continue outer loop is going to jump to the next iteration of this outer loop, but anything that's outside of this for loop is not going to get executed. So this line down here is going to be the deciding factor on whether we want to use continue outer loop or if we want to use a break. So this code is ignored with continue outer loop. This code is not ignored with a break. So let's just go through an example of this. Let's do a refresh. So what happens is it finds that value 54, it prints you found the value, and then it jumps to the next array, 43. If instead we used a break, first paying attention to what goes on here, it does not print that squiggly line. Now if we save and do a refresh here, it says you found the value, and then it does print that squiggly line. So that's a primary difference. When you use break, it breaks out of this outer for loop and continues execution at line 17. When we use continue with the outer loop, it just goes to the next iteration of the outer loop immediately, skipping anything that comes after this. Now the other option is to use a label, but instead of using continue, it's to use break. And what this is going to do is it's actually going to break out of the outer loop and just jump down here to line 20. So this is where it will break. I was gonna spell that out, but I can't write and talk at the same time, so I'm not gonna worry about it. So if we do break outer loop, it's going to finish this outer loop and continue down from 20. So when we do a refresh, what's going to happen is it's going to find that value 54 and then end the search altogether. So overall, this stuff can be a little bit confusing because there's so many different options. There is break and continue, and you can put that inside of the inner for loop, or you can put it inside of the outer for loop, and then you can use labels to reference a loop farther up the nest. So you got to do a lot of practice with this if you really want to get it down. Honestly, even going through this video, I had to think about it just to make sure I was saying the right thing and that it was going to jump the correct way. So using these things can be a little bit confusing sometimes, but just make sure you understand them. And what we're going to be doing now is we're going to be moving on to a new topic. So I would encourage you guys to make sure you have all of this information down before you move on to the next topic, so that way it doesn't come back and bite you.
So thank you guys for watching. In the next video, we're going to be talking about something new. I'm looking forward to it, so please be sure to subscribe as that really helps out the channel. Thanks guys, and yeah.
Hello, my nerds. Welcome back to the Valentine's Day special. Today is Valentine's Day, so congratulations all of you who are happily bonded with another. And if you're one of the unluckies to not quite have that perfect person or perfect entity, I know the perfect date for you guys. That's right, JavaScript date objects. That's what we're talking about in this video. So yeah, if you're looking for a hot date, I got one for you. So awkward. So we've talked about all kinds of different data types here. We've talked about the primitive data types, we talked about arrays, and we even talked about some on objects. Well, now we're going to be creating an object, one that the constructor has already been defined for us. So it's called a date object. So you can do something like this. var, and then you can name it whatever you want. And I'm just, going to go off that play on words, right? Valentine equals new date. So what is going on here? What is this? Why are we doing this? Well, this is known as a constructor, if we haven't talked about this yet, or if you're just not remembering. A constructor is a special function that's going to return an instance of something. So this is going to create an instance of a date, which is a special object that can be used to store day, year, hour, and minutes, and all that good stuff. This video is going to be the concept behind a date. In the next video, we're going to go into how to create them and how to use them. So this constructor exists, we can use it, and we have to use the new keyword. And that is important. You always do that when you're going to create a new object from a constructor. So whenever we call this constructor and don't pass anything in here, it's going to default to right now. And by right now, I mean whatever time you're watching this, not the time that I'm saying this, because that wouldn't be right now, that'd be in the past. So if you want to see that, you can log this date to the console, and then you just throw the variable name there, and when you do a refresh on the page, every time you refresh, that date is going to update, because every time you refresh, it gets a new date, and that time is going to continually be the present. So if you want to see that change, go into the console and do that. It's pretty cool. So this will give you something along the lines of Thursday, the 14th, 2019. And then it'll give you the hour, the minutes, and the seconds. Then it's going to give you the time zone. And this is where it's going to change from person to person. So you might get something like GMT minus 0600, for example, which would be Central Time. So it would say something like Central Time. So as for this actual number, you might be wondering, like, what is that? What is GMT minus 0600? Well, there is a standard time zone known as GMT. That's kind of like what the rest are based off of. So you can think of Central Standard Time as GMT minus 6 hours. So you might see GMT minus 5 or GMT minus 4 or plus 3, whatever. It's basically a way to standardize the time. You generally don't have to worry a whole lot about this part here though, because it's going to update automatically based on the time zone of your computer. Now, if you want to be specific on a date and not just get the date of right now, you can pass information into this constructor to define what date you want. So the bare minimum is the year and the month. So for example, we could say 1990 month 11, but there's a gotcha you need to know about. This is the month, but it's zero based, meaning this is actually December. So the months go from 0 to 11. The zero-based thing is not the case for the year, so 1990 is actually 1990. Same for the day. If you go in here and add another argument, you could say December 31st, for example. Like so. That is also not zero-based, so 31 is day 31. Now when you're working with dates, you should also understand that there are times when we're going to be working with milliseconds. So just a huge number of milliseconds from a particular date. And this date is known as the Unix epoch. So where exactly am I going with this? Well, if you do something like new date and then pass in a number of milliseconds, you can basically say an exact point in time. So for example, you can represent right now in a number of milliseconds from this Unix epoch, which is January 1st, 1970. So you could basically start counting milliseconds from this exact moment in time and represent any moment in time. So just give it a try. You can get the exact milliseconds for right now by doing date.now. You can use dates for a lot of different stuff. For example, you might want to time how long it takes to do something, or you might want to keep track of when something happened. You're going to be using dates a lot, and it's good to get a lot of practice with them. So what we're going to be doing in the next video is we're going to be taking some of these principles we just talked about, go through some examples in code, have a little bit of fun, and have a little bit of a Valentine's Day celebration by being on our computer coding. Yeah, fun. So be sure to check out the next video. And once again, guys, I hope you have a great evening. Maybe if you have a special someone in your life, make sure you let them know that they're important to you and that you care about them.
Yeah.
Hey, I just wanted to let you know that I love you.
I love you too.
Thank you.
Really excited.
Yeah, just reminding my viewers to tell their special ones that they love, that you love them. So I was giving them an example.
Okay. Thanks.
Yeah, of course. Have a good day.
Bye.
See you guys.
Hey, what's going on everybody? Welcome back to your JavaScript tutorial series. This video, we're going to go hands-on with dates. Now, I would encourage you to check out the previous video because that was like the foundational video for dates. It was actually quite a bit of fun, so I'd encourage you to check it out. So in the previous video, I created a date. I used var, but in this case, I'm going to use let because we're in a block scope here. So we can give it a name and then just say new date. Again, this is the date constructor. So this is going to give us a new date object. We do a refresh. Oh, I got to print it out here. So we can do console.log, print my date, do a refresh, and you can see this is what the date looks like. So it has the day of the week, month, day, year, hour, minutes, and then seconds. So every time you refresh, that seconds is going to go up. So it's constantly changing. When you just call the default constructor here with no arguments passed in, it's just going to give us the current date. So if you don't want that default behavior, then you need to pass in some arguments. So you can pass in the year and the month. Those are the only two that are required. The rest are optional, but you can pass in more information if you'd like. Now there is one gotcha, as I mentioned in the previous video, that the month is actually 0 based. So 11 is December. So if I save this and do a refresh, you're going to find that it says December 1st. So not November, the 11 is December. So if you want January, you need to use a 0. If you want February, you want to use a 1, and so forth. Now there is one extra thing that I didn't mention in the previous video that you definitely need to know about. The date constructor is very interesting in that if you give an invalid value, it kind of converts it to a valid value. So if I put a 12 in here, for example, it's actually going to be January of 2021. So basically we start with 2020, then we add 13 months, which would make it January of 2021. So hopefully that makes sense. It basically just rounds around in a circle, and we'll keep doing that. So this is January, this is February, and so forth. So I could put in some huge number in here, and it's just going to add that many months and convert that to what year it would be. So we can do a refresh, and you can see this would in fact be March of 3141. So if you guys are watching it this year, that year, then this is pretty interesting. So let me know how the future is. So yeah, that's how date objects work. You can also pass in a number of milliseconds. So if you just pass in one argument, it's interpreted as the number of milliseconds. So put it in like that. Now it might be hard for you guys to translate milliseconds to an actual date. So let's just go through some samples. If we put 0 in here, we actually get 1969. Now you actually have 1970
January 1st, but because we're in Central Time Zone, which is GMT -6, we're actually getting 18 hours on 1969. But basically, the date object, it starts at 1970, January 1st, which is known as the Unix epoch. So any milliseconds we add to this is going to go from that date forward. So if I put 1,000 in here, that should be 1 second, so this should be 01 here. And indeed it is. So that's how that works. Now, if you want to pass in the number of milliseconds for right now, you can do that by doing date.now. That's going to return the number of milliseconds from 1970 to right now, and that's going to give us the same exact value as just doing the default new date. So if we wanted to do that, we could console log my date as so, and then we could also just console log a new date like so. And you can see we get exactly the same values. So either one will work, and you'll probably see a little bit of both. Now, usually when you're doing date.now, you're not going to be passing that into a new date. You're actually going to be using it to keep track of a number of milliseconds. So for example, we could create a new variable. Let's bring this one back to the default, so we just have a normal date there. And then we could say, let, I don't know, time equal date.now. And this is going to give us just a huge number of milliseconds, and we can print that in the console log like so. And you see that's the number of milliseconds from the Unix epoch. So this is known as a Unix timestamp, and this particular version does use milliseconds. Some will only use seconds, but in JavaScript it does take milliseconds. So these first 3 digits here are going to update very quickly because these are the number of milliseconds. All right, cool. So what else? You can use milliseconds to basically keep track of how long something took. So a common thing you will see is you'll get the date.now before something happened, and then after something happens, and then you'll basically subtract the end from the beginning to see how long it took. So if we wanted to do something like that, we could say let start equal date.now, and then we can say let end equal date.now. Now these are going to be basically the same thing at this point, but if we do something that takes a bit of time in between here, we could see how this might work. So let's create a for loop. We could say, we'll let I equal 0, I being less than some really big number, I++. And let's just do a huge sum here. So let's create a variable x. We'll set that equal to 0, and then we'll say x equals x plus I. So let's see what happens here. And at the end, we're going to console log x. Save that and then refresh. So we get this really big number here. And that's the sum. Now, if we want to get how long it took, what we would do is do end minus start and assign that to a total. So we could say let total equal end minus start, and then we can console log the total. Like so. Do a refresh, and you can see it took 6. And you can see as I add zeros here, this number is going to become much bigger. In this case, I think I made it a little bit too big. Whoops. We'll bring that down to 0 or 2. Open that in a new tab there. And you can see it took 227. Let me add one more 0. Do a refresh. And now it took about 1295 milliseconds. So if I add another 0, it should take about 10 times that. So let me see. Awesome, and the number seems about right. Now I'm pretty sure this is the same number I had to start with, so if I was just a little bit more patient, it probably would have showed up, but you know, I had to spend 20 seconds to save me 10 seconds. Now we don't really need x in this case, I was just printing that for fun and just to see how the number got larger as we increased I. The next thing I wanted to talk about is that you can actually add and subtract dates. So let's get rid of all of this and go through another cool example. Let's create an application that will tell us the number of days between two dates. So we can make a before date, and we can just pass some number in here. We'll just go with that there. And then we could say after and say new date. And let's just make it maybe 5 days in the future. So the answer should be 5. Now what we can do is we can actually say after minus before. And let's console log this and see, let's first assign it to a variable. So let's say
let days equal after minus before. And we're not quite done. This isn't going to give us what we want, but this is a good start. So we'll just console log days and see what we get. So we get this huge number, which isn't quite what we're looking for. This is actually the number of milliseconds between the two dates, and that's not what we want. So we actually have to take this and convert it from milliseconds to days. And how do we do that? Well, we actually divide by however many milliseconds there are in a day. You could look that up, or you could calculate it yourself. We could say 1 day is equal to 1,000 milliseconds. For every second, there's 60 seconds in a minute, and there's 60 minutes in an hour, and there's 24 hours in a day. Then all you have to do is take this whole thing and divide it by 1 day, and that should give you the answer. Like so. Now the answer should actually be correct. And we get 5. Awesome. So that's just a little bit more practice with dates. You can do a lot of cool things with these, and you're probably going to run into them a lot with JavaScript. So make sure you pay attention now that the video is over. And hopefully this was helpful, and I'll be sure to go over some more stuff in the next video, where I think we're going to be going over some pretty useful date functions. So I'll see you then. Guess you could say it's a date. Hey, what's going on, everybody? This video, we are going to continue our discussion with dates. Now, what are we going to be talking about specifically? We're going to be talking about the most common methods with dates. So one thing I wanted to mention, you can use a particular method called date.parse. The recommendation for this is avoid it if you can, because it's not guaranteed to work on all web browsers. But you are still going to see this quite often. So with this, you can pass in a string and it's going to interpret it as a date. So for example, we could put 12th of January 1995, and then you can put some time in there if you want. So we could have it like that, and then you can put the time zone. We can just go with Green Sandwich Mountain Time or whatever it is. Assign that to a variable, and then we can console log that. Do a refresh, and we get a value in milliseconds. And it seems to be working. If you put an invalid date, so for example, if I put Jan like that, it's going to, oh frick, it worked. Why'd it work? That's weird. Anyways, I guess maybe Jan with a ton of N's is close enough to January. I'm not entirely sure. But anyways, if you put an invalid date in there, you're gonna get not a number, which we talked about that when we talked about numeric data types. So you should understand what that is at this point. Now, a common variation of this thing is to pass it into the date constructor directly. So you could say new date and do a refresh. And in this case, it says invalid date. Let's fix that Jan here. There we go. Do a refresh. And we get the date version. So depending on whether you want milliseconds or a date object, you can decide which one you want to do. You will often see formats other than this as well. So for example, a common format is the year. So 1970 followed by the month. We could do 11 and then the date, such as 14. And that will give you the exact same thing. Well, not the exact same date in this case, but it works exactly the same way. And you can do that as well. If you want to know more about the intricate details of using strings to create dates, you can research that, figure out the ups and downs, and what formats are recommended for the most compatibility with browsers. There are also JavaScript libraries that can be used for dates that might work a little bit more effectively. If you really are working with dates a lot, you might want to look into one of those. Shouldn't take more than a couple seconds searching the internet to find some of the popular ones, so I'm not going to do that here, but just want to let you guys know that do what you need to do to work with dates correctly. So you want to try to avoid anything that's not going to be standardized or might be hard to interpret. All right, now let's move on to the next method. We have been creating dates by saying new date and then passing in information here. Well, this is going to be interpreted as our local time. So if I go in here and say, hey, I want this to be 2012, we'll go with the 11th month, the 15th day, and then let's say the 10th hour, 10th minute, and the 10th second. We'll just go with that much information. When we write this out, we get that same information. So basically what's happening is it's taking this date, it's converting it to UTC, also known as GMT, so Universal Coordinated Time and Greenwich Mean Time. Basically the same thing, two different names for the same thing. So that's like the standard time zone that everything is based off of. And then everything else is just represented as that plus or minus a certain number of hours. So when we create a date, it's stored in UTC, And then when we print it out, it's converted back to our local version. But sometimes you're going to be given dates in UTC, and you don't want to put them in using your time zone because then it's going to change the UTC representation. So let's say this date we were given is already in UTC and we don't want it to be converted again when it's stored. We can do that by putting a method call in here, date.utc in all caps, and then passing all that information to that method. Now when we do a refresh, because it's assuming this is already UTC, we're going to get 6-hour difference. And when we do a refresh, we see indeed it is. We have a 4 here instead of a 10. So the takeaway here is if the dates are already in UTC, you want to do it with this technique here. If they're not already in UTC and they're given in local time, that's fine. Just use local time here, and when it's printed out, it should be correct. Now I'm going to get rid of that and just do a normal date creation. So I'm going to say 2012, give it some month and some day. And now what we're going to do is we're going to work with this date a little bit. Specifically, you can get a little bit specific with what kind of information you want about this date. So for example, you could say my date dot get full year. And what this is going to do is it's going to return the year. So now we should just get 2012. There's a lot of different options for this. Another one is get month, like so. Do a refresh and we get 10. And you could do the date as well, get date, and we get 12, which all those seem right. Here is the JavaScript documentation with a lot more information with all of the different possibilities of these methods. Obviously, I'm not going to go through every single one because that would take all day, but if you want to do any specific thing, you can go in here and find the appropriate method to do that. All kinds of stuff such as getting the milliseconds, minutes, the seconds, and all kinds of other variations. So lots of information here. Just go through that and look and see what might be useful. Now the next variation of methods are setters, and these are used to set the date. So for example, I can go in here and say my date dot set, and I can change any of this information. So for example, I could change the hours and say that we're 12 hours in. Now when we get the date, console log it, what happens is we get 12 hours in. So you can use those methods to change individual pieces of a date. There's one more method I wanted to talk to you guys about, which is get time zone offset. So what we can do is we could say get time zone offset and then just call this and see what it gives us. So let's put this inside of a console log. When we do a refresh, we get the value 360. What the heck is that? Well, this is actually the number of minutes our time zone is offset from UTC or GMT. So we can actually divide this by 60 if we want to know the number of hours, and it should give us 6. And note that it's positive. Even though our time zone is currently minus 6 hours from UTC, this is still going to be positive, so it's flipped. What do I mean by that exactly? Well, if we do a console log my date, you'll see that on here it says GMT minus 6. Well, this value is going to be positive, and if the case where this is positive, this value is going to be negative. So you gotta remember that it's flipped. I think the reason that this is positive is because it basically takes the time UTC and subtracts the current time, whatever time zone you're in. So if our time zone is 6 hours less, then the difference is going to be 360 positive. Then when we divide that by 60, we get the value 6. So we've been talking about dates for a while now. There's so much more, and I would encourage you to research it if you're going to be working with dates quite often. That's all we're going to be covering for now. So hopefully that was enough information to get you grounded in dates, and then when new stuff comes up, you're not completely lost and you have that foundational layer. Hopefully I gave you what you need, and if you've enjoyed this content, please consider subscribing, as that super helps out my channel. I'm trying to grow this channel to 100 million subscribers. Almost there, guys, so I could really use the help. Thank you, and I'll see you in the next video.
Hey, what's going on, everybody? Welcome back to your JavaScript tutorial series. This video, we're going to talk in depth about functions. And then in the upcoming next section of videos, we're going to go through everything you need to know about functions. So this video is going to be the concept, and the next video is going to be the code. So yeah, if you're looking for the code, you want to check out the next video. But I'd recommend you stick through this one because we're going to go through a lot of material that's going to help you throughout the rest of this series. So functions are a very big deal in JavaScript, and it's important that you understand how they work. The very first thing you need to know is what exactly a function is. A function is basically when you define a section of code that can be called or invoked. So think of it like this. This is your function, and you have some lines of code in here, And rather than using those lines of code over and over and over again, you can just call this function multiple times. So here we have one call, here we have another call, and so forth. So you can kind of think of a function as a process that will sometimes take an input and sometimes give an output. So it's kind of like this. So if we zoom in on that a little bit, we can get input, and it'll do something with that input, and then it will return an output. Now the input, the stuff you pass into the function, is known as arguments. Then you have the function body, that's what it does, the code, and then we have the output, which is known as the return. So that is basically the concept of what a function is. We've used functions so far throughout the series, but now I want to get in a little bit more depth. So what we're going to talk about now is first we're going to create an example function, talk about the different pieces, and clarify some terminology when it comes to arguments and parameters and all of that stuff. Now there are a ton of different ways to create functions inside of JavaScript, so I'm going to basically teach you the default, which is a function declaration, and in the upcoming videos we're going to talk about the variations. So what it's going to look like is you're going to have the function keyword, then you're going to give it a name, the identifier. In this case we could say it's called square, and what this will do is it will square a number or multiply it by itself. Then we put parentheses, and we put any variables we're going to need in this function inside of these parentheses. So for example, we could just say x. Then we have what's known as the function body, which is indicated by curly braces. So we have an open curly brace, and then we have a closed curly brace. And then inside of the curly braces is where we put the code that belongs to this function. So this is the function body. So what we can do is we could say return x multiplied by x. So what that'll do is it'll take a number such as 5, that's going to get passed into the square function, which will look like this. And the return, what you get back is 25, 5 times 5. And you can do something with that value, so you can assign it to a variable, or you can output it to the console, or whatever. You can pass it as an argument, whatever you need to do. So here we are calling square, and we're passing in x. The thing you need to understand here is that this x here is different than this x here. They are two separate variables. So you could use whatever variable name you want here, it just has to exist. So for example, we could say, let x be the value 5. And then we could pass x into this function call. Now, when you are passing something into this, it's known as an argument. But the actual variable inside of the function is known as a parameter. So argument is when we're calling the function, parameter is inside the function declaration. So you can kind of think of it like this. We have parameters which can contain values, so we have basically a variable, and the arguments get passed in to those parameters, whatever value is in that variable. So the value of x gets passed into this variable x. Now one thing about JavaScript is it's very flexible when it comes to functions. So when it comes to arguments, you can pass less arguments, you can pass more arguments, and so forth. So for example, we could call square and just leave the parentheses empty. Or we could call square and pass in multiple numbers. Or we can even pass in a string. So how does this work? How is it possible that we can pass in multiple things, even though it's only accepting one up here? This is in contrast to many more strict languages, so if you're coming from C++ or C# or Java or something, this is not something you can do. So it might be a little bit weird if you're new to JavaScript, but have some other coding experience. But basically what's going to happen is if you don't assign a value for a particular parameter, it's going to be undefined. If you pass multiple arguments and there's not enough room to store them all, then these ones will just be ignored. There actually is a way to access those extra arguments through an implicit arguments parameter, but we're going to get into that in a future video. But for the general purpose here, these values are not going to be accessible in any of the parameters we define up here. So this value 5 will get assigned to x. These will not be assigned to anything here. So when it comes to functions, there's a word you should know, and that is function overloading. The concept of function overloading is that we can have multiple versions of a function. Well, this is not exactly possible with JavaScript. That's because when we're doing overloading in other programming languages, the different types of arguments passed in will determine which version of the function to call. So we might have a square that takes no arguments, and we might have one that takes 3 arguments, or whatever it might be. But because JavaScript allows any number of arguments, there's no concept of function overloading. Now we can mimic function overloading, so it is a topic that's still going to come up with JavaScript, but it's done in a different way. So basically you need to implement the functionality for any number of arguments that might be passed into these parameters and whatever type they might be. That's because there's only one square function that exists. So if you need different versions, you need to basically create the logic to make two versions inside of this function based on the values of the parameters. So we might be getting into the weeds here, so don't worry about it too much, but I just wanted to clarify, if you know of the concept of function overloading, it doesn't exist in the same nature that you would expect coming from a different programming language. The next thing you need to understand is that in JavaScript, functions are known as first-class citizens. And this is just a really confusing way to say that functions are objects. So what is the significance of the fact that functions are objects? Well, it means that we can treat functions as if they are any other objects, and objects have special capabilities. For one, you can take an object and assign it to a variable. So functions can be assigned to a variable. We can create an array of objects. So in theory, we could create an array full of a bunch of different functions. We can make objects be assigned to the properties of another object. So with functions, we can assign them to properties to create methods. We can take objects and we can pass them to functions. Well, we can do the same thing with functions. We can pass a function to a function. And this is the basis of what's known as a callback function. So if you have a function, and as an input, it takes a function, and then inside of this function, it'll execute that function. That is a concept known as a callback function. And I'm sure we'll talk about that much more in this series. Another thing is that objects can be returned from functions. So we can actually return functions from functions. So not only can we take functions as input, but we can output functions. And we'll actually go over a popular function known as bind that will return a function. So we're going to get into all of this in this video series. Alright, so that should be a pretty good introduction to function concepts. What I'm going to be doing now is in the next video, we're going to go over a little bit more concepts, get a little bit more into the concept of callback functions, as well as the concept of passing by value versus passing by reference. And you'll know what I mean by the quotes in the upcoming video. So check that out, that should be pretty helpful. And then after that one, we should be getting hands-on with these functions. So check it out and please be sure to subscribe as that really helps out the channel. And I could really use your help. I'm one of the weaker channels out there. So yeah, could use your help. All right, see you in the next one. Hey, what's going on everybody? Welcome back to your second part video on JavaScript functions. In this video, we're going to go in a little bit more depth on how things are passed to functions, as well as a little bit more on callback functions and asynchronous callbacks. All right, so now that we talked a little bit about functions in the previous video, you have a pretty good understanding of how they work and what they are at the fundamental level. Now, when I said we passed an argument to a parameter, I said that the value gets copied to that parameter. And that is how things work in JavaScript. So I think we had something like this, where we had a parameter here, and then we had the function body, and then we called the function or invoked it and passed in some value or some variable. Let's say we're passing in a variable. So we declare a variable x, and then we pass it into the square function like so. Well, what's going to happen is the value of x is going to get copied into this variable here. So it might look something like this. Here we have the x variable containing the value 5, and then we have another x variable, and this 5 gets copied into that variable. So what that means is any changes to this variable inside of this function do not persist outside of the function. So if we change x inside of the square function, and then we use x down here, the value of x is still going to be 5. That's because the value's copied, so if we changed this, well, the original one stays the same. Now things get a little bit funky when we're working with objects or complex types. So what do I mean by complex types? Well, the opposite of the primitive simple types. So if you're working with any data that's of a primitive data type, you can look up all the JavaScript primitives. Those are going to be copied into the parameter values, and we're not going to see any changes on the outside of the function. But when we're working with something such as an object, it works a little bit different. And the reason why is because of this. Let's say we create a variable x, but this time we assign it an object. And here is just an empty object, but you could put stuff in this object. Well, what's actually going to be stored in this variable is a reference to where this object is in memory. So think of it as if it's pointing to some object in your computer's memory. Well, now when we pass this x's value to this x's value, this one here, the thing that is passed is the value of that reference. And that's where things get a little bit confusing. So whatever the value of this is, the location of that object is copied here, and it also points to that same object. So now, if we change that object inside of this function, it's going to be visible outside of the function because they both point to the same area of memory, the same object. And there's a lot of confusion about this because there's not very super clear terms, and different languages have different ways of doing this. So for example, other languages will say pass by value versus pass by reference, or value types versus reference types. So in JavaScript, the way it works is that everything is passed by value. So the value is copied from the argument to the parameter. It just so happens though that sometimes that value is a reference. And that's where the line gets a little gray on it, whether it's passed by value or passed by reference. Technically it's passed by value, but if we're working with a type such as an object, a type that is not a primitive, well then the actual value itself is a reference to wherever that is in memory, and we can change the values of it inside of the function. So we can go in here and modify that object. Now the exception to this is we can't actually create a new object and assign it to this one and have this one affected, because this is what would really be happening. We would be taking this arrow and no longer be pointing it to the old object, we'd be pointing it to a new one, so it'd look like something like this. So now these are pointing to two separate things, and this one stays unchanged. So this is the argument, and this is the parameter. So the only time the changes to a particular variable inside of a function can be visible outside of that function is if we don't reassign it to a new object and we just change that object. So if this was an object, we could change some of the properties. Let's say it was a person, we could change that person's name, or we could change some of the variables inside of that object. But if we actually point it to a new object, that connection is now severed, and these point to two separate entities. So changing this one is not going to also change this one back here. And hopefully throughout the next videos we'll go through some examples and this will become crystal clear. So if you need to basically conclude this and just need to understand how this works, is anytime you're passing an argument to a parameter, if you are reassigning it, the connection becomes broken and the changes will not persist outside of the function. If you are instead modifying, those changes will exist outside of the function. This concept even applies for primitives. So for example, if we have an argument here, let's say it's x, and let's say we're working with integers, and then we have the parameter here, and let's say we pass in that value 5 over here, and we change it over here to 10, well, we're actually not modifying the value, we're reassigning it a different value of 10. So anytime there's a reassignment, the changes are not persisted over in the argument side. Same thing with objects. If we change the object to a new object, those changes will not persist to the argument. So let's just go through an example here. We have this function func, and it takes one argument, so it has one parameter here. And what we're going to do is we're going to say x.name has the value Sally. And then we have an object literal here, so we're creating an object, and it has one property, name Caleb. And then what we'll do is we're going to call this function, and we're going to pass in me. So here's what happens step by step. We create that variable. The variable's name is changed to Sally, so this name here is also going to be changed because they point to the same object. So down here, me.name is going to contain the value Sally, not Caleb. But if instead we did this, and reassigned x to a new object, and we made a property on this name equal to Sally, this is not going to exist down here, so me.name down here is still going to be Caleb. All right, so that was a lot of information. Hopefully that really cleared up how things are passed inside of JavaScript. It can be confusing, so what I recommend is just to create a function, start passing information into it, change things, and see if after the function call they persist or if they do not persist. be a really good way to practice some of this material, and I hope to go over some of that in the upcoming video. Hey, what's going on everybody? Welcome back to your JavaScript tutorial series. This video, we're going to go over the concept of callback functions and how those work in JavaScript and what makes those possible. Check out the previous two videos if you want a little bit more of the foundations of functions, and check out the upcoming videos if you want some hands-on exercises. Now, in order for you to understand what a callback function is inside of JavaScript, you need to understand how JavaScript works with functions. Functions in JavaScript are what are known as first-class citizens or first-class objects. And basically what that means is you can treat a function as if it's any other object. Not entirely sure why it's called first class, because the fact that something's first class makes me feel like it gets special privileges, but in JavaScript that's not really the case. First class actually means it's treated normally. It's a weird choice of words in my opinion, but whatever. Basically what we're saying here is that compared to other languages where functions are just functions, inside of JavaScript they get special privileges because they are treated as if they're any other object, because they are. So what that means is all the stuff you can do with an object, you can also do with a function. If you think about an object, well, an object has properties. You can put properties on a function. You can pass objects as parameters. You can return objects. You can assign them to variables. All of these things you can do with functions. And this allows us to take a functional approach to programming when we're working with JavaScript, which is where functions are kind of the building blocks for building an application rather than going through code procedurally. This allows us to go through code in a functional nature with JavaScript, which is where functions are the building blocks for our application. Now, the concept of a callback function is just when we pass a function as an argument to another function, and that function invokes the function we passed in. So it looks a little something like this. Here we have some function, and we're passing in something to it, but in this case we're passing another function. And then inside of the bigger function here, our function is executed. So the thing we passed in is brought into the function body and it's executed. So what I want to do now is I want to go through the syntax of how to do something like this. We'll just give you a stupid example and then we'll go through something you might actually see in the real world. So sometimes there will already be functions that exist that we will give a function to. Other times we ourselves are going to create a function to take another function. So the concept where we create a function to take a function, the bigger function in that situation is known as a higher order function. So back in our example, the function that took another function, this one here is known as a higher order function. And that's just a term you might want to familiarize yourself with. All right, so let's go through the process of creating a higher order function. All right, it just started pouring outside, so I apologize if the audio is a little rainy, but I'm already halfway through the video, so we're gonna make it through. So we created a function, it's called do something, and what is it going to take as an argument? Well, we can create one parameter, and if you remember, JavaScript is not statically typed, so we don't actually have to worry about the type. All we have to do is use a variable as normally we would. So we can assign a function to this variable, no problem. Then on the inside of this function, all we would do is call x. So x gets passed in, and then we invoke x on the inside of our function. So how would this look in the calling? Well, we can create a variable, and I create a function here. This is an arrow function, just throwing that out there. We're gonna get into arrow functions here soon, but basically you can create a function anyway, but we need to be able to assign it to a variable, and one way to do that is to use an arrow function or a function expression if you wanna look that up. So then what we can do is we call do something, and what we're going to pass into here is my func. And I'm going to capitalize that F. And when you do this, you don't use the parentheses because that will invoke the function. We just want to pass the function itself, and it's going to be invoked on the inside here. So my func gets assigned to x, and then on the inside of this function, we invoke that function. So my func is going to be executed here. Now I think I got all the syntax right, but obviously I can't execute it to make sure, but it's going to look something very similar to this, and I'm sure we'll go into this in the upcoming videos. Now I wanted to call out the return here. So the function we're executing is going to return 5 multiplied by 5, or 25. But we're not really returning anything here. So if you want to be able to get that value back out, basically we need to return this function call. So we would say return and then invoke x. Now this here is not going to return the function, it's going to call the function and return whatever the value is. So since x is given the myfunc function, it's going to return 5 times 5. That's going to be returned from this do something, and ultimately it's going to be returned here, which means we need to do something with that value. So if you wanted to console log it, you could, or you could assign it to something like so. All right, cool. So it's going to look something like that, probably. Now what I want to talk about is a little bit on asynchronous callbacks. So let's create another function that we can assign to a variable. This time I'm going to use a function expression. So this time we're creating a variable. It's called do something. We're going to assign it a function. And let's just say all this function will do is do a console log. And what we're going to do is we're going to pass this to another function called setTimeout. So setTimeout is a higher order function, so it takes a function as an argument. So what we're going to do is we're going to pass in do something. And then as the second argument here, it's actually going to take a number of milliseconds. So we'll just say 2000. Now what's going to happen is this setTimeout is going to invoke this function for us after 2 seconds has passed. But the thing here is that it's asynchronous. So it's actually going to continue in our code. So whatever is right down here, it's going to start executing that. And after 2 seconds has passed, it'll break from this, go back and execute this function here, and it'll console log done. So this is pretty interesting because you can have a series of function calls here or logs down here, and you realize that this one actually happens after some of these ones are executed. And that is the basis of asynchronous callback functions. When you have an asynchronous callback function, the function will be called at some time in the future. In this case, 2 seconds. The concept of something being asynchronous is that it doesn't have to be waited on in order for the following code to start executing. This concept is going to come up a lot in JavaScript, especially if you're working with single page applications. So a single page application is when you basically build a web application, but everything is in one page, basically a single application. So if on that page you click load data, for example, rather than taking the user to a new page with all that data loaded, it's going to asynchronously get that data and load it into that position on the page. So you may have heard of AJAX, for example, asynchronous JavaScript and XML. This is a way to implement this functionality if you want a particular part of a page to load without doing a page refresh. You can load that data asynchronously. Oftentimes when you're using JavaScript with some API, you will have callback functions for if something fails or if something succeeds. So if the data is retrieved successfully, then execute this function. Otherwise, execute something else. So it's very important that you understand this concept, and it all comes back down to how functions work and how they are objects themselves. When you think of functions as purely objects, you can start thinking in this functional way where we can pass functions to other functions and return functions from functions. So hopefully this video was a good introduction to callback functions as well as asynchronous callbacks. Some people will not actually consider a callback unless it's asynchronous. I would probably disagree with that though, but I'm not gonna get into all that. Basically, you can call functions inside of functions and it's cool, so you definitely wanna learn it. All right, thank you guys. Please be sure to subscribe and I'll see you in the next video. Hey, what's going on everyone? Welcome back to your JavaScript tutorial series. This is essentially going to be the hands-on follow-up to the previous video or the previous 3 videos, which were all about functions. Now we're going to be practicing with some functions, getting a little bit more experience. So just follow along. We're going to create a function and just talk about it. So what we're going to do is we're going to create a power function. I may have showed this in an earlier video, so if that's the case, just copy that code or just type out what I'm typing here. So what we're going to do is we're going to start with a total and we're just going to increase that as the loop goes on. So inside the loop we'll have an iterator, let I be 0, and we'll go until I is less than y, which is what we're going to raise x to. And then we'll say I++. And then inside of here, all we have to do is we need to increase the total. And how much are we going to increase it by? Well, we're just going to multiply it once by whatever this number is. So let's say we're raising 3 to the 3rd power. We're going to multiply total by 3 times, which will give us the correct value, which I think would be 27. So then once we're done, all we have to do is return the total. And then outside of here, we can give it a test. We'll say console.log, and we'll say power raised 3 to the third power. And I'm going to wrap all of this code inside of curly braces. Tab that over, and there we go. We should be good to go. Now let's run this, give it a try, and you can see the result is 27. So it appears our function pow is working correctly. Now we have two distinct parts here. We have the function declaration and the function invocation. So here we're declaring the function, and here we are invoking the function right inside this console log. It returns a number. That number gets passed to this console log, and it's outputted to the screen. That's how the workflow works. The parameters are the x and the y. The arguments are the 3 and the 3. So you know there's a difference between parameters and arguments. Parameters are the variables that hold what we pass in, and the things we pass in are known as the arguments. You can create a function like this, but you can also assign this function to a variable. So if you wanted to do that, we just need to change this by prefixing it with something like let my func and then assign it what we just typed out. Now, instead of referring to it by pow, we would refer to it by my func, like so. Refresh. My func is not defined. That's because I need to capitalize the F here. Do a refresh, 27. Now, in this situation, we're giving it a name here, but this is actually unnecessary because we're giving it a name here. So what we can do is we can just get rid of that, do a refresh, and it's still 27. So it seems like there's lots of different ways we can create this function. So how are we supposed to know which one we want to do? Well, this is known as a function expression versus a function declaration, which we just showed where we didn't assign it to a variable. So if you're assigning it to a variable, it's known as a function expression. And we're going to talk about the difference between these two.
What's up, everyone? Welcome back to your JavaScript tutorial series. This video, we're going to be talking about hoisting. This is going to be the concept video, pretty simple. And then in the next video, we're going to go hands-on typing out some junk on the computer. So if you're new to hoisting, basically it's the idea that JavaScript is really confusing, but I'm going to try to make it easy. So let's talk about hoisting, and then you'll start to see why I say it makes things confusing. But by the end of this video, you should have a pretty good understanding, and you will no longer be confused, so don't you worry. So the very first thing you need to understand is that the two primary ways of creating functions, function declarations, and function expressions, these are hoisted differently. And that's the main reason I put hoisting in this series, was because that's going to come up, and if you don't understand what you're doing, you're going to get yourself bit in the butt by your code. Alright, so now that you understand why I brought hoisting into this, let's just start from the scratch. What is hoisting? So hoisting is the idea that when you have JavaScript code, it's going to be scanned first, and then it's going to be executed the second time. So basically, we go through the code 2 times, and this happens automatically. We don't actually do it. When you run the JavaScript code, it's going to basically go through the code 2 times, not once. The first time, though, none of your code is actually executed. The only thing that happens the first time are variable declarations. Alright, so here's some sample code that'll help you understand this concept. Now, note we're using var. Things are a little bit different with let and const, and you'll see that in the next video. For now, just think in var. And if you guys don't remember the difference, when you use let and const, you're basically creating a block level variable. Whereas with var, that's going to be a function level variable. So if you're in the global scope, it's going to be attached to the window object. Yada, yada, yada. You can get more info on that if you want. So in this situation, we are console logging x before a value is given to x. So what is going to be outputted in the console? Well, it's actually going to output undefined. So basically what's happening is the first scan of our code, any variable declarations happen. So it goes through here. Oh, and notice this one right here, x. X is then given the value undefined. Now, the second time through our code, where our code is actually executed, it goes through, hits this console logs the value of x, and as we know is undefined. Then it goes down here, assigns the value 10 to x. This is important when it comes to function declarations, which look like this. So this is a function declaration, function do stuff, and all it does is console log the word things. With hoisting, all function declarations are hoisted. That includes the code inside of the function.
So what that means is if we invoke this function before this code, it's actually going to work. So here we have a call to this function, and now let's talk about how this code's going to be scanned with the hoisting process. First time around, it's going to scan. Bzzz. You have to make the sound effects, by the way, or it doesn't work. And it hits this function declaration. That whole thing is hoisted, so it's basically declared, including this code. Now the second time around, bzzz, oh, it hits this call. Do stuff already exists because it was brought into existence the first time around. So this works, and you will get the value things. Now function expressions do not work this way. So if we do a function expression, it's going to look like this. Then you have some code in here. In this situation, only the variable is hoisted. So the first time through, it scans, bzzz, this function's hoisted, including the body, bzzz, gets down to this function expression, and only the variable is hoisted. So var x is given the value undefined. So the actual function body is not hoisted, meaning it doesn't actually exist till we get there in the second scan when we get to this line of code. So this means if up here we try to invoke this like so, we're going to get an issue because this is currently undefined. Hopefully that makes sense, and it probably doesn't, but I tried my best. So what you need to do is you need to check out the next video, because that's where we're going to go through an example which is going to solidify these concepts and make your life a whole lot easier. Mainly when you're working with let and const, things are not going to be undefined when they're hoisted. They're still going to give you errors, and that's the primary difference, error versus undefined. And you'll see what I mean in the next video, so go check it out. Please be sure to subscribe to this channel, and peace out.
Hey, what's going on everybody? Welcome back. This is going to be a follow-up to the previous video where we talked about hoisting at the conceptual level. Now we're going to go through some code samples to illustrate these concepts. Now, I already recorded this video once, and I'm redoing it because the first time it was just really complicated, and the goal for this video here is to keep it simple. So if you want to know all the juicy details, you can find all that stuff online. You can find examples of where this might bite you in the butt, but most of the time you're not going to have to worry too much about it. But it is good to understand the concepts, so let's talk about them. Basically, you can see the concepts of hoisting by doing a console log and putting some variable in here that you've never created. Do a refresh and we get x is not defined. Now, if after this we go and create this variable and assign it a value, now when we do a refresh, we get undefined. So this line of code that comes after this one is affecting the output. So what is going on here? Well, you can basically think of it as a two-step process. First step, our code is scanned and any variable declarations, such as var x, happens first. Then the second time around, the second step, the code is executed line by line. So the second time around, this is hit, and var x has already been declared, which is why we get undefined, which is the default value when we declare a variable. So logically, this is what's happening. We have var x, then we console log x, and then we assign a value to x. Now your code is not actually being rearranged like this, but this is the way you would think about it. When we do a refresh, we get the same exact value. Now when we're talking about functions, function declarations are hoisted, including their function body. So if I do something like this, function do stuff, and in here we'll just console log, we'll just say, hey. Well, we can obviously go down here and call this function, do a refresh, and we get hey. But what we can actually do is we can take that line and we can put it at the top, and it will still work. So we do a refresh and we still get hey. That's because this entire thing happens first in that first sweep, and then the second time around, the function call happens. So logically, you can think of it like this. The function is going to be moved to the top, and then we're going to execute the function. Again, our code's not actually being rearranged, but that's how you can think about it. So I'll put that back to how it was. Now this is a function declaration. Function expressions are a little bit different. So if I assign this to a variable, we'll say var do stuff, assign it this function, and this is specifically for var. We'll talk about let and const in a minute, which is a little bit different. Now when we do a refresh, you can see we actually get an error. See, this is a function expression, which in function expressions, it works just like any other variable, only the function declaration is a quote moved to the top. So logically, it's going to look like this. Var do stuff, and then we'll assign a value to do stuff down here. When we do a refresh, you can see we get the same value. So you can think about it this way. So function expressions, only the variable is hoisted and not the entire body. So that is the primary difference between function declarations and function expressions. Function declarations, the entire thing is hoisted. For function expressions, only the variable is hoisted, which is the same exact way it works for any other variable. So function expressions have nothing special about them. So the main takeaway, when working with function expressions assigned to variables, we cannot use them before they are assigned to. We can only call this function after we assign it a value. Now when we do a refresh, we get hey, and we don't actually need that line anymore. Well, we didn't need it in the first place, but you know what I'm saying. Do a refresh, and there we go. Now, when you're working with let or const, you're never going to be able to use the variable before it is initialized. So let's go through an example like that. If we say console log, pass in x here, and then we say let x and assign a value 10, do a refresh, you can see we get an error. Cannot access x before initialization. So that is how it works with let and const. You can kind of think of it as procedural. It's not going to do anything ahead of time. Now, if you want to know all the juicy details about let and const, it's basically broken up into a 3-step process of declaration, initialization, and assignment. There is technically a little bit of hoisting with let and const where the declaration happens, but it's not actually initialized with the value undefined. So no memory is given to this variable. And this is a little bit confusing, so I didn't really want to get into it because I don't believe the natural human being breaks up variable creation into 3 steps. Usually it's thought of as 2 steps, declaration and initialization. When we're talking about let and const and hoisting, it's split up into 3, declaration, initialization, and assignment, where the declaration says, hey, there is a variable here. The initialization is where we give that some memory and initialize it to undefined. The assignment is when we actually give it a value such as 10. So if you want to be that granular, then that's fine. With let and const, only the declaration step happens when the hoisting happens. So the initialization, where it's actually given the value undefined, that happens when the code is actually hit. So if you want to know more details, here is a good article, Hoisting in Modern JavaScript with let, const, and var. Here you can get all of the code samples explaining the difference, but functionality-wise, you don't really have to worry about hoisting with let and const because the code is going to work as you would expect if you went through the lines one by one. So yeah, if you want more info, check this article out. Otherwise, thank you guys for watching. In the next video, we're going to be talking about functions as first-class citizens. Super important topic, and it's definitely one of the big pieces of JavaScript. So go check it out, and please be sure to subscribe. Thank you, and I'll see you in the next video. Hey, what's going on, everybody? Welcome back. This video, we're going to be talking about functions as first-class citizens. So over the last 5 or so videos, we've talked about functions, hoisting, and all kinds of other cool stuff, and now we're going to talk about one of the key things of JavaScript, and that is functions as first-class citizens. So it's a weird way of saying functions are treated just like any other object. So you may also hear this concept called first-class objects instead of first-class citizens. Same thing, don't have to worry about it. So what exactly does this mean? Well, there's a series of things you can do with functions that you can do with normal objects, and we're going to be talking about that in this video by going through these examples. So the first thing, you can assign a function to a variable, and we have talked about this with function expressions. So this is a function declaration. Well, as soon as you assign it to a variable, it becomes a function expression. So we could say let pizza, and then we can assign it this function, and then down here we can call pizza and pass in some numbers. Doing a refresh, we get 27. So that's the first thing. Assigning a function to a variable is something you could do with another object. So for example, we could say let things and assign it some object. This is just an empty object, but you can go and put stuff in it if you'd like. But that is an example of something you can do with a function that you can also do with a normal object. The second thing is you can add a function to an array. So let's first get rid of this pizza here. We don't really want to use that the whole time. So let's just clean it back to how we had it. And let's say we create an array. We'll call it cool functions. And what are we going to do? We're just going to assign it an array, but we're going to start with the value pow. So that's this function here. And now we can access the values inside of cool functions. So just to see that, we can say console.log and just pass in cool functions. Do a refresh and you can see inside of here we have pow.
So we could call this, we could say cool functions index 0, and then we can execute it and pass in 2 values. Like so. Save and do a refresh, and we get the value 27. So adding a function to an array is the next thing that you can do with JavaScript functions. Next thing you can do is you can add a function to an object as a property. This is also known as a method. So for example, we can create an object, we'll just call it math functions, and we'll assign it some object, and then inside this object we can give it some properties. We'll say power, and we'll assign it pow. So pow is the function up here, but now we can access it through math functions. So down here we can say console.log, we'll say math functions dot power, and pass in 3 and 3. We'll get rid of this other console log here, do a refresh, and there we go, we got 27. And just to confirm, it's coming from line 16 right here. The next thing is that we can add properties to a function. This one might be new to you. So because a function is just an object, and objects have properties, we can actually add properties to functions. So what is that going to look like? Well, here we have the pow function. Let's say we wanted to describe this function. Well, we can actually say pow.description, or whatever we would like, and give it a value, like so. This property could be used to explain what the different parameters are for, or how to properly use the function, and then this can be accessed on this object. So for example, we can console log pow.description, do a refresh, and there you go. The next thing is that you can pass a function to a parameter. This is common with what are known as callback functions. So for example, let's create a function, and we'll just call it callback example. And this is going to take a callback. Now a callback is just a function that's going to be executed inside of a function that takes it as a parameter. So we could say return callback 3, and we'll raise it to the 5th power. So I just said we'll raise it to the 5th power, but this is actually general. We could pass in any function we wanted to this function as a callback. But to use this, all we would have to say is callback example and pass in pow. So how's this going to work exactly? Pow is going to be passed in here, and then it's going to be executed inside this function here. Do a refresh. Now the value that this calculates is going to be returned, so we actually need to do something with that, so we could console log it here, like so, and do a refresh, and there we get the value, 243. So passing a function to a parameter is not something you commonly see in other languages. So for example, if you're using Java or C#, you don't really do that. But in JavaScript, that's very common with callback functions. The last one I have for you is that you can actually return a function. So in this situation, we're not returning a function, we're actually calculating some value and then returning that value. But just the same, we could return the function itself, and then we can use that return value. So let's rename this. We'll just call this return a function, and it's going to have a function here as a parameter. And then all we're going to do is return that function. Now, all these examples are obviously very exemplified, not necessarily 100% useful examples, but the concepts persist beyond just these silly examples here. Instead of actually taking a parameter, we can actually just return a function that already exists, such as pow. That'll make it a little bit easier for us. Now what we can do is say return a function, call it, and then with the thing that's returned, we can call that. So the syntax is a little bit weird. Let's say we want to raise 10 to the 3rd power. That's how you would do this. Do a refresh, and I think we have to console log it. Yep, and then do a refresh, and we get 1000. Wow, so that's a lot of stuff. So the first parentheses here, that calls this function. That returns a power function, which we then call with these parentheses here. So to conclude, the main things we covered, I think we covered 6 things. You can assign a function to a variable. You can add a function to an array. You can assign a function as a property of an object. You can assign a property to a function. You can pass a function as an argument, and you can return a function from a function. So those are 6 things that basically set JavaScript functions apart from other programming languages, and that's why we call them first-class citizens or first-class objects. Hopefully that was helpful, and yeah, that's all I got for you guys in this video. In the next video, we're going to talk about how we can use one of these capabilities to our benefit. So thank you guys, I'll see you then. Hey, what's going on everybody? Welcome to this video. We're going to be talking about memoization. And yeah, I'm probably saying it wrong, but I don't care. And what is this exactly? Well, using the concepts we talked about in the previous video, functions can be treated as any other object. So we can actually attach a property to a function to basically keep a memory of all the computed values. When would you want to do something like this? Well, if you have some kind of algorithm or something you're trying to calculate that's very computationally expensive and you don't want to have to repeat over and over calculating the same thing, you can use memoization to your benefit by storing a record of what the result will be. So this might be common in, say, for example, if you want to calculate the factorial for a bunch of numbers. Well, if you calculate the factorial for some number such as 500, that can take a lot of computational effort, and if you have to do that numerous times rather than repeating it, you could just look up the value and boom, you're done. So we're going to be talking about that concept here using power function. So basically we're going to calculate powers and we're going to store those using the memoization technique by basically adding a property to this function. So if you're in a language where you can't add properties, you can certainly use a different variable or a different data structure, but we're going to take advantage of the capabilities of JavaScript. So what is this going to look like? Well, before we get into the actual solution to do this, let's start with a very simple example where all we're going to do is we're going to output all of the things we've calculated with this function, all of the results. So to do something like this, we might create a property. So we'll just say pow.calculated, and we're going to make this an array. And now what we're going to do is after we calculate some value, we're going to append to this array by saying pow.calculated.push, and then just pass in that value, the total. So let's go through an example of this. And we're also going to output it. So we'll say console.log, and we're going to log pow.calculated so we can just get a regular update of what the value of pow.calculated is. Then outside of this function, what we're going to do is we're going to call it. So we'll say pow33, and this is going to return the value. So unless we're doing something with it, it's not going to be very useful. So we might want to console log it, or we might want to pass it into another function. But since we're doing this console log here, you can still see some output, so I'll show you what I mean in just a second. So we can do two examples of this. Do a refresh. The first time 27 was calculated and it was pushed onto the array. Then the next time the 27 was calculated again for this one and it was pushed onto that array. So that is basically a way to maintain state between numerous function calls. The state of this calculated persisted after the first function call, and it was appended to during the second function call. So as we do more and more examples, you'll see that different things show up in here. Let's do the fourth power. All right, do a refresh, and you can see it just grows and grows and grows. Now, obviously, this is not helping anything because we're not looking up into this calculated array to see if a value has already been calculated. We're just adding to the array and then just doing the calculations again each time. So this algorithm right here is going to be executed every single time. In order to bypass this algorithm to save computational effort, we need a way to basically look up to see if a value has already been calculated. And when would you want to do this? Well, if this algorithm was very time consuming, in this case, it's not so bad. Calculating the power isn't that big of a deal. But if we're working with really large numbers or some more complicated algorithm, we definitely want to consider a shortcut. Now, in order to look this up in some array or object, we need basically a key value pair system. So the key is going to be the input, and then the value is going to be what the output would be. So right now, over in the arrays, we're just storing the result, but there's no way for us to look up what input got us that result. So it's not really helping us any. So in order to basically have that key value pair system, we can use some data structure. We're going to use an object because an object is just key value pairs. So we're going to change this to an object by switching it to curly braces. Now for the actual key, you can use whatever mechanism you can think of to basically have a unique way of describing the input.
What I'm going to do is I'm going to use strings. So what we're going to do is we're going to create a variable in here, and we'll say let string version, and we'll assign it the value x plus, that's the first parameter, and then we'll just have the caret symbol to represent raising it to the power plus y. And just to see this, let's console log string version, and let me give some more room here, and then we'll output string version here. So now when we run this, this push is no longer going to work because we're working with an object. So let's just comment that out, do a refresh. You can see what these string versions are: 3 to the third, 3 to the third, 10 to the fourth, and 10 to the third. So we can use those for the keys, and then we can have the actual end result as the value. So to do that, instead of using this push technique, what we're going to do is we're going to say pow.calculated, and you can actually use array indexing like syntax and say string version, so that's going to be the key, and then we're going to assign it the value, which is going to be total. Now when we do a refresh, let's look at what's going on here. So the first time we pass in 3 to the third power, and then 3 to the third power has the value 27. When we do it again, that key already exists, so it's replaced. Then we do 10 to the fourth, we get a new one in there, and then 10 to the third, we get another one in there. So now what we need to do is, instead of replacing the values, we actually need to check to see if that value already exists. So to do that, before the algorithm, we can do a conditional. Say if string version in pow.calculated, that'll search for that key. And if it exists, what are we going to do? We're just going to return the value. So we return pow.calculated, and then inside of the square brackets, we put the key we're looking for. So we say string version, and this is going to refer to the value. And just for fun, we'll do a console log, and we'll say found. So now let's do a refresh. The first time it's inputted, the second time it says found, and it no longer does this console log down here. And then it goes on to the next ones where each time it's added. So to show this even clearer, we'll do a console log down here. And I know console logging everywhere is not the best way to do this, but it's nice and easy to visualize. So what we'll do is we'll just say calculating. So either it's going to return the value already, or it's going to do the calculations. Now when we do a refresh, every time it says calculating, it's going through that algorithm again. Anytime we have a repeating use, it's going to save us some time by not recalculating it. Do a refresh here. Now we have 3 to the third, 3 to the third, 10 to the fourth, 10 to the fourth. You can see the first time it's calculating, second time it's found. Same thing, calculating, found. So that is an introduction to memoization and how we can optimize an algorithm by storing key value pairs of inputs and outputs and referencing those to see if we've already done that calculation. Again, this string here, I just totally made up that convention. If you have some better way of representing the input and the output, go for it. I'm sure you can think of something awesome. So that's all I got for you guys in this video. In the next video, we're going to talk about default and REST parameters. So that's going to be pretty cool. Please be sure to subscribe, and I'll see you in the next video. Hey, what's up everyone? Welcome back. In this video, we're going to be talking about default and REST parameters. We're also going to touch on the arguments parameter as well as a couple of other things. So it should be a pretty good video. I'm pretty excited, and I think I'm ready to get started. All right, so the thing with JavaScript is that there's no real concept of overloading. So when we create a function, such as this pow function, that is the function that will be called no matter how we invoke pow. So if we invoke pow like so, or if we invoke pow like so, it doesn't matter how many or what type of arguments we pass in, it will always execute this function right here, pow. So let's just see what happens when we run it like so. Let's do a refresh. The first one gives us 1, and then the second one gives us 1. That's because the first one is just going to start with 1, and that's what's going to be returned. The second one, I think it's only really paying attention to the first 2 arguments here. Do a refresh and we get 16. Yep, it seems I'm correct. So this is a potential issue because people that might be using your code as a library, or you who might be referencing a function, you might not exactly invoke it the way you expected it to be invoked when you created the function. Or we might be wanting to have multiple versions of the function, accepting different numbers of arguments, and so forth. So there's a lot of different flexibility things we need to concern ourselves with when it comes to JavaScript functions and the number of arguments passed in.
So the first thing, let's talk about when we have less arguments passed in. What are we going to do to address that? Well, there's 3 things I got that could help with less arguments. But first, let's get rid of this, and now let's talk about the 3 possibilities. The first is to use default parameters. So for example, let's say if we don't pass in this y, we want it to default to 2 and square the number. So let's just pass in 3, and we just want it to square it, which will give us the value 9. Well, to do that, all we have to do is put y equals 2 up here in the parameters as a default parameter here. Now when we do a refresh, you can see we get the value 9. The second way is you can test the value of y inside of the function. So for example, we could say if y has the value undefined, then what we're going to do is we're just going to set the value of y to 2. This should work the same way, and we can get rid of that default parameter. Now we do a refresh, we still get the value 9. Either one of those will work. I prefer the first one. And now what about that third option I was telling you about? Well, it actually serves the same purpose as number 2. It's just a different way that you might see it. So what this is going to look like is you can basically do the ternary operator by using the type of y. And if the type of it is undefined in strings, then if it's undefined, we're going to return 2. Otherwise, we'll just keep whatever the value of y is. And this needs to be assigned to y. So this is obviously a lot more verbose than this version. So of the 2, I recommend this, but you might see this in older code. So let's just see if this works. Let's get rid of that line, do a refresh, and you can see we still get the value 9. So there's 3 options for you. I'm just going to stick with the obvious easy one, which is to use the default parameter there, get rid of this junk. And there you go. So that is the way you deal with less arguments than you need for all the parameters. The solution is to use defaults. Now, what if you pass in too many arguments? So let's say we raise 3 to the 3rd power, and then we pass in some other mumbo jumbo that we don't really know what it means, but someone passed it in just because. Well, you can actually access this data inside of the function still. And the way you can do that is by adding another parameter here and using the 3 dots. So you create an ellipsis, and then you give it a name, so we could call it extra, for example. And I'm going to get rid of this default here. So now we have x, y, and then ... extra. And we can output extra inside of here to see what it contains. So we'll use extra just like a normal variable. You only need the 3 dots when you're defining the parameter there. Do a refresh, and you can see it contains 4, 6, 3, 4, which is actually all the extra stuff that we passed into this function. So when would something like this be useful? Well, if you're working with the power function, we don't need any of that extra stuff, so I'd probably just get rid of this here. And if someone passes in extra data, then don't worry about it, just ignore it, which is the default behavior. But there are certain times when you want to create functions that accepts unlimited arguments passed in. So let's go through an example of that. Let's create a function down here, and we're going to call this largest. And it's going to take 1 argument, but then it's going to have extra as another option. And you can name it whatever you want, that's up to you. And what this is going to do is it's going to look through all of the numbers and return the largest one. So we'll basically keep track of the largest using a variable, and we'll first assume that the x is the largest. Then we'll try to prove otherwise. So we'll do a for loop, and we'll go all the way up to extra.length, and then I++. And then all we have to do is compare the extra value, whatever one we're on, to the largest, and if it's bigger, then replace largest. So we'll say if extra index I is greater than largest, what are we going to do? We're just going to set largest equal to extra of I, like so. And then once we're finally done with the loop, we can return the largest, and it's going to return the actual value, not the index. So it depends on what you want. If you want the value, you can do this. Otherwise, you can keep track of the index and return that. Now, instead of calling power, let's call this largest function and see what we get. We do a refresh, and we get 6, which indeed is the largest variant value inside of this. Let's try another one. We put 30 at the beginning, we get 30. Maybe we put 45 at the end, and we get 45. And this is cool because we can put any number of arguments in here and it should work. So we can go up here and put 2000, 10, and so forth. Do a refresh, and you can see we get 2000. So we basically created a function that'll work with any number of arguments. Very versatile, very cool. Now the other thing I wanted to talk about was implicit parameters. So what is an implicit parameter? Well, anytime we use the term implicit, it means behind the scenes or not explicitly stated. So when we have a function, there's implicit parameters that we can use that give us more information. So the first one is this. So we can console log this, and I'm going to call that function. So down here, I'm going to call pow, and it should output this, which you can see is the window object. We're going to get into this in the next video, so don't worry about it for right now, but one of the other implicit parameters is actually called arguments. So what you can do is you can do console.log, pass in arguments, and this is going to contain the argument data. So if you expand this, you can see index 0 is 3, index 1 is 3, which correlates to the arguments passed in. So this is similar to an array, but it's actually not quite an array. So you can work with it like it's an array, it works with indexes, but it's not going to have all of the capabilities of an array. You can convert it to an array if you want, but the only real time you're ever going to want to use this arguments is if you're working with legacy code and you don't have the capability to use the REST parameters here that I talked about earlier. So the recommended way is to do this, but anytime you need those implicit arguments, you can do that like so. And the other obvious benefit of using the REST parameters I talked about is that this is an actual array, so it's going to have all of the methods that you would expect it to have, unlike the arguments that we talked about earlier. So that's all I got for you guys in this video. In the next video, we're going to go into detail of what this means, and that'll be fun because that's a really big piece in JavaScript, and it's extremely important. So go check that out, and I'll see you in the next one.
What's going on, everybody? Welcome back to your JavaScript tutorial series. This video, we're going to be talking about this. You may also hear it as the function context, but we're going to refer to it as this. So when you have a function and you invoke this function, you pass arguments. So for example, if you have a function called x, we might pass in the values 5 and 10. And these are explicit arguments. We're typing them out manually with our hands. There's also implicit arguments where we don't type them out and one of these is the this argument. So you can kind of think of it as an invisible argument passed in right here called this, but you don't actually type it. This is just how you can imagine it with your brain. So that means inside of the function x in the function body, you can access this variable this that happens to be passed in implicitly, and we can do stuff with it. So here we have this function, and what we could do is we can console log this, which is the thing that was passed in implicitly. Even though it's not defined in this parameter list, it still exists. It's a thing. Throughout the rest of this series, we're going to use the keyword this to do all kinds of various powerful things. So for example, we can use this inside of methods to refer to the object that it's being called on. We can use it inside of constructors to refer to the new object. All kinds of things that we can do with this. It's not so much important that you understand all the uses of this by the end of this video. That's because we're going to go into that in the next video. The main thing is I want you to understand where this comes from. And as you understand now, it's an implicit argument that's passed to the function. Now, one of the things I don't like about this is that if you create this function like so, and this contains some value, don't even worry about what it is right now. Well, the way that we invoke this function is going to change the value of this because the argument that's passed in is going to change based on the location in which we call this function. Again, you'll see that in the next video where we talk about the different ways to call functions. But for now, just understand that the value of this can change based on how we call it. The reason I don't super like this is because the behavior of the function changes based on how you call it, which makes creating predictable functions a little bit challenging. See, with these parameters here, we expect different inputs. You know, we might pass in a 5, a 10, or a 20, and we acknowledge that, we understand that. But we also have to worry about this. So if the function uses the value of this, we have to consider all the different possible values for this. So it can be a little bit more complex than what you might expect from another programming language. Inside of another programming language, such as C# or Java, this always means the same thing.
it always means an object that a method is attached to. That's because inside of C# and Java, it's object-oriented, everything is an object, and all functions are methods. But in JavaScript, it doesn't work that way because we can have a function as its own entity. We can invoke this function with the new keyword and then it becomes a constructor. And on top of that, there's another capability that JavaScript has called strict mode. So you can say use strict and then the functionality of this changes again. So there's a lot of different variations and you need to understand all of them. So it's a little bit complex. The content of this video has been very conceptual. What exactly do you need to know? What is your takeaway from this video? A couple things. 1, this is passed in as an argument to the function implicitly. 2, the value of this changes based on how we call the function. And 3, most of the time, this is going to refer to an object that has a method on it. So imagine this function was attached to an object. Then it might look something like this. And these names are like terrible because we just have totally random names. But we'd have dog.x. Just as an example. Well, now this is going to refer to that object. So it would literally output the object that it's attached to. That's coherent with other programming languages as well, C#, Java. This is always used to refer to the objects that methods are being called on. So to show you guys this, take a look at this object here. It's an object literal called me. It has a name, which is Caleb, and then we're going to attach a function to it. And let's say inside of this function, we output the value of this person's name. The way we can do that is by saying this, which refers to the object the method is attached to, dot name. And this is how a method refers to the object it's attached to. So when this function uses this in this context, it's like saying myself dot name. So yeah, a little confusing, but trust me, it's gonna be cleared up in the next video where we're gonna go over some examples. So please be sure to subscribe and check out the next video. It's gonna be awesome, so see you then and peace out.
Hey, what's going on everybody? Welcome back to JavaScript tutorial series. If there is one video in this series that's going to help you the most as a JavaScript developer, it's going to be this one. And yes, pun intended, because we're going to be talking about the this keyword. So you'll often see the this keyword used inside of functions to refer to various different things. And that's what we're going to be talking about because it doesn't always mean the same thing. So what we're going to do is we're going to start by creating an object and we're going to attach a function to this so then it becomes a method. And then we're going to call this method and we're going to see what happens when we output this. So let's just go through an example and we'll go on from there. And by the end of this, you'll have a pretty good solid understanding of this keyword. So we'll say, we'll just create an object for me and we'll give it some properties. So this is my name. And then we'll just say, output me, and this is going to be a function. And all this function is going to do is just going to console log this keyword. That way we can see what the value of this is when we invoke this method. So now we need to invoke this, so all we have to do is say me.output me and invoke it using the parentheses and do a refresh. And what do we get? Well, we actually get the object itself. So you can see it has a property name and then it has a function. So the very first way to think of this is if we invoke a function as a method. So when we invoke a function as a method, which just means it's attached to some object, the value of this inside of that function call is going to refer to the object itself. This gives developers the possibility to refer to the object itself inside of a function call. So for example, I could do a console log and I could say this.name. This is just another way to refer to the object, so this is how we can get that value. So we do a refresh, and we get Caleb. This is actually the way it works in most other programming languages, such as Java and C#. When you use the this keyword in a method, it always refers to the object that the method is being called on. But there's a lot of variations in JavaScript, which is where people get confused, because in other programming languages, this is the only use of this. But in JavaScript, it depends on how you call the function. So I want to show you guys that in this video. What we're going to do is we're going to take this function, we're going to copy it, and we're going to put it on the outside. And what we're going to do is we're just going to say function output me. And instead of having this function here, we're just going to say output me. do a refresh, everything stays exactly the same. And I'm going to get rid of this line here because we're not going to need that anymore. So we created the function on the outside, but it's still attached to this object, and we're calling it as a method because it's after the dot on some object. The next way is just to call a function like a normal function. So in that situation, all we would do is say output me and invoke it. Do a refresh. Well, now we get this window object. So what in the world? So when we invoke as a function, we get the window object. Now the next variation is if we call a function that is using strict mode. So if we say output me, and we'll just give it, we'll just say output me strict. Then inside of here, just say used strict. And what this will do is this will change the functionality of various JavaScript pieces, basically to help protect you from common flaws of JavaScript. So I'm not sure if we talked about it in this series or not, but that is what it's used for. So everything after here inside of this function is going to be in strict mode. So in this situation, if we console log this, we're actually going to get undefined. Oh, I should probably invoke it. Output me strict, do a refresh, and we get undefined. So this is invoking a function in strict mode. Now if we put use strict in this one, just to show you guys for a second, when we do a refresh, well, the first situation, it still refers to the original object. So we only get undefined when we're calling it as a function and not as a method. There's a lot of information to this stuff, and it definitely takes some practice to understand all the different ways. The next way is calling a function as a constructor. For this example, we're going to start with a constructor. What is that going to look like exactly? Well, we're going to create a constructor for people. So this constructor can be used to create numerous people. And the way you would use it would look like this. So we call the function with the new keyword. It has a capital P because that's a convention for constructors. And then we assign it to a variable. In this case, we said person with a lowercase p. Now what we can do is we can console log this and see what the value is. We do a refresh and you can see it's an empty object. So when you call a function as a constructor, the value of this refers to the new object that's being created. So that means we can refer to this new object by saying this.name and giving it some value. Then what we can do is we can console log this afterwards and do a refresh, and now it has a value. So basically what's happening is we call this function with the new keyword, and an empty object is being passed into the implicit this parameter, and that is going to refer to the object that's assigned here. So if we went down here and we console logged the person with the lowercase p, the variable, do a refresh, these are going to be the same exact thing. So those are the 4 ways that you should know about creating functions and how to invoke them and what the values of this will be. So to conclude, we can call a function as a method, we can call it as a function, we can call it as a function in strict mode, and we can call it as a constructor by using the new keyword. Now there are a couple functions you might want to know about. Specifically, if you look up call, apply, and bind, these are some functions that you can use to be a little bit more explicit about what you want the value of this to be. Maybe we'll get into that in the next video. I guess we'll just have to watch and find out. So thank you guys for watching. I'll see you in the next one.
Hey, what's up everyone? In this video, we're going to be talking about the call and apply methods inside of JavaScript. Very useful when it deals with the this keyword, and it allows us to modify what the value of this is. So as an example, we're going to create a function. We'll just call it do stuff. And if you're wondering what this function is going to do, it's going to do stuff. So in here, I want to console log, and what I want to console log is I actually want to console log the argument. So whatever we pass in. So we're going to create a parameter here. We'll just call it input, and we're going to console log it. Now what we're going to do is we're going to call this function, and we'll just pass in the value 5. Do a refresh, and we get 5. Now the next thing I want to output is this keyword. So whatever the value of this is, and I need to put my semicolons here. There we go. Now we do a refresh, we get 5 and the window object. Now check out the previous video if you need to understand why it's the window object, but I'm assuming you understand that, and that's really not the focus of this video. We're just going to try to change the value of this. Now to change the value of this, all we have to do is call a method on the function itself. So we say do stuff dot
And then the function is called call. And the arguments we pass in is the first one is the value of this. So we can put whatever we want. And then the next argument is the argument we want passed in into input right here. So we'll just go with the value 5. Now we do a refresh, we still get the value 5 here, but now we have a string that says hello. So that is how you can specify what the value of this should be. Now if there's multiple parameters, such as input and input 2, all we gotta do is put a comma, and we can put that here as well. So we can put a 10, and what we'll do is we'll console log both the inputs. Input 2. Awesome. Save and refresh. Now I get 5, 10. Everything works exactly the same. Now there's a very similar method called apply. And the way this works is you're going to use it the same way, but instead of passing in separate arguments, you're just going to put them in an array. Now we do a refresh and we get the exact same result. So both call and apply are used to change the value of this, but the difference is call will take separate arguments and it'll be passed into each argument, and apply is going to take an array of arguments. You may also see this assigned to a separate array, so for example you could say let args and assign it 5, 10, and then instead of passing it here you could just say args. So that is call and apply. You'll probably run into those in your JavaScript career, and that is how they work. So thank you guys for watching. Please be sure to check out the next video because we're going to be talking about bind, which is another important method you should know about. That's all I got, and peace out. Oh, and don't forget to subscribe. Hey, what's going on everybody? Welcome back to your JavaScript tutorial series. Please be sure to check out the previous video because that's where we talk about call and apply. Now we're going to be talking about bind. So bind is another useful function that you're going to run into. And the purpose of this is also to change the value of this. But it works a little bit different than call and apply. Call and apply change the value of this right when you are invoking the function. Bind is a little bit different because it's actually going to give you a new function where the value of this is permanently changed. So the way this is going to work is instead of calling apply, we're going to call bind, and the arguments, the first one is going to be the function context, the value of this, and then the next one is going to be the first argument. So it works similar to call in that we don't put it in an array. So what we're going to do is we're just going to get rid of this line altogether, and we're just going to pass it in as separate arguments like so. Now when we refresh, nothing's actually going to show up. Why is that? Because this doesn't actually call the function. All it does is it creates a new function, so we actually need to assign it to something. So what we could do is we could say new function and assign it this value. So now all we have to do is call this new function like so. Do a refresh and we get the values we were expecting. So there are various uses you can find for call, apply, and bind on the internet, but the main thing you need to understand is how they work and that you can pass your own custom objects in for the value of this. So it doesn't just have to be a string, it could be an object you created. So for example, you could say let me, you could give it a name, and then you can pass this value in for the value of this. Now when we do a refresh, we actually get that object. So you may also hear the concept of this known as the function context. The function context is just another word for this. But most people just say this, and that's what I've been using throughout these videos, so that's what I'll try to do as we go on in the next videos. So another topic related to the value of this deals with arrow functions. We've touched on them a little bit in this series, but the value of this is different for arrow functions than what you would expect for normal functions with function declarations and function expressions. So what we're going to be doing is in the next video, we're going to be talking about arrow functions, how to create them, the syntax, etc. And then what we're going to be doing is we're going to be talking about the value of this inside of arrow functions. Thank you guys for watching. Please be sure to subscribe, and yeah, go check out the next video. Thanks. Bye.
Hey, what's going on everybody? Welcome back to your JavaScript tutorial series. This video, we're talking about something super special. We're going to be talking about arrow functions and bow functions. I'm playing, guys. We're going to save the bow functions for another video. So, just arrows today. Alright, so what in the world is an arrow function? It's basically a new way to create a function. And it looks a little something like this. Alright, so here we have opening and closing parentheses, and then we have an equal sign and a less than alligators, okay. Greater than sign, and then an expression. So this is one variation. This is the concept video. In the upcoming video, we're going to be going over some examples. So you guys know how I like to pair things.
So make sure you watch both parts. So the equivalent for this in a function declaration would be something like this. And this is pretty close. So pretty much a lot of the stuff stays the same. The parentheses is where the parameters go. Dang it, drop my chalk. The expression is what we are returning. So it might be something like 5 plus 5 or some calculated value or something like that. Any expression can be returned here. In this situation, we do not use the return keyword. We just put the expression. So you have to type less, which is a burden. And you can also notice that there's no curly braces and we don't have to have the function keyword. So overall, it's just a lot less typing, very concise. Now there are a couple variations. For example, if you want to have a parameter, for example, x. And then in this situation, what we can do is let's just say we want to return x squared. Bless your soul. So it might look something like this. Now there is one thing you need to also add here. So right now we can reference this function by using x, which is the name of the function here. Let's give it a better name. Let's call it func. Well, if we wanted to reference this one, well, we actually need to assign it to a variable. So it might look like this, like so, and then we invoke it the same way we would invoke any other function. And we would pass in some number, such as 5. That's going to give us the value 25, which we could then console log or pass into another function or whatever. All right, so let's talk a little bit more about the syntax. Specifically, these parentheses, they're actually optional when you have one parameter. So we can actually get rid of this. And then all we have is x, fat arrow, x times x. They are required when you have 0 or 2 or more parameters. So if there's one, they're optional. Another thing, inside of here, you could put a lot of statements, right? You can make a really complex function. But this is just an expression. We can't put more than pretty much anything there. So if you want to do more statements inside of the function, you actually need to make a function body using curly braces. And that's totally fine. In this situation, you would need to use the return keyword to return something. So it would look like this. Beautiful handwriting, I know. So the only thing we did is we added the curly braces and put a return. But now we can have multiple statements. So before this statement, we could have another statement with a semicolon and all kinds of different statements. Now, what is special about arrow functions? We're going to get into this in a lot of detail in the upcoming videos. But the thing that's special about arrow functions is the keyword this. So with normal functions, this changes based on how you call the function. With arrow functions, the value of this is always going to be the same, and it's determined by where the function is created rather than how the function is called. So back in my in-person video about this, I was complaining how with normal functions, they're a little bit unpredictable because this can change. Well, arrow functions fixes that problem because the value of this is always going to be the same. There's a couple of things you gotta be careful of with that and make sure you get the right value of this, but we're gonna be talking about all of that. So hopefully this video gave you a pretty good introduction to the arrow function, and be sure to check out the next video because we're gonna be doing some code. So yeah, peace out. Woo! Okay, I didn't hit you. That was a close one. I threw the arrow at the camera. I missed on purpose though. It wasn't even close.
Hey, what's going on everybody? Welcome back to your JavaScript tutorial series. This video, we're going to go through a sample of creating an arrow function and understand the syntax of how to make that work. So first thing we're gonna do is we're gonna create a normal function and then we'll convert it to an arrow function. So real simple, we'll just create a cube function. And all it's going to do is it's going to return x to the third power, which you can do by multiplying it by itself, like so. Now to call this, all we gotta do is say cube, pass in some value, and we can console log it, like so. Now when we do a refresh, we get 125. So 5 times 5 times 5 is 125. Now if we wanted to make an arrow version, it would look like this. We would say let, and then say whatever we wanted to call it. We'll just call it cube. It's hard to talk and type at the same time. Cube arrow, and then we can assign it the function. Now what is the function going to look like? Well, first thing, we have the parameter x, and then we have a fat arrow, and then we have what is going to be returned. So x times x times x. And to call this, it's going to work exactly the same way. We'll console log it, and we'll just say cube arrow and pass in the value 5. Do refresh and we get 125. Now you'll often see on the left side parentheses around the parameter, and that's totally fine. Do a refresh and it still works. Sometimes the parentheses are required, other times they are not. So when are they required? They are required if you have no parameters or if you have more than one parameter. So 0, 2 or more. But 1, they're optional. So for example, if we didn't want to pass any parameters in here and we just had a actual literal value, well then we would need those parentheses, and when we do a refresh we still get the same value, but now our function becomes a lot less useful. So I'm going to go back to having one parameter and having the parameter multiplied. So again, no parentheses when there's one parameter. Now on the right side you can have an expression like so, and that will be returned. So you do not need the return keyword. Or what you could do is you can actually put a block of code. In that situation, you're going to need the curly braces, so it would look like so. And when you put the curly braces, the return is no longer implicit. So when we do a refresh, we're actually getting undefined. So if we have curly braces, we actually need to say return. Now we get 125. So when you put the curly braces, it functions just like a normal function where you can put numerous statements inside of the curly braces. So for example, what we could do is we could make a more complex function. And then we could even do other statements in here, such as a console log. And then we just need to be sure we have that return keyword, like this. Now you can see it says calculating and we get a value. So if you just want to return some value that is calculated from some expression, you do not need the curly braces and you do not need the return keyword. If you want to do a little bit more of a complex function, then you're going to need those curly braces and you're going to need the return keyword. You can assign this function to a variable such as cube arrow, how we did it here, but you'll also often see this for callback functions. That's because it's very concise. You can put a lot of information without typing a lot. Going back to the simple example without the curly braces, you can see that this here is a little bit simpler than up here. Less typing, no curly braces, and no need to type the return keyword.
So that's how to create arrow functions. In the next video, we're going to be talking about the value of this inside of arrow functions. Very, very important, and it's one of the key differences between normal functions and arrow functions. Be sure to subscribe and check out that next video. Peace. Hey, what's going on everybody? Welcome back to your JavaScript tutorial series. This video, we're going to be talking about this inside of arrow functions and how it's different than regular functions. So before we get started, which by the way, this video is going to be freaking awesome. All right, so what we're going to do is we're going to create a very, very simple arrow function, and we're going to create a really very simple normal function. So we'll just call it arrow. So we'll say let arrow, and we'll assign it an arrow function. Pretty much the most basic thing. All this is going to do is return this. You could also console log this inside the function if you'd prefer. Either way is going to work fine. We'll just have to console log the output of this function rather than having the console log on the inside. The end result is the same thing, it's just where you want to do the console logging. Then what we're going to do is we're going to create a normal function, and all this will do is return this. So let's call this. We're going to say arrow, and we're going to say normal. Now this is where we're going to put the console log instead of on the inside of the function. And do you know what this is going to give us in the console? Hopefully you know. Hopefully you watched my video on this keyword, because I talked about all the different ways you can call functions and the values that's going to show up here. And it is, drumroll, the window object. And it's the same for both of these. Now the thing with this inside of an arrow function is that it never changes based on how you call the function, which is actually very nice because it makes the function much more predictable. When working with normal functions, either function declarations or expressions, we have to worry about how the function is invoked. And as a result, we cannot always be assured that the output of the function or what the function does is the same. So we have to consider how the function might be used in various different contexts. With arrow functions, all we have to do is think about what the value of this is when it's created, and we can be assured that no matter how the arrow function is used, it's always going to have that value of this. So to show you guys this, what we're going to do is we're going to create an object. We'll just call it functions, and what we're going to do is we're going to put both of these functions in here. So it'll look something like this. We'll create two properties. One will be the arrow function, and the other one will be the normal function. So this is another cool thing, is that the properties can have the same names as the function,
and that's totally fine. You don't want to put the parentheses because we're not invoking it here, we're just assigning it. So we can console log the functions object here and see what it gives us. You can see it's an object with two functions. We have the arrow function and the normal function. Now what we're going to do is we're going to invoke these as a method. And if you remember from this video, when you invoke a function as a method, the value of this is the object itself. So it should show up as this. That is if we're working with a normal function, but you'll see the arrow functions are a little bit different. Oh, so let's start with the normal one. We'll say functions, normal, like so. Do a refresh. I gotta output it, sorry. Now do a refresh, and look at that. We get the object itself, the functions object. But now let's do the arrow function. We're gonna do it up top. We're gonna say console log. We're gonna say functions.arrow. Now when we do a refresh, you can see it still shows up as the window object. So no matter how we call this arrow function, the value of this will always be the window object because that's what it was when we created the function. So we created this function here and the value of this was the window object. So no matter whether we called it like this or as a method, we still get the window object in both cases. Now, this can cause something very confusing. It's a gotcha that I'm going to have to call out in the next video. And I've fallen for this, and I'm sure you will too if you don't pay attention. So please be sure to check out the next video because we're gonna be talking about one thing you need to be aware of. Thank you guys for watching, and I'll see you in the next one. Hey, what's going on everybody? Welcome back to JavaScript tutorial series, and I am excited for this video, and I bet you guys, especially if you came from the previous video, are dying to know what we're gonna be talking about. So we're gonna be talking about a gotcha with the arrow function. Now it's not that the arrow function is doing something incorrectly, it just gives us a result we might not be expecting or might not be what we're used to. Alright, so let's just go over a quick review of what we talked about in the previous video, because we got a lot going on here, and if you're just jumping in, it might take a second to digest. Basically, we created a very simple function. All it does is return this. We did it for an arrow function, and then we did it for a normal function. And then we console logged the output. Looking at the output, we can see they both give us the window object. Then what we did is we created an object literal and attached those functions to this object and called the functions as methods. You can see that the arrow function, when called as a method, still gives us the window object. The normal function, on the other hand, gives us the object itself. And the point I was trying to make in the previous video is that the value for this, for arrow functions, does not change. It's permanent based on the value of this when the function is created. So when we created the function here, the value of this was the window object. And to confirm that, we can just console log this. Do a refresh, and you can see right there. Awesome. So what about when we create a function, specifically an arrow function, inside of an object? So we'll just do arrow test. And all this is going to do is the same thing. It's just going to return this. So I want you guys to predict what's going to be outputted. So we'll just say, functions.arrow test and invoke it. So what do you think will appear down here at the bottom? Drum roll, please. All right, time's up. Refresh. And look at that. It's the window object. Are you surprised? You may have expected, since the function is being created inside of an object, that the value of this would actually be the object instance, such as when we called this one here. But in fact, that's not the case. The value of this when this object literal was created is still the window object. Right here. And this is going to blend in, so I'm just going to put a couple of exclamation marks there. Do refresh, and look at this, still the window object. So when we call a normal function, such as down here on line 18, we get the object itself because we're calling the normal function as a method, and the value of this changes. But when we actually create this arrow method, the value of this is indeed the window object. So yeah, that's the gotcha. I know it's not that crazy, but basically you just need to be aware is that if you're using an arrow function as a method inside of some object, the value of this is not going to be that object. Now before I go, there's one other good thing I thought I would share with you. If you want to see what the value of this is inside of this object, all you gotta do is create a new property. So for example, you can say this, that works fine. And put a comma. Now when we output the object here, you will see, let me do a refresh, the value of this is indeed the window object. That's why when we get to this function, the creation of it, this is the window object. Thank you guys for watching. Hopefully that was helpful. Now in the next video, we're going to be talking about bind with arrow functions, and I think the result will surprise you. So be sure to check it out, and don't you dare forget to subscribe. All right, peace. Hey, what's up everyone? Welcome back to JavaScript tutorial series. This video, we're going to be talking about the arrow function in conjunction with the bind method. Now, I did a video specifically on bind just a couple videos ago, so you might want to check that out so you can get the context or the prerequisites or whatever. But basically, bind allows you to force a particular value of this, and it will return a new function that you can then call. All right, so what we have right now, we have this arrow function, and we're calling it. All it does is return this, and then we just console log that value, and we get the window object. Now you have to realize the whole point of arrow functions is to get the value of this from the parent context. So what is the value of this right here? That's right, the window object. So that's what the value of this is going to be for the function. Now this bind method is going to take a new value for this. So we'll just start with hello. And then what we need to do is we need to assign it to another variable because it's actually going to return a new function. So we'll just say let new func and assign it this. Then all we gotta do is call that and output the output. So we'll say new func and call it. Do a refresh and we still get window. So what in the world? We're binding this value to the value for this, but when this is returned, we still get window. And that's the thing. You cannot change the value of this for arrow functions. Even though we can call this bind method on it, it doesn't actually change the value of this. So if you need to explicitly state what the value of this should be, you need to use a normal function and then use the bind method. So in that situation, it might look like this. Function normal, return this. And then all we have to do is use the bind method on this function. And we're going to do a little bit of a shorthand here. So we're going to say normal.bind, pass in whatever we want. And that's going to return a function. So we can just call that function. And this entire thing will be outputted in a console log, like so. Do a refresh and you can see that we're able to change the value of this for that normal function. So when it comes to bind with arrow functions, not a thing. Again, if you need to be explicit about what this should be, use a normal function and then use bind and then use the return function whenever you need that value of this. If you're going to use it multiple times, you'll probably want to assign it to a variable like this, so then you can use it as so. But obviously not for an arrow function. All right, so enough rambling. That's all I got for this video. In the next video, we're going to start talking about a new topic. It'll be a lot of fun, so please be sure to check it out, and I'll see you then. Hey, what's going on everybody? Welcome back to JavaScript tutorial series. Let me tell you what, I am pumped for this video because we're getting into a new section and it's going to be a lot of fun. So we're going to start talking about debugging, and you don't want to skip this because it's an essential part of being a software developer. Alright, so I have this function here to calculate the factorial of something. And just as a refresher, if you don't know, the factorial will take a number and multiply it by every number lower than that. So if you pass in 5, it'll do 5 times 4 times 3 times 2 times 1. I think times 1, I guess it doesn't really matter. And the result should be 120. But as you can see here, we're getting 24. What in the world? I'm so terrible at this. How are we going to fix this? Well, the first instinct is to go in here and console log the total, like so. And then what you can do is you can do a refresh and you can see what's happening. And that might be helpful in a lot of circumstances. Honestly, that's what I do. That's what a ton of developers do. It's no secret that everybody logs information before and after a calculation. That's just what people do. But sometimes we want a little bit more substance when it comes to debugging. Now, we're specifically going to be debugging with the Google Chrome developer tools. Other browsers are probably exactly the same, but there might be a little variation. So if you want to be exact, you can get Chrome. There's also extensions you can get and all kinds of other ways to debug, such as with IDEs. I even think Visual Studio Code has an extension for JavaScript development debugging. But we're just going to start with the classic browser-based debugging, and that's what we're going to get used to first. So let's get rid of that console log. And what we're going to do is we're going to go to the Sources tab up here. And over on the left, we're going to go into the JavaScript folder and select our JavaScript file. Now what you can do is you can set a breakpoint, and that's going to pause the execution of the program, so it'll allow us to see the value of variables as we're going. So for example, we can put a breakpoint right here where that total would be calculated. Now when we refresh, it actually pauses at that point and tells us the value of the variables. So this is the very first iteration through the loop, and you can see x, the parameter here, the value passed in was 5, the total is 1, and x is still 5 here. Now what you can do is over here on the actual application window, which is really small right now, there's this little button here, resume script execution. That's going to continue the program until it hits another breakpoint. Press it, now we're on the second iteration, and you can see total is now 4. Press it again, total is 12. Press it again, we done. So let's do a refresh. And if you know how a factorial works, the first thing it's going to do is it's going to take 5 and multiply that by something. So we're starting with 1, so then when we multiply, we have a value. So the first time it should be 5. 1 times 5. So we're starting with a total, which is going to keep track of the result through these iterations. And it starts at 1 because we need to multiply by it and we need to retain that value. If we started with 0, we would just end up with 0. So the first time through it should be 5, but when we run it, we see 4. So the starting value is incorrect. We're multiplying by I, but I is 1 too low. There's 2 ways we can fix that. We can start the total at 5. When we change the value here, that doesn't actually persist into our code, so we'll want to do it over here. Now we can save and go back to the console and see what the result is. 120. So that's one way to fix it. So we're basically doing 5 times 4 times 3 times 2. The other way to fix this would be to actually start with 5 down here and have a total of 1. Either way, it's going to work exactly the same. Now do refresh, we get 120. That might be really easy to see by debugging this and going step by step, because we can go in here, now do a refresh, and you can see after the first iteration, the total is 5, as it should be. Now there is something as a conditional breakpoint, and to do that, you can right-click your breakpoint and click Edit Breakpoint, and now you can make some expression that will have to evaluate to true for this breakpoint to be hit. So for example, we can stop when total is greater than 5, press Enter. Now when we do a refresh, you can see it stops and total is 20. So it's stopping a couple more iterations in than what we were originally. So that's really useful if there's just one odd case out of tons of iterations where there's some kind of bug happening and you want to stop right then and check. All right, that's all I got for you guys in this video. That should be your introduction to debugging. Obviously there's a lot to it, a bunch of stuff down here and things. It's a little overwhelming, but we'll get through it. So thank you guys for watching. I'll see you in the next video. Hey, what's going on everybody? Welcome back to your JavaScript tutorial series. This video, we're going to continue our discussion on debugging, discuss something real quick to share with you guys before we move on to try-catch blocks, which we should be talking about in the next video. So we're going to be talking how you can set a breakpoint for a particular event. Alright, so here's the code we had from the previous video, and this is just some algorithm to calculate factorial. But a lot of times our JavaScript applications are going to be very event-driven. So someone clicks a button, someone drags over something, etc. So we might want to set a breakpoint to basically look at the state of our application when something like that happens. So first thing we're going to do, inside of index.html, we're going to create something. So let's go in the body, and what are we going to create? I don't know. Let's just create a paragraph, and we'll say hello. All right, now let's do a refresh over here. And we got hello. Now, if we want to listen for an event, such as a click, we can attach an event listener. So inside of JavaScript, what we can do is something like this. Document.getElementById. We'll talk about how to give it an ID in just a second. And then what we'll say is on click. All lowercase. All right, so let's give it an ID back in HTML. We can just say ID, give it some name, whatever you want to call it, like so. And we can reference that over here. All right, so we have this property on click, and what we can do is we can assign something to happen, so a function. It's actually easiest just to use an arrow function, so we'll just do that. Let's clean this up a little bit. Let's bring this down to the next line, and let's create an arrow function. And I'm just going to console log clicked. You can use the normal function if you prefer, it really doesn't matter. And semicolon at the end, do a refresh. Let's go back to the console. When we click this, look at that, it says clicked. All right, so the event is working correctly. Now let's talk about how to set a breakpoint for that particular event. Inside of sources, we go back to our source code, And then down here we have event listener breakpoints, and we have all of these different events. One of them which is mouse, and in here is click. Now I'm not sure if you have to do a refresh or not, but either way, when you click this, it's going to pause. So it realized we had a click event, and look, it stopped at the first line of code that happens when that click happens. So that is how you do event breakpoints, and you can see there's all kinds of different events you can do. So you can do mouse over and all kinds of other stuff. Let's do a mouse over just for fun. And what we're going to do is we'll just copy this, paste that, and what we'll do is we'll say on mouse over, and we'll change the console log to mouse over. Now let's do a refresh, and as soon as I hover over hello, look at that, it pauses. If I go around, go up from the bottom, it pauses. So that's pretty cool. So that is your introduction to event listener breakpoints. It's a great thing to do if you're having some issues with an event not working, or it's doing the wrong thing or something like that. Hopefully that was helpful. Now let's go into the next video where we're gonna talk about try catch and what are known as exceptions. So it should be pretty fun. I'll see you guys then, and be sure to subscribe. Hey, what's going on everybody? Welcome back to your JavaScript tutorial series. This video we're gonna be talking about exception handling using try and catch. Now I have here the Mozilla developer documents for JavaScript. This is a pretty good resource if you want to know all the details on try catch, but it's a little bit much. So we're just going to start with the basics, and if you want a little bit more, you can come here into this control flow and error handling document. So to basically describe the topic, error handling is obviously handling some error. Now whenever you can, you should prefer control flow over error handling. So for example, if you have some form and someone spells something wrong or puts some incorrect data, you can handle that using control flow, which as a reminder, control flow is just if statements, switches, loops, and so forth. Alternatively, you can throw an error and handle that error, which would be the error handling route. The preference is to use control flow, but you will see some people using error handling as if it's control flow, which isn't really recommended. Basically, you should only really use error handling for things that are exceptional, things you're not really entirely sure how to handle using if statements. The majority of the time though, you're not going to have to worry a whole lot about it because you can look for various cases using conditionals inside of if statements and basically catch any cases. But if we're in the situation where, your program's not even going to be able to continue or something really unexpected happened, well, in that situation, you might want to do a throw statement and use error handling. But let's just get into some code for this and stop blabbering about the documentation here. So let's just clean off what we had from the previous video if you're following along. We'll start fresh, do a refresh here, and we're back to nothing. Go to the console. And here's what I want to do. I want to execute a statement that doesn't exist, such as this. When we do a refresh, look at this. We get an error. So this here is also known as an exception. You may also hear this as a runtime error because it happens when you're running the program. Now, how do you deal with something like this? You can wrap it in what's known as a try block. So it looks like this. Put try and then curly braces like so. Now we can't just have the try here. We also have to have a catch, something like this. And then there is also a finally, which will look like so. Catch will catch the exception, so if something goes wrong, and finally will execute some code no matter what. So whether there's an error or not, finally is going to execute. Just to show you guys this, we'll do a console log, and we'll put test, do a refresh, look, it says test. If there's no error, do a refresh, we still have test. We can even get rid of the catch section, as long as we have a finally section. You can see in this situation, it still works. Do a refresh with that error there, and you can see we still get test as the output. So it attempts to execute this, doesn't work, goes to the finally, console logs this, and there's no point in the future where this thing is caught, so it says uncaught reference error. So what we'll do is we will add a catch section here, and we'll just put a console log. Now when we do a refresh, we get catch and then test. Now you can actually have an argument to catch and you can give it a name. We'll just call it E, and this is going to be the information about the exception. So what we can do is we can just console log E, do a refresh, and look at that. Here is the error that we got. So to sum up what I was saying, anything inside of the catch will only execute if there is an exception, such as this. Finally, will execute either way. Anything after the entire try is not guaranteed to execute. So for example, if we do a console log here and just say after, and we get rid of this catch, when I do a refresh, you can see we get that error and nothing after is executed. So putting the important stuff in the finally is a way to guarantee that it gets executed. Now you can also throw your own exceptions of various types. So let's just do that. So let's clean this out. And what we're gonna do is we're gonna create a function. And in here, we're just going to throw an object, and it's going to have a property error with the value tis broke. And it's going to have a code, and we'll just give it the value -1. All right, awesome. Now what we can do is we could say try, and inside of here we can call do something, and then we can have a catch E. We can console log the E and just say error. And then we can say finally, and here we'll just say, I don't know, whatever you want, like so. Now when we do a refresh, look at that. We get an error, and then it says wrapping things up. So if something terrible happens that we can't easily recover from, we have the option of throwing an error and ultimately having it caught by a try catch block, or just having an uncaught error exception. In that situation, it's gonna look something like this. Do something, and we'll just get rid of all this. Here we'll just get an error like so, uncaught. Now another thing you can do is you can actually say throw new error. And you see we have error in capital letters here. So this is a special constructor that's going to create an error for us. There are all kinds of different error objects we can use by calling various constructors, which is found inside of this documentation that I showed you earlier. So inside of the exception handling statements, we can go into ECMAScript exceptions. And look at all these. The one we just created is the generic error constructor, but here are all kinds of different variations. So if you want to basically build off of something that's already been defined, you can use these constructors to your benefit. Now there's also something known as DOM exceptions, D-O-M exceptions. These can be thrown when doing various DOM work, which we'll be getting into soon, but you can see those in the documentation by going back and going to DOM exception. Now this is just one constructor, DOM exception, but it has a name property, and then there's a bunch of different names that are available to us. So here's how we would describe the error. So that's all I have to say about exceptions. Again, I just wanted to emphasize that exceptions are used for exceptional things. They're not really meant to be used all of the time instead of using if statements. When you throw an exception, it's like saying, oh crap, that's something we were hoping didn't happen. Yeah, it just happened. So that's how you should use exceptions. Alright, so that's all I got for you guys in this video. In the next video, we're going to start talking about object-oriented JavaScript. It's going to be a whole lot of fun. I'm pretty excited for that. So please be sure to subscribe, and I'll see you guys then.
Hey, what's going on everybody? Welcome back to your JavaScript tutorial series. Now we're going to be talking about the disaster in JavaScript that people like to call object-oriented programming. Now if you're coming from another language and you're like an object-oriented pro, prepare to have your brain tickled and your booty slapped, because it's nothing like these other languages. Now it's kind of similar, but there's some like key differences that if you don't understand, you will die. So pay attention. The next section in this series is going to be a whole lot of fun. Slightly agonizing if you're sort of already object-oriented up here in different languages. But if you're fresh, consider yourself lucky because you don't have to unlearn stuff and learn stuff in a different way. So yeah, this is the one scenario where knowing less might actually benefit you. So stay focused though. It's still going to be brain tickling. So we've worked with objects in this series, and we've even worked with constructors, and that's what we're going to be doing in these upcoming videos. But let's just make sure we're all on the same page and discuss what an object is. An object will describe some entity. So it could be a person, it could be a car, it could be a request, it could be whatever it is. It could be things. So let's say this is an object that describes me. We might have a name of Caleb, an attribute of smoking hot, and his favorite food, of course, is the one and only pizza. Alright, so this describes me. Now we might have another object that describes you. So maybe your name is Pablo, and you're super nerdy, and you like cheese. And you might be doing this for everybody. Maybe you're trying to make an application that describes people, and you're gonna have like tons of people. Well, you don't wanna have to make all these objects from scratch every time. So instead, we use what's known as a constructor function. And consider the constructor function a thing that takes information as input and gives you a new object. So basically we could use this constructor function to build me and you. Now as you get deeper into JavaScript, you're going to learn about classes. Now in JavaScript, there's no real difference between classes and constructor functions when it comes to functionality and the way they're used. They are different when it comes to syntax and how you actually make them. But once you understand the basis, the constructor function, picking up classes is a piece of cake. So if you're in React and you're working with classes, don't worry, because you can pick it up super easy once you understand this junk. Now if you're coming from C# or Java or C++, classes is basically the equivalent to the constructor function in JavaScript. So let's talk a little bit about this constructor function. It's going to be just a normal function, and it's going to use this, which we talked about. When you use this inside of a constructor function, it refers to the new object you are creating. Now, the constructor function is not going to have a return. So you're not going to return a new object. Instead, you're going to invoke this function in a special way by prefixing it with new. So for example, this might be a function called person, and we might call it by saying new person. And then we would assign that to a variable. Now there's a similar way of doing this known as a factory function. In that situation, you create a function, and inside that function you create a new object and you return that object. So it's a very similar thing. It's a way to do similar stuff, but I would recommend you stick with constructor functions. You might just want to know that the factory function concept exists. So what we're going to be doing now is in the next video, we're going to create a constructor function and learn the syntax on how to do that. It's going to be a lot of fun, and we're going to get into some deep stuff. So put your big boy pants on, buckle up, and let's get started. Peace out.
Hey, what's going on everybody? Welcome back. This video, we're going to be talking about how to create a constructor inside of JavaScript. Now, this is a fundamental piece of object-oriented programming inside of JavaScript. Even if you're starting to work with classes in JavaScript, the constructor is really the basis for it all. Classes are just a syntactical sugar that makes it a little bit easier and a little bit more what people are used to from other programming languages. So this video is going to be very simple. All we're going to do is we're going to create a constructor to create users. So when you create a constructor, by convention, you use a capital letter. So it'll look something like this: function user with a capital U. And then when we want to create a new user, all we have to do is create a variable and say new user, like so. And then what we'll do is we'll just console log and output this new object we created called me. So let's do a refresh. Right now we have an empty object, which makes sense because we're not actually giving it any properties. So inside of JavaScript, when you call a function as a constructor, like we're doing here, so if you prefix it with the new keyword, then inside of the function, the keyword this refers to that new object we're creating. So what we can do is we can console log this, and we can watch as it's getting created. So when we first start, it's going to be empty. So we have this empty object. Then what we can do is we can assign properties to this object by saying this dot and creating a property such as name, and we'll just give it Caleb as an example, but this isn't a really good example because that means everybody who's created is going to have the name Caleb. So I'll show you guys how to customize it for person to person, but for now we'll just start with Caleb, do a refresh, and now once we're done down here, this person has the name Caleb. So we'll do a console log this here again and see that the second time around we have a property on this object. So we can use this to our advantage by attaching properties to it, and that's how we basically define the structure for any new objects we're creating with this constructor. So how do we change the name from person to person? Well, we can actually take it in as an argument. So we need to create a parameter here. We'll just call it name, and then what we'll do is we'll just assign that value here. Now when we call the function, we need to pass in a name such as Caleb. Now this should do the same exact thing, refresh, and there you go. Cool, so what I'm going to do is I'm going to get rid of these console logs, just so it's a little cleaner, and I'm going to create a couple objects. So we'll create you, and I don't know what your name is. We'll go with Camila, and
we're going to console log me, and we're going to console log you. Now in this situation, I have the name Caleb and you have the name Camila. So we've parameterized this constructor to make it customizable for individual people. As another example, let's create an interest parameter and we'll assign that to the object as well. This .interest, and we'll assign it the value interest. So we'll pass in an array here, and this is where we'll put the interest. We'll say cooking, eating, and exercise. Now one of these is a lie. Can you guess which one? Haha, you guys probably thought it was this one, but it's actually this one. Tricked you. Yeah, I'm not a huge cooker. I could probably burn water. I used to try to do a reality YouTube TV show called Caleb Cooks, but it didn't go so well, so I just privatized that and moved on to bigger, better things. All right, Camila, let's say you're interested in Hot Wheels. Awesome. Now when we do a refresh, look at this. We got interest, which is an array, and 3 elements, cooking, eating, and exercise. And you, on the other hand, interest, Hot Wheels. You can also modify the object after the constructor. So for example, we could say me.membership and set it to gold as an example. And we can console log me and see that that is added to my object. Now you do have the option to add methods in here. So you can say this dot print info or whatever you want, but it's not always recommended to put methods in the constructor function. And we're going to talk about that as we get in a little bit more depth with object-oriented programming. Basically, that's going to copy the method for every single object. It's not always what we want to do. I'm just going to adjust this screen a little bit and make it a little easier to see. That's all I got to say for you guys in this video. Now, here's what we're going to do. In the next video, we're going to talk about something called factory functions. Similar to this, but different. You'll notice here that we do not have a return. And that's one of the key differences between a constructor and a factory function. Then after that video, we're going to come back to methods when it comes to constructors, because the way you want to do it is a little bit different than you might expect. Like I said, you can go in here and put methods, but I'm going to be teaching you guys the recommended way, which is a little bit different. So thank you guys for watching. Hopefully this video changed your life forever. And don't forget to subscribe, and I'll see you guys in the next video. Peace out. Hey, what's crack-a-lackin' everybody? This video, we're going to be talking about factory functions. Now, I do recommend you check out the previous video, which is on constructors, because factory functions are very similar, and they are pretty much going to give you the same result. All right, so taking a look at this constructor, we are using this to create new users, specifically me and you. Now, what we're going to do is we're going to create a similar thing to this, but it's going to be defined as a factory function, and it's going to look a little something like this. We'll just give it a new name called new user just to distinguish the two. And this is also going to take a name and interests. So pretty much the same thing so far. But instead of saying this dot something, what we're going to do is we're actually going to create a new object. So for example, we can say let person and just create it as an empty object literal. Now inside of this object literal is where we can assign the name and the interest. So it might look like this. Name is going to be name. So this is the property name, and there's a lot of names going on here. So this is the property name, which is named name, and the value is the name parameter. Next we have the interest, which is going to be the interest parameter. So it's smart enough to know that the left side is the property name, and the right side comes from the parameters. So even though they have the same name, it's totally fine. Then all we do is say return person. Now as for actually using this function, you don't prefix it with the new keyword. Instead, you just use the function name by itself as you would any other function. So what we'll do is we'll get rid of the new keyword. We're going to create you using the factory function, and we'll just call the function name, which is new user. Now it does have the word new, but it doesn't have to have that. You could name it whatever you wanted. You could name it Taco Bell if you wanted. We're gonna pass in the same stuff. Make sure we save and do a refresh. And taking a look at our people here, we have me and we have you. You still have a name and an interest, and everything is pretty much the same. So of the two techniques, this is recommended. The constructor is recommended, but you will probably run into factory functions and hear about them in future JavaScript work. So it is important to understand how they work. Overall, it's pretty simple. In fact, it's more similar to how you would normally use a function, whereas the constructor is a little bit different. So it's actually pretty easy to remember. Please be sure to subscribe and go check out the next video. That is, if you have a soul. Hello, my children. Welcome back to your JavaScript tutorial series. This video, we are going to get a taste of inheritance. The next video is going to talk about it officially, but I just wanted to give you a little sneak peek. And basically, I'm going to teach us how to do something. You might not necessarily understand all of the whys, but by the end of the series, you'll have it down. So what exactly are we going to be talking about? We're going to be talking about the proper way to give objects methods when it comes to using constructors. All right, so first let's talk about the first way you would think to create a method on all the instances of this user constructor. So you would probably go in here and say this dot output stuff and assign it a function. And inside of this function, you might just do a console log and put some stuff out on the screen. So you might do the name and the that's not what I wanted, in interest. We're going to prefix this with the this keyword, and let's give it a try. What we're going to do is we're going to go down here and say me.output stuff. Do a refresh, and you can see we get that information down here. It says Caleb, and it has the interests. We can customize this, such as so. Do a refresh. My name is Caleb. That's a little better. And this works, obviously, because we just did it. And you should have a similar thing. So you should say you.output stuff. And refresh. And look at that. You got the same thing. Now, the problem here is actually not really a problem if you're working with really simple applications like we are here. Now, if you're going to scale to very large applications, the problem is that every time we create a new user, we're creating a copy of this method. Well, as you might know, methods can become very large and we can create lots of objects. So we're basically wasting memory. The fix for this is to put this method on the parent object for these users. And how exactly do we do that? Well, outside of this constructor, what we're going to do is we're going to say user with the capital U, so to refer to this constructor, and say user.prototype.output stuff. And that's actually a terrible name, so I'm just going to call it greet. And we're going to assign a function to this, put a semicolon at the end there, and we can do the console log in here. And what we'll do is basically just say the same thing, like so. Now what we can do is we can call that function greet and do a refresh. And look, it works exactly the same way. Now this is off topic, but you also have the option of just returning some value and then console logging it down here. That doesn't really have anything to do with inheritance, but it's just a side note. There's always question of whether you should console log inside of the method or if you should do it on the outside. It's generally preferred to do it on the outside, but this is simpler. But this function is limited because all we can do is console log. If we wanted to take that value and put it in as an argument somewhere else, then this method's not going to work so well. But enough blabbering, back to the point. Basically, this is going to be one method that all of the objects are going to have access to. So I have access to it, you have access to it, but there's only one method actually created. That means we can replace this with this new and improved method and save on our memory. Cool. So taking a look at our objects, you can expand them, go to the prototype, and see this greet function right here. Cool, so that's just a little taste of inheritance. Now we're going to talk about it officially in the next video. Thanks for watching, and yeah, be sure to subscribe.
Hey, what's up everybody? Welcome back to your JavaScript series. I was having a really bad hair day today, so I was just like, forget about it. I'm just gonna mess it all up. So, apologies if it's distracting, but gotta do what you gotta do. So, when we're talking about object-oriented programming, one of the key pieces is known as inheritance. And basically, this allows one object to take parts of another object and inherit them as their own. This is done in JavaScript by what's known as a prototype. So a prototype is just an object that another object inherits from. One way to save memory is people will put methods for a constructor on the prototype. That's because that prototype is going to be given to that new object that's being created with a constructor, and having only one object that numerous objects reference as their prototype is going to prevent the duplication of a method over and over and over again in each object. So if you need some visualization for that, think of it like this. Let's say we have two objects, we have one here, and both of these contain a method, so some function that's a property on these objects. Well, if these methods are exactly the same, we have a duplicate. Wouldn't it be better if these could kind of share the method in a different place? Well, that's what the prototype does. So up here, we can have a prototype object, and here we can put the method. So something like that. Then instead of putting them both down here, we can just have it in one place. Then if you call this method on this object, for example, it's going to be searched for the method, realize it's not there, and it'll look up one layer into the prototype and find it. It's not always just one prototype, because the prototype can also have a prototype. So you can have this chain. It might look like this. So this object inherits from this one, which inherits from this one, and then eventually it's going to be null, which means there's no more prototype. So this would be the root object because there's no more prototype. When looking for a particular property, it's going to search this object first, then this one, and then once null is reached, if that happens, it's going to be returned as undefined. Now there is a default prototype that things are going to inherit from. It's called object.prototype. When we create a new object, it's going to ultimately inherit from object.prototype, and as a result, certain things are going to be made available to this object by default. So for example, the toString method. This method comes from object.prototype. So we're going to talk a little bit more about this in the next video, so you'll want to subscribe, you'll want to go check that video out. And yeah, I'll see you guys then. Hey, what's going on everybody? Welcome back to your JavaScript series. Today we're going to be talking about inheritance a little bit more when it comes to constructors. Let's go through an example where we use an object literal. So I might do something like this. So we're creating this object and we're just using the curly braces to create an object on the spot. This is known as an object literal, but when we're doing this, it's essentially the same thing as calling the object constructor, which would look like this. Basically, you say new, and then you invoke this function called object with a capital O. Now when we create a method, it has a prototype. So in the previous video, we talked about object.prototype. Now we get a little bit more context and understand where this comes from. We have this constructor called object with a capital O, and this constructor is going to have a prototype, which is accessible through this prototype property of the constructor. Now, why is this important? Well, when we create a new object using a constructor, the prototype is transferred to that new object. So for example, if we say let x and assign it new object to this call to this constructor, this prototype is going to be transferred to the prototype of this new object. In this case, it's called x. Now, I don't think you'll access it the same way, being x.prototype. Rather, you would access it using object.getPrototype of, and pass it in parentheses. So it would look like, where do I write this? So if you did object.getPrototype of x triple equals object.prototype, you will get true. So what we can do is we can basically define an inheritance hierarchy by strategically using prototypes to pass on information to the children. So anything that's part of this object.prototype is automatically passed on to anything created using this constructor, in this case x. We can do that same thing with our own custom constructors, and that's what we'll be doing in this series. So hopefully that was helpful for you guys. In the next video, I'm not sure what we're going to be talking about, but as always, it's going to be the greatest video on all of the internet. It will probably go viral, so you'll want to definitely check that out before everyone else does, and it's old news. So thank you guys. Please be sure to subscribe, and I'll see you in the next one.
Hey yo, welcome back everybody. This video we're going to be talking about prototypes and how to manually set the prototype for an object. Now if that sounds like a bunch of mumbo jumbo garbage, then you probably need to go back, watch the previous videos, and get a little bit of that pre-knowledge stuff. Alright, so here's what we're going to do. We're going to use an object literal called user, and what we're going to do is we're going to say whether this user is active. So maybe that means they've signed in recently or their email is activated. Let's go with the email option. So you confirm your email and you become active. And let's say we're creating an application where teachers can sign up and students can sign up and they can create courses and take courses. And now what we're going to do is we're going to create a teacher. It's going to look a little something like this. And inside this teacher, we're going to say what this person is teaching. It's going to be an array, and we'll just say this person is teaching math and science. You know, you can get a little bit more specific if you want to put course names or whatever, but this is good enough for me. And here's what we can do. We can say object, capital O, dot set prototype of, and the first thing we're going to put in here is the object to change its prototype. So we'll say teacher, comma, and then the value of the new prototype or null. So we'll go with user. So we're setting the prototype of teacher to be user. Now what I want to do is I want to console log the teacher. Do a refresh, taking a look at this object, we can expand it, and you can see this underscore proto. It's an object, and look at that, we have this active here. So what that means is we can say console log teacher dot active. When we get a refresh, we'll get true. So even though we didn't say an active was on this teacher, it still outputs true. So basically what's going on is we're making this user object be inherited from when we create this teacher object and set its prototype to be that user. Then what we can do is we can go on and create a student and inherit from user as well. And then we can differentiate from teachers and users and all that cool stuff. But this is the basis. How to set the prototype of an object, you do it like so. Now what I want to do is I want to output teacher again, do a refresh, take a look in here and expand all the prototypes. So you can see the first prototype, that's going to come from here. Then this next prototype is just object, which is basically the root of the inheritance chain. So that's your introduction to manually setting the prototype for an object. Hopefully that was helpful, and I'm sure this will come up in the future, so make sure you got this stuck in your brain. Right now we're just working with object literals, but eventually we'll talk about how to do this with constructors and so forth. So thank you guys, subscribe, and I'll see you in the next one. Yo, what's up everyone? Welcome back to your JavaScript tutorial series. This video, we're gonna be talking about how to overwrite a particular value in the prototype of an object. So to basically translate that into code, let's just go through an example. So here's what we're going to do. We are going to create a student object. And what this is going to have is a major. And we'll just say this person is an English major. Like so. And we're also going to set the prototype. So we'll say object.setPrototype of, and then we'll say student, and we want the prototype to be the user. So this is going to inherit the active being true. So right now we have a teacher that is active true and a student that is active true. So what we can do is say teacher.active, and then we can also say student.active, and these should both be true. True, true. And what I want to do is now overwrite this value inside of the student. So to do that, what we can do is say student.active and set it to false. Now, what is going to happen here? Because if you think about it, both the student and the teacher share this value. So if we set it to false, is it going to show up as false for just the student, or is it going to show up as false for both the student and the teacher? Let's find out. So I'm just going to put some text here just so it's a little bit easier to read. Now let's do a refresh, and you can see the teacher remains true and the student becomes false. Why is this? Well, it all has to do with how the properties are found. So when you say student.active, the very first thing it's going to do is it's going to look on this object to see if it exists. So when you say student.active, such as in right here, the very first thing it's going to do is it's going to look on that student to see if it exists. When we assign it a value, it's going to put that value on that object. So if we get rid of the .actives and just look at the objects themselves, you'll see what I mean. Do a refresh, the teacher and the student, you can see the active false is directly on the student rather than on the prototype, which is down here. So in a way, we're just masking over this value that's in the prototype. When we ask for teacher.active, it first looks on the teacher object, doesn't find it, so then it goes to the prototype, and then it finds it. In theory, if this did not exist, it would look in the prototype again, and then there wouldn't be any more prototypes, so it would be undefined. As an example, we could just print teacher.tacos, do a refresh, and look at that, teacher undefined. The teacher's not undefined, the teacher.tacos is undefined. The text teacher comes from right here. So the key takeaways, when you're asking for a particular property, it first looks on the object. If it's not found, it goes to the prototype, and it will continue up that chain until there's no more prototypes. When you set a value, it's going to set it directly on the object. So in this situation, the false is going to be shown when we ask for student.active. So in the next video, we're going to talk about instance properties versus prototype properties, when you should use which, and some other stuff like that. So thank you guys for watching. Hopefully this was helpful, and hopefully you now understand how you can override a value for a particular object when you want to cover up what the prototype value is. Be sure to subscribe, and I'll see you in the next one. Yo, what's up everyone? This video, we're going to be talking about some of the best practices when it comes to instance properties and prototype properties. So in the previous video, we talked about how you can overwrite a prototype property by setting that same property directly on the object. In this situation, the student inherits from the user, and the user has active true, but we overrode that by setting a student.active to false. In the object structure, you can see that directly right here, and then on the prototype, you can see active true here. When looking for this property to see what the value is, it'll first look at the object, and if it doesn't exist, it'll look at the prototype. But since it doesn't exist, we'll get the value false. So now I want to talk about when you should use properties on the prototype and when you should put them directly on the object. So the main reason you would want to create a prototype object is when you have multiple objects that are similar in nature but might have some minor differences between them. So for example, students are very similar to teachers, but they're not the same exact thing. You know, students and teachers, they're both humanoids. They both might have a name. They both might have a birth date, a place of living. They both might be active or inactive, such as here the default is active true. But there are some key differences. For example, a student will have a major if we're talking about some kind of school system, or if we're talking about an online learning platform, the student might have a particular track they're following or something like that. Teachers, on the other hand, teach. They have classes they're teaching. So the things that are shared between the student and the teacher can go on the prototype, in this case, user. That's because when we set these prototypes, they're both going to have that value, such as active. So one thing that's weird about the way we have it set up right now is that both the teacher and the student have active true. Right now we're just working with single object literals, but once we get into constructors and creating lots of objects, it doesn't really make sense just to make everybody active true. When something is likely to change between object to object, it would make more sense to have that directly inside of the object. So basically you could take this active true and you could put it inside of the student and you could put it inside of the teacher and put the appropriate value. So if that's the case, if you can do it that way, why exactly did we do the prototype and put it in this own object over here?
Well, what I was thinking is that if the majority of objects have active true, you can have it as the default. Or if you want it to default to false, you could set this to false and then only set it to true on the exceptions. So for example, let's say the student activates their email address, we can say student.active is true. So everyone is false unless otherwise stated directly in the object at this level, not in the prototype. So doing a refresh, you can see it's true when we get student.active. I'm going to switch this tacos back to active. There we go. So what we could do is we could add more to the prototype object. For example, we could create a method. We will call it say hello, and this will be a function. What we will do is we will just return this dot name plus says hi. Where does this dot name come from? Well, that's something we would put directly on the objects. So we can give the teacher a name down here. We'll say name. We'll make it Caleb Curry because I'm teaching. And then we'll give you an appropriate name as well. Name, oh, I don't know. Peasant student maybe. Perfect. What we can do is we can say teacher.sayHello. Call that method. And we'll do the same for the student. There we go. Do a refresh. And look at that. Caleb Curry says hi. Peasant student says hi. And I need to throw a space in there. So when this method is invoked on the teacher, the very first place it looks for the value of name is directly on that object, which is where it gets it. And then if it's not found there, it's going to look on the prototype. And then if it's not there, it'll look at the next prototype and so forth until it's undefined once we run out of prototypes. We put say hello inside of the user because you can think of it as core functionality for the objects that are going to inherit from it. It doesn't make sense to put the same exact function inside of both of the object literals. Any common functionality we can put inside of a prototype to keep things more organized. Then if we want to update the greeting, we can do that here. Now, if you want to use a special greeting, that's something you can override in a particular object, like we talked about how we overrid the active being false. So that's all I got for the basics of prototypes and inheritance. What we're going to be doing now is in the next video, we're going to talk about polymorphism, which is another big piece of object-oriented programming. And it really deals with how we can view objects as different types based on the prototype chain. So for example, we can treat a student as a student,
or we can treat the student as a user. We can treat both the students and the teachers as a user. But we'll get into all the juicy details in the next one. So thank you guys for watching, and I'll see you then.
Yo, what is up everybody? In this video, we're gonna be talking about polymorphism. Should be pretty fun, so be sure to subscribe if you enjoy. Gosh, where am I going? Be sure to subscribe if you enjoy this content, and let's get started. All right, so inheritance, we've talked about it in this series. Basically, an object can have access to properties on the prototype. So for example, we could have teachers and students, and these can both inherit from user if we're creating a website, for example. Now, inheritance works similar in real life, right? So in the Curry family, I grab traits from people higher up in the hierarchy, like parents, grandparents, and so forth. So I'll probably go bald, etc. Kidding, Dad. So when people look at me, they can say, oh, it's Caleb, or they can say, oh, it's that Curry kid. So I can be treated as myself, or I can kind of be treated as part of this inheritance hierarchy. And this is a terrible way of explaining this, so I'm just gonna try to give you guys a different point of view. When we're talking about JavaScript, an object can be treated as the type of whatever it is, or it can be treated as the type of its parent, or its parent's parent. So if we have a student, we could also consider this student to be a user, which makes sense. Both students and teachers are users, at least in our inheritance hierarchy for this particular application. So inside of JavaScript, we'll often have a collection of similar items. So think of an array of users. So we might say let users, and we might assign an array to this with some objects inside of it, or we might push objects onto this array. But essentially, this array is going to be used just for users, which can include students or teachers. And that's totally fine in JavaScript. In fact, JavaScript doesn't really care. You can put whatever you wanted in this array. There's no concept of a typed array, which would be nice. So inside of Java, for example, there's the array list. In C#, I think it's just called the list. These are generic types where you can basically say, I only want to allow users, or I only want to allow students or teachers. Now, although we can't do this exact same thing inside of JavaScript, it's still very common for our lists to contain a similar type, such as all users. So this stuff is still important inside of JavaScript. Now, the beautiful thing with polymorphism is that you can treat numerous different types as if they are one type. So we can treat the students and the teacher both as users. Why is that important? Well, because we can tell these users to do something, and because we can override certain methods inside of the children, then we can just expect them to do the appropriate thing. So for example, let's say we have a method and it's called work. And we have a list of users, so both the students can work and the teachers can work. Maybe the students will study, maybe the teachers will teach or do research or whatever those professor people do. And using our collection of users, we can just say, yo, everybody in this collection, you guys need to start working. And the students will do the appropriate thing, and the teachers will do the appropriate thing. So that's one example of how polymorphism can be useful, but there's lots of other cases you're going to find inside of the object-oriented paradigm. So be sure to understand these concepts, and check out the next video because we're going to go through an example of this on the computer. All right, thanks guys, peace out, and be sure to subscribe, yeah.
Hey, what's going on everybody? This video we're going to be going over a polymorphism example based off of what we have here. We have a student and we have a teacher, and both of these have the user set as their prototype. So if you need a little bit more background on polymorphism, check out the previous video. So what we're going to do to illustrate polymorphism is I'm going to get rid of these console logs, and I'm going to create a new collection of similar items. In this case, it's going to be called new members, and it's going to be an array. And we can put the objects in here like so: teacher, student. And the whole idea is we can go through this array treating the teacher and the student as if they are the same type, specifically type user. And then if there's some kind of variation between the student and the teacher, the appropriate thing will happen. So for example, you can look at all the users and say, go to work. The students go study, and the teachers start teaching. For now, what we're going to do is we're just going to iterate through these members. So we'll say new members for each, and this is going to take a function. So we'll say function E, which is the element, And the function body, what we're going to do is we're just going to console log. So the first time around, it's going to be the teacher. And what do we want to console log? Let's just console log the say hello, which should be available to the teacher because it's in the prototype. So we'll say e.sayHello, like so. Next iteration, it'll be the student, and that should also work because the user is the prototype for that as well. So let's save, refresh. Caleb Curry says hi, peasant student says hi. So this is pretty cool and it seems to work, but it's not too crazy. So what we're going to do is we're going to mix it up just a little bit by overriding this method inside of one of these objects here. So let's go with the teacher and we'll just put that down here. So I'm just going to copy it to begin with and paste it here. But now instead of saying hi, what I'm going to do is I'm just going to say what the teacher is teaching. So we'll say teaches, put a space there, and then we'll do a loop. This dot teaching dot for each, and throw in a function here. And then what we're going to do is rather than just returning this here, we're basically going to build out a message. So we'll get rid of the return and we'll say let message and we'll assign it this value. And then once we're done, we can just return the message. That allows us to append data to this. So we can go in here and say message plus equals, which will append to it. And we'll just put the element, which will be the class they're teaching, and then a space. All right, let's do a refresh. There we go. Caleb Curry teaches math science. And then yours is still doing the original, which comes from the user. So you could put a custom one for the student, maybe saying, hi, my name's peasant student and I am majoring in English, or whatever you wanted it to be. Basically, we made a collection and we go through this collection and it'll do the appropriate version of whatever we're trying to do based on what object the current iteration is on. So the first iteration, it's a teacher, so it does the teacher version. The second iteration, it's the student, and it does the student version. Well, in this situation, the student doesn't have anything, so it goes to the prototype and does the default user version. So that's an example of polymorphism essentially inside of JavaScript. Hopefully that was helpful for you guys, and please be sure to check out the next video because we're going to be talking about prototypes of functions. So that'll be pretty cool.
Hey, what's going on everybody? Welcome back to your JavaScript tutorial series. This video, we're going to be talking about prototypes of a function. Now, this is an essential ingredient to understanding constructors, so you need to pay attention. It can be a little bit confusing, but I'm going to try and make it real simple. All right, so here we have some code from previous videos. We're going to reference back to that in the future, but for now, we're not going to use that. We're actually going to go outside of these curly braces so I can just collapse this. What we're going to do is we're just going to create a function. And if you're wondering why we're doing this outside of the curly braces, is because I want to explore it inside of this console over here. So we're just going to create a function, and all we're going to do is just literally nothing. We're just going to return, I don't even know why I put that, but that's what we're going to do. Now what I want to show you guys over here is when you say do something, that'll give you the function, but what you can do is you can look at the prototype by going to do something.prototype. What this prototype is an object indicated by the curly braces, and it has a property called constructor, and this constructor is a function, which is in fact the function we created. So we have this weird loop going on, and I want you to really pay attention to this because it's confusing. Basically, we create this do something function. This has a prototype, which is what it inherits from, which is an object, and this object has a constructor property, which is what brought it into existence, and this constructor points back to the function. So if you want to see this loop, first thing we do is we look at the function prototype, which in fact is an object which has a property constructor. So when you expand this, you can see that here. This constructor property contains that function. So when we expand it, this is everything about the function. One of the things is this prototype property, which brings us back to where we started. So here we have the constructor property, which is the function, and so forth. You can keep going forever just by expanding these and expanding these and expanding these for eternity. So this is weird, and why is this even important? Well, it's important when we're trying to understand how calling a function as a constructor works when it comes to inheritance. When we call a function as a constructor, the prototype of this function is transferred to the new object as its prototype. So what we're going to do is we're going to clear this console out, get rid of these comments here, and just to show you guys, we're going to call this function as a constructor. So we'll just say test, and we'll say new do something. You can ignore the return in this situation. It's not going to be used because we're using the new keyword. Do a refresh here, and when we say test, we have this object. It's an empty object.
But if we expand it, we have this prototype. Now this prototype is the same prototype as the prototype of this function. So expanding it, look at this. It's the same object that has the constructor property. Comparing this to do something.prototype, you can see, look at this. Same exact thing. If you want to see this programmatically, you can do something like this. If do something.prototype is equal to object.getPrototype of and pass in test. And then inside of this conditional, we can just say console log match. When we do a refresh here, we get match. Now, if you want, you can look up the difference between these two ways of doing things, but basically, do something is going to have that prototype property, whereas test is not, so we have to do it a little bit differently. So let's go through an example of how this applies to us when we're working with constructors. Let's go back from the beginning and say we create a taco constructor to make lots of tacos. And in here, we're gonna say this toppings and set that equal to, let's do an array. And we'll start with cheese. And this is going to be on every single taco. Now, when we do something like taco.prototype.make and set this equal to a function, we're setting this function onto the prototype of the taco function. So just for fun, we'll just console log making a taco. And then we'll create an instance of this by saying something like let my taco equals new taco. All right. So what exactly is happening here? Well, if we refresh over here and we take a look at taco, the function, and then say .prototype, this is going to have two properties, make, which is the function we created, and then constructor, which points back to the original function. When we explore my taco, expanding this, we can see we have this __ proto. This is where we can see the prototype object, and you can see it's the same exact thing as up here. So the way constructors work is they transfer the prototype of the function to each of the objects that are created. So this here is the prototype of the function. We create an instance using this function, and that's transferred down here to the instance. Each object created from this constructor is going to share that single object. So when we go down here and we create a new taco, these are both going to have the same prototype object. This saves memory, which is why we often attach the functions to the prototype. So, conclusion, it's basically a really long video to explain what you probably already understood, but hopefully this video just gives you a little bit more details about how functions have prototypes, and those are transferred to any instances created when we call that function as a constructor, such as here. So yeah, a little complicated, but if you want that extra information, there you go. Now in the next video, we're going to be talking about something that's probably going to come up a lot and it's very useful, so you'll want to check it out. Thanks guys, and I'll see you in the next video, and be sure to subscribe! Hey, what's going on everyone? Welcome to your JavaScript tutorial series. This video, we're going to be talking about how to check if a property exists inside of an object. Now this is actually a very simple process. Basically what we're going to do is go down here in the bottom, and this is the code we've been writing throughout this series. You can copy it and get it up to speed if you don't have it, but it's not a huge deal. What we're going to do is we're going to go down here, and we're just going to do a console log, and we'll say name in teacher. So we're going to check if the teacher object here has a name property, which we know it does, but this is how you can programmatically check that. Then we'll just put a comma, and what you're going to do is you're going to put the property in quotes. So we'll say name, and then you say in, and then the object name, teacher, like so. Do a refresh, and look at this, name in teacher, true. Now another similar way of doing this is to do a test, such as, we'll just do it inside of a console log again, and we'll say teacher.name equal to undefined. And then what we'll do is we'll say the same question. When we do a refresh, we get false. That's because we're checking to see if it's undefined. So what we need to do is we actually need to invert the whole thing. So to do that, you can put an exclamation mark here instead of the first equals. Now it says true. So now you're basically saying if teacher name is not undefined. So the way this really works is it will look at the teacher object, which we will output right here, and it'll check to see if it has a property name, and it does, so it returns the value. But if for some reason it does not exist, here's what's going to happen. So we'll do refresh. It's going to search that object. Taco does not exist, so it'll look in the prototype. Oh, no taco there. It'll look in the prototype. No taco there. So it ran out of prototypes, so then it'll just return undefined. So that is how you check an object for a property. Hopefully that'll help you in your programming experience, and I'll see you guys in the next video. Hey, what's going on everybody? Welcome back to your JavaScript series. This video, we're gonna be talking about a cool method called hasOwnProperty. Now, it'd be a good recommendation to check out the previous video because we talked about how to check an object for a particular property, such as name. And now we're going to be talking about a method that's going to do something very similar, but a little bit different. We're going to get rid of the second half here, and we're going to say teacher.hasOwnProperty. And inside of the parentheses, we're going to put the property we're looking for, in this case, name. Doing a refresh, we still get true here. Expanding the object, you can see the name property is right there. Now the difference here is hasOwnProperty will only check directly on the object and will not check the prototype. So scrolling up, you can see, for example, we have this active inside of the prototype, but inside a teacher we do not have that active property. So if we put active in here, when we do a refresh, we get false. But if we do it the way we had it in the previous video, such as this not equal to undefined, teacher.active, do a refresh, we still get true. So this one will check the prototype, and so will the other way, which looked like this. And these strings are a little bit out of date, but oh well, we'll just get rid of name. There we go. So all we do is put active inside of quotes, and then say in teacher, do a refresh, and you can see both of the old ways return true, but hasOwnProperty returns false. So that's how the hasOwnProperty method works. Hopefully that was helpful, and be sure to check out the next video because we're going to be talking about lots of cool stuff, specifically how to list the properties of an object. Thank you for watching, and be sure to subscribe. Hey, what's going on everybody? Welcome back to your JavaScript tutorial series. This video, we're going to be talking about how you can list the properties of an object. I got this code essentially from the book, A Smarter Way to Learn JavaScript, which you guys can look up if you want. It's a pretty good book if you're looking for the basics of JavaScript. So what we have so far are these objects, and then we set the prototypes, and then we do a little bit of polymorphism stuff down here. So what we're going to do now is we're going to create a list called properties, and we'll set this equal to an empty array. And if we want to get all of the properties of an object, what we do is we say for, and in the for we can say let prop in teacher. So this is going to iterate through each property in teacher, and we're going to name it prop for that iteration. So then what we can do is we can say properties.push, and we can push that prop into that array. Then if you want to see all the properties, you can say console log and put properties in there. Doing a refresh, you can see we have a list of the properties: name, teaching, say hello, and active. Now the next thing is if you want to just get the properties directly on an object rather than throughout the entire prototype. So right now, scrolling up, you can look at the teacher and you can see we have name, teaching, and say hello directly on the object, which are the first three. But active comes from the prototype up here. So if we want to get rid of those, here's how you do that. So what we're going to do now is inside of this for loop, we're going to say if teacher.hasOwnProperty, and inside of the parentheses, we're going to pass in prop. If this is true, then it exists directly on the object, so we can push it into the array. So we'll paste that there and clean this up just a little bit. Beautiful. Now when we do a refresh, we only get those first three: name, teaching, and say hello. Active, on the other hand, is not part of that list. So that, my friends, is how you get a list of properties on an object. Thank you guys for watching. In the next video, we're going to be talking about converting object literals to constructors. So far, we've just been using object literals, but this is not a really scalable option if you want to create lots of objects. So thank you guys. I'll see you in the next video, and be sure to subscribe. Do it now. Hey, what's going on everyone? Welcome back. This video, we're going to be talking how we convert these object literals into constructors, which is a little bit more scalable option when we're doing inheritance and all that good object-oriented programming junk. All right, so there's going to be a lot of changes. So what we're going to do is we're just going to start fresh. I'm going to keep this code for now, but I'm going to go back and remove it eventually. So what I'm going to do is I'm just going to scoot everything down, but you can get a good look of it real quick because we're going to base our code up here off of what's down here. So instead of saying an object literal here, we're going to create a function, and it's going to be user with a capital U. So again, that's the convention for a constructor. A constructor is just used to create multiple, in this case, users. So we can use it as a utility to create lots of users. Then instead of using key value pairs, we will say this.active and assign it a value such as false. and then we end in a semicolon because we're inside of a function, so each one's a statement. Now for the method here, we're going to put that on the prototype as we've talked about. So we'll say user prototype dot say hello and set that equal to this junk right here. Beautiful. Next thing is the student. So what we're going to do is we're going to say function student, this dot name, and we're going to use a literal value for right now, but pretty soon we'll parameterize it in just a couple of minutes. Give you a nice encouraging name and set your major. The reason we don't want to put literal values here is because this is going to be used for all students that we create, and not everybody's going to have the same name and the same major. But this is a good starting point. Then we're going to do the teacher, so we'll say function teacher, this dot name, Caleb Curry. This dot teaching, we'll set this to an array, and we'll put a couple of values in here. Math and science. Now we're going to talk about the inheritance hierarchy in the next video, so for now I'm just going to leave this say hello function out of the picture, and we'll talk about that in the next video. The next thing on here is the set prototype of. That's what we're going to be talking about in the next video as well. Right now I just want to get the constructors built and make sure that we can use them, and then we'll parameterize them and so forth. So let's see how this is going to work. When we create a student, it's going to look like this. Let student be a new student. And rather than just getting these default values, we want to pass them in. So I'm going to take this, paste that here, take this, paste that here, because these are going to be specific values for this new student. This is an individual student, so we might have 10 students. This is just one of them. And we're going to take those as arguments, so we need to create two parameters here. We'll say name and major. Then here we'll say name and major. We're going to do the same thing for the teacher. So we'll say let teacher be a new teacher, and we're going to take these values and I'll take the teaching as well, and then we'll parameterize it. Now just to confirm we got it working, we're going to console log the student and the teacher. I'm going to scroll down. I'm going to comment out all the other console logs we have, just so we have a clean console. There we go. So now when we refresh the browser, we get an issue. Student has already been declared. All right, that makes sense because we've been writing this code ourselves up here, and I did not go and comment out the code down here. So what we're going to do is we're going to comment this out, or we'll just actually just get rid of it. Everything from all the way down here, we'll just get rid of. There we go. Now we do a refresh, and look at this. We have a student with the two properties, and we have a teacher with the two properties. So now we have the equivalent objects that we just had written as object literals, but we created them using a constructor. So now if we want to create more of them, it's a lot easier. So using this technique, you could create a loop and create numerous students. So if you wanted to create 100 students, you could do a for loop from I0 to I99, and then create a new student for each iteration, put those in an array of students, whatever. The sky is the limit. Whatever you need, you can do. Essentially what I'm trying to say is the constructors is a much more scalable option. Now what we're not doing yet is anything with the prototypes. For example, expanding the student and the teacher. Looking at the prototype, you're not going to see anything about a user. So there's no prototype chain. That's what we're going to be doing in the next video with constructors. So thank you guys for watching. Be sure to subscribe and go check that out because it's some important stuff. Hey, what's going on everyone? Welcome back. In the previous video, we created these constructors, and now I want to set up an inheritance hierarchy. Basically, the student and the teacher should both inherit from user. So my vision is that we have some website, students can sign up, teachers can sign up. They're both users, but they're both a little bit different. So make sure you watch the previous video if you need help getting all this stuff set up. Otherwise, enjoy. So if we wanted to set the prototype, we could go down here and set the prototype of the student. We could say student.prototype, and then we could set this to some user object we create from this constructor. But the better way of doing it is to just do it for all of the objects rather than each individual one. So to do that, what we can do is we could say student.prototype, and notice we're using the capital S, so we're doing this for the constructor. And we're going to set this equal to a new user. So the prototype for student is going to be a new user object. We'll do the same thing for the teacher. So we'll say teacher.prototype equals a new user. So each one of these gets their own user object, which will be the prototype. Now, compared to what we had here previously in the console, you can see there's no prototype talking about a user. It's just this object. When we do a refresh, check this out. Now, the prototype is a user. Oh yeah, very cool. So now if we want to override a particular property, such as this method here, we can do that. For example, we'll go down to the teacher and we'll create a new say hello. So we'll just say teacher.prototype say hello, and we'll set this to a function, and we'll just return teacher says hi. Let's do a refresh and see where that shows up. So expanding the teacher, expanding the prototype, right there it is. Whereas if you look at the student, you expand the prototype, then you expand that prototype, and there's the say hello. So basically on the teacher, we made that say hello function one layer up closer to the teacher. So rather than using the say hello method that is in this prototype, we just have it one layer up closer to the teacher.
Hey, what's going on everyone? Welcome back. This video should be pretty simple. We're going to be talking about the instance of operator. So this is used to see if an object is of a particular type. So when we are working with inheritance, the instance of operator is going to be important to us because we want to make sure we are working with an object that is of a correct data type. Now, I'm using the term data type very loosely. Basically, I just want to make sure, for example, a student is a valid user and so forth. So I'll show you guys how to do that. So what we can do is we can What we can do is we can go down here and we can console log and say instance of teacher. Doing a refresh, you see we get true. But we can also do console log teacher instance of user. Capital U there. Do a refresh and we get true. Which makes sense when we expand teacher. You can see in the prototype we get user with a capital U. That's because it comes from this user constructor. So the object that this teacher inherits from is a valid user object, which you can see from line 22. So when you create a teacher that inherits from a user object, the teacher is both a teacher and a user. So when you're doing polymorphism stuff, you can be sure that you're working with a valid data type for whatever you're doing by checking it using the instance of. So you can do it inside of an if statement. So for example, we'll switch it up and say teacher instance of student, which will actually be false because a teacher does not inherit from student. So we'll have an else clause here and we'll console log. Nope. All right, do a refresh, and right hand side of instance of is not callable. I need to make sure this is a capital S. So it's a type student. Refresh and we get nope. If we go back to that lowercase s for a second, refresh, you can see right hand of side instance of is not callable. So basically it's saying, hey, this student here, that does not correlate to a function such as this one here. But when we use that capital S, well now it's callable. So it's going to work. And basically expanding on that teacher, we can see that the prototype, nowhere does it contain student. So something you might be able to do with this, let's say we go down here and we create a function, we'll call it do something. And what we can do is we can create a function that can work with both teachers and students. So how would we do this? Well, we'll give it the name user because it's a little bit more general, and then we can do a case. So if user instance of user, if it's a valid user, what we can do is we can return, 5. Otherwise, we can return -1. Basically, it's an invalid type. Now, you could do some complex algorithm here. We're just using numbers here just to illustrate the concept. And we can call this, so we can say console log, do something, and we will pass in the teacher object we created up here on line 28. And I'm going to get rid of some of these other console logs. We'll get rid of these 2 that we created in this video. And we'll get rid of this conditional here. So when we do a refresh, we get 5. So it's a valid user. But if we pass something in here that's not, such as a string, we do a refresh and we get -1. So that's how we can create a function to work with the parent objects, and we can be sure that it doesn't try to execute the code if the type is incorrect. Alright, that's all I got for you guys in this video. Hopefully that is helpful.
What we're going to be doing now is we're going to be taking a break from the object-oriented stuff, and we're going to get into a little bit with what you might have actually expected this entire series to be about, which is working with the HTML and making our pages dynamic. Lots of series focus on this content. I, on the other hand, tried to focus on the JavaScript language pieces, so now when you go to work with the page, you actually have an understanding of what in the world you're trying to do and how to do it. So you're welcome for giving you that good quality background. Now you can go modify your HTML like a boss. So let's do that. I'll see you guys in the next video, and be sure to subscribe. Yo, what's up everyone? In this video, we're going to basically do a quick dive of HTML. This is a JavaScript series, so I know, like, what are we talking about HTML for? But JavaScript and HTML are highly integrated. So if you're working with web pages, you can't really have one without the other. So this is going to be your HTML crash course, just to give you the main essentials you need to start working with web pages. Now, inside of our JavaScript, we can basically just get rid of all this stuff. We're not going to be needing that, and if we do, I'm sorry. Alright, so let's just start fresh. Inside of index.html, the only thing we have is the body and the paragraph. Alright, so this video is going to be giving you the prereqs for HTML, then we'll touch on CSS, and then we'll talk about integrating JavaScript into it all. So those are the three pieces. HTML is your structure, what pieces we want in our web page. The CSS is the styling. We don't actually have any CSS here, and that's fine, we'll get into that. Lastly, we have the JavaScript, which is the functionality. Now, if you need a good illustration, imagine we're building a house. HTML is the walls, the doors, the cabinets, basically the structure of your house. The CSS is the design, what size windows you want, the color, the shape, all that junk. JavaScript is the functionality, so this allows the windows to open, the doors to open, and the cabinets to move. So hopefully that illustration helped, probably didn't, but that's okay. So let's start from the beginning. HTML. Now we start with this doc type HTML at the top with this exclamation mark. It's basically a way to tell the browser we're using HTML5. Everything goes inside of these HTML tags. HTML stands for Hypertext Markup Language and is broken up into a bunch of elements. So an element consists of an opening tag, some stuff, and a closing tag. So let's look at the first element, the head element. We have the opening tag right here, we have the closing tag, and then we have a bunch of other stuff inside of it. So that is an element. Some elements do not have an opening and a closing, and they just exist by themselves. These are known as self-closing tags, and you'll probably see those with, for example, the break. And you'll sometimes see those like this, other times you'll see them like this. I think either one is fine. This is XHTML compatible, but I don't think it really matters, honestly. Whatever you prefer. The BR is used to set a break, so it'll show up as spaces right here. But for now, we'll just get rid of that because we're not done talking about all the boring pre-stuff. There are a lot of elements you can use. You can look up a list, but just some of them are the P for the paragraph, which is right here. There's a BR for break. There's a div. There's a button. There's an input. All kinds of stuff. Now, one element we can do is known as an H1. This is an example of a heading and will change the way the text looks. So basically, it makes it really big and cool looking. Now, not only does this change the looks, but this is also used for SEO. Search engines and crawlers will use this information to decide how your page is structured and what to focus on. So what the web page is actually about, or what the title is, should go inside of the H1. This title up here, that's what actually shows up in the tab up here, which is also very important. There should only ever be one H1, but you can have multiple H2s. The P is used to describe a paragraph. We also have a span, and I'm going to get rid of the H1. We'll do a refresh, and we'll see these. So this is a paragraph, and this is a span. They're very similar in nature, but the P describes an entire paragraph, whereas a span just describes a section of HTML. The span is going to be inline, so you can make just a piece of something a span. So to see that, what we could do is we could actually make this a paragraph, and we can make this last word a span, like so. Doing a refresh, you can see nothing really changes. So spans are just used to indicate a particular section. We can give it an ID, and then we can style it or give it some functionality. We also have divs, which can describe a section. So that might look like this, where we can surround our content with a div. That can be used to describe an entire section, usually bigger than a span. A span might just be part of a sentence. A div might be an entire section of a page. Now you can also create lists. So you can do that with UL or OL. So UL is an unordered list, And then each item inside of this is going to be li for list item. So here's my shopping list. All right, so we got a lot of variety here, and you can see this will show up with the dots. An ordered list, OL, is going to number them. Doing a refresh now, we got 1, 2, 3. Next thing is we can create images. That's going to look like this. Image, source, and then we can put a URL. And then we can end it. Inside of the source, we can put either a local file location or we can put a web address. So I just got some image off the internet, doing a refresh. Look at that, it's a giant image. We can go in here, we can modify this. For example, we can set a height and we'll set that equal, oops, probably put the quotes there. We'll set the height equal to 100 pixels. Do a refresh now, and there we go, it's a little bit more manageable. Links are similar, so what we're going to do is we're going to go down to the next line and say href. So instead of source, you're going to have href. And then equals and paste a link here, such as the same link. And then you're going to close it. This one, you're going to have a closing tag. And in between the tags, you can put your text. So we could say, for example, source. Doing a refresh, we have the source text, which we can click and it goes to the image. So what I'm going to do is I'm just going to put a break here. And that'll bring the source down to the next line. Now you may also see an href with just a pound sign. What this is going to do is it's going to make a link, but it doesn't actually go anywhere. And this is often used if you just need to make a button that is tied to some JavaScript, for example, that might cause something to happen. So I'm going to go back, keep that link there. Now when you're working with simple HTML, linking to other pages is often very important. But when you're working with JavaScript, you'll often create what are known as SPAs, or single page applications, SPAS. And in this situation, you might just have an index.html, and this will render the whole app dynamically, and things will just stay on this one page. But if you need to link to another page, all you gotta do is put the file name. If it's in the same folder, you can just put the name, no prefixing, but you can also do a lot of different ways to navigate through your file structure, and you can look that up if you need specifics. So the important thing to realize is that this is all client side, meaning over here we can inspect and we can see all of the HTML used to create this. So there's nothing secure about HTML. We can go in here, we can see it all. We could also view the page source and look at that. Once we have an element, we can grab it in JavaScript. So if you guys want to see that, all you gotta do is go into the JavaScript and do something like let my button equal document.getElementById, pass in some ID such as click me, and let's go create a button to match this. So inside of the HTML, let's get rid of this junk. Here we will create a button, and this will have an ID which will say click me. Then what we can do is save, do a refresh, see our button right there. Inside of the HTML, we can put a value here, such as click me now. When we do a refresh, you can see the button there. Zoom in a little bit. Inside of the JavaScript, what we can do is we can say my button.disabled and set that equal to true. Doing a refresh, you can see now we cannot click it. So that is how you dynamically grab a button inside of JavaScript. We're gonna be doing all kinds of stuff like that in the upcoming videos, but that's just a little bit of a taste. Now that's all I got for this video. The next video, we're going to do a crash course for CSS. And then we'll talk a little bit more about the JavaScript side of this, working with JavaScript to modify the page and so forth. So if you liked these 2 lines here, you're gonna get a lot more of that in the upcoming video. So be sure to subscribe. Hey, what's going on everybody? Welcome to your JavaScript series. This video, again, is not about JavaScript exactly, it's about CSS. That's because it's also an essential ingredient for web development, so I just want to give you what you need to know to start working with it. Now, by the end of this video, you're not going to be an expert, like me, of course, but we are going to go through some of the key essential things you should know about CSS. Now, when it comes to CSS, this is something that you link to your HTML file. Now, you can have internal CSS, which you put directly in your HTML file, but it's usually recommended to have an external style sheet. So by external, I mean external to this page. We're actually going to create a new file, which will be its own CSS file. So how do you do that? I don't know, let me look it up. So all you have to do is in the head, put link, and then say rel equals style sheet. And then we're going to give it an href, which is the file location, and we'll just go with stylesheet.css. Now our JavaScript is actually in a separate folder. You could do that if you would like. To do that, just go in here and say CSS, put a slash, and then inside of our folders, we can click new folder, CSS. Inside of there, create a new file, call it stylesheet.css. .css. Just to make sure it's working, you can put an asterisk and then curly braces, and then inside of these curly braces, what you can do is just say background color and set that equal to red, like so. Doing a refresh, wow, look at that. All right, so you see we have this asterisk. This is an example of a selector. Now, if you want a good list of selectors, I recommend the best source on the internet, W3 Schools. So you can find that here, CSS selector reference. And you can see we did this one here, which selects all elements. So basically everything in the entire page was selected, and we changed the background color to red. Now you can grab other things using all these series of selectors. I'm not going to go over all of these because honestly, I just don't want to. So once you select a selector, you can choose properties and values. So what we did, our property was background color and the value was red. What are the other possibilities for the properties though? Well, going back, we can see this really good reference here, which is the CSS reference, and here is a list of all of the properties. So here's what we're going to do. We're going to get a more specific selector. So to do that, we can grab an element. In this case, it's giving an example of the P tag, so it'll grab all the paragraphs, but we could actually use a different element. So let's try an example of that. We can go up here on a new line and say button, and inside of the button, we can give it a different background color just to see the difference. Blue. Doing a refresh, look at that. This is modern web development. So this is kind of odd. If you read this from line to line, you can see we set the button's background color to blue, and then we say we grab everything and set the background color to red. So, you know, wouldn't this change the button's color to red? Not exactly. Basically, there's a layer of rules in CSS defining which ones get applied and which ones get ignored. This concept is known as specificity. Specificity. I think I got it right. Yeah, so this is known as specificity. Specificity? How do you say this? Specificity. Yes. And you can see this is 0, 0, 0. Hovering over button, we got 0, 0, 1. So that's at least a little better. Basically, the way the order goes is inline CSS happens first. So if inside of index.html, you go in here and you say body style equals background color green, that's going to be applied over all others. Doing a refresh, you can see we get the green here for the body. So I'm going to get rid of this, go back to style sheet. Then the most specific thing will be applied. So talking to the button is more specific than talking to everything. So that's the one that's going to be applied. And then if you happen to have the same specificity twice, then the latest one is going to be applied. So if down here we set something else, let's say we change the background color to green yellow, and we're going to also set the border. So we can say border, and we'll say yellow dotted. Doing a refresh, check this out. It's yellow, and we got that dotted background. So this one was overridden, and this one replaced it. Now check this out. If we took this one up here, cut that, and pasted it down here, here's what's going to happen. The entire section for this button is not going to be overwritten, only the background color. So when we do a refresh, you can see we still have that dotted border. So it doesn't override everything from the first button, just that specific style background color. And if for some reason a particular property value is extremely important and you don't want anything to override it, you can do that. So for example, we want this green yellow to not be overridden. We can just say important, prefixed with the exclamation mark. It's kind of confusing because in other programming languages, the exclamation mark means not, so it's kind of like it's saying not important. But in CSS, that's not exactly what it's saying. It's actually just saying this is important. And you just prefix it with the exclamation mark because that is the syntax for it. Now, what you're probably going to do a lot of the time is grab things by class and ID. So looking back at the CS selectors reference, you can see we can grab classes and we can grab IDs. Classes are prefixed with a dot. IDs are prefixed with the pound sign. So check this out. What we're going to do is we're going to get rid of our CSS because it's pretty ugly. Go back into the HTML, and I want to create like a simple list. So inside of the body, what I'm going to do is I'm going to create an OL, an ordered list, and inside of here we're going to have some list items. So we'll have home, contact, and just to warn you guys, this isn't going to be like an amazing website. And then we'll have an about us. So doing a refresh, this is what we got. Beautiful. Now I want to assign some classes and I want to assign some IDs and talk about the difference. So a class, you can assign this to numerous things. So we'll go in here, we'll say this is the class border, and we'll also put that on this one here. So we'll say class is border, and we can style both of these together by referencing this class. So going into the CSS, it might look something like this. Dot border. We put the dot because it's a class, and then we can give it a border. 5 pixels orange solid. Beautiful. Wow, this is stunning. Now the ID is a little bit different because that's only going to be used for one thing. So we could actually put it on something that already has a class. We could just say ID, and we can just call it special since it's the only one. Inside of the style, we can grab that using the pound sign. So we can say special, and we'll just make the color. Oh my golly, Claire, you're emailing me now? Seriously? It's like 7 in the morning. We'll just make the color green. Doing a refresh. Wow, look at that. Green text. All right, cool. Now, the other thing you should probably know is that working with the CSS, you can do it pretty easily by inspecting the page and going in here and dorking with the styles down here. Now, for some reason, I can't resize my windows. I'll just close this one out. Let's inspect this about us. And that's going to open where that is. And what we can do is we can test our CSS here. So for example, we could set a margin, and we'll set that to 30 pixels. And you can see that changes stuff. We can also set a padding of 10 pixels, and that changes stuff. None of this is going to persist, so the actual file stays the same. Looking back at our code, you can see nothing changes here. So this doesn't actually save. It's just for experimenting, but it's cool because you can go in here and you can increase the numbers by using the arrow keys. It's pretty cool. So margin determines how much space is outside of an element from the other elements. So this right here, this area. Padding is on the inside and determines how much space the stuff inside of it has. So if we increase the padding, you can see the space between the about us and the border increases. There we go. Now the contact and the about us is pretty separated. They're probably pretty sad because they're all concerned about their spacing. They're probably going to make a movie, The Space Between Us, or something stupid. So we're just going to decrease these, and you can actually just turn them off if you just want to go back to normal. That way you can see the difference. Now, obviously that was a pretty terrible CSS introduction, but you know, that's the kind of quality content I create. Nothing more than you would expect. So what you need to do now is if you want to master CSS, you need to focus on that separately. Now this is a JavaScript series, so what you need to do is you need to worry about the CSS later and just focus on getting your JavaScript down. Don't get too sidetracked. I just wanted to give you the basics, but if you want some other stuff to study, I would look up pixels versus EM versus percentages. Also important selectors and properties, how to style lists, how to style links, how to dynamically size pages, and how to do scaling and all that good stuff. Now, it wouldn't be a JavaScript series if I didn't tell you at least something about JavaScript. So what we're going to do is we're going to go back and change some JavaScript stuff. So we're going to change some of the style on our button that we created. My button's kind of a long name, so you could just call it my butt for short. So what we'll do is say my button style, and then we can set a particular style by putting its name. So for example, background color, and we can set it to red. Doing a refresh, look at that. We just styled our button. Cool. So that's the basics of CSS and working with it inside of JavaScript. You can make things dynamic with JavaScript. So for example, inside of a click handler, you could change the style. Doing a refresh, clicking it doesn't work because it's disabled. So we will just comment that line out. Doing a refresh, click it, and it turns green. So that's how you can do some dynamic JavaScript stuff. You know, when you click a button, maybe it goes gray and turns disabled and so forth. So what we could do is do that by cutting this and pasting it here. Maybe you want to activate something and it starts red, you click it, turns green, and now we can't turn it off. Yeah, so that's some good stuff. All right, I'll see you guys in the next video where we're going to be talking about the DOM. Peace out, and I'll see you in the next video. And don't forget to subscribe.
What's up, internet? This video, we're going to be talking about the DOM. So far in this series, we've talked a lot about the functionality of JavaScript. We've talked about how to work with methods, object-oriented programming, and all that other boring stuff. This video, we're going to actually start talking about working with web pages. which is what the majority of you guys are probably wanting to do with JavaScript. A key ingredient to this is known as the DOM, D-O-M. So DOM stands for, what is it? Document Object Model, which I totally did not forget. And basically this is a structural representation of your page. So similar in how HTML describes the page, the DOM is a structural representation of the page as well. We can programmatically work with the DOM and it will be shown inside of the web page in the browser. So one thing we've done before is document.getElementById. This is how you grab a particular element inside of the HTML. This is one way we can work with the DOM, but there are so many more ways that we can work with the DOM, and that's what we're going to be talking about in the upcoming videos. You can consider the DOM to be sort of like boxes that are related to each other. Each of these boxes is known as a node, and a node can have child nodes. So this is the child node, this would be the parent node. Now these bad boys, these are known as siblings. So they're probably gonna be fighting and all that other stuff siblings do, but we'll teach them how to get along. Basically, we can relatively reference nodes using a parent. So for example, if we have reference to this node, we can say node.child nodes, I think it is, and we can get access to these three. So it's this relative way of basically traversing through the structure of your web page. Now I planned this video out ahead of time, and man, I was thinking I had all this juicy information to share, but I think I pretty much covered everything in that really short period of time. So what we're gonna be doing now is we're gonna start working with the DOM for the next section of videos. And yeah, that's pretty much it. It'll be a lot of fun. And I was trying to think of a pun, but I really don't got anything. That's all. Thank you guys. Peace out.
Hello everyone, welcome back to your JavaScript series. I'm gonna just clean off all of these files, get rid of this ordered list, and we'll keep the button because you know it's cute. Alright, so we're gonna start fresh. We're gonna start working with the DOM. You know, it might actually be good to leave that list in there. So we'll put this list in here so we can see that inside of the DOM structure. So in the browser, go into the console, developer tools, go to document, dot, and type in child, and one of these in here is child nodes. Expanding this, you can see we have HTML. This is the one we are interested in, so expand that. And in here, we're going to have more children. So we can expand the child nodes. We can see we have the head and the body. Ignore the text here. These things are automatically added based on how we have our source code typed out, but they're not actually contributing to the structure of the page. So what we just care about is this body. We can expand that and we can see child nodes again, expanding that, and you can see our structure. We got those texts we can ignore, so the main thing in here is the ordered list and the button. So you can go through this and see the entire structure of our page. Using this structure, we could grab any element in the entire page. So rather than grabbing something by an ID or a class, we could grab it by traversing this structure and grabbing the node. So for example, if I wanted to grab every element in the ordered list, here's something we could do. Let's go back to our code. Scoot over, everybody. And we'll go into the JavaScript file. And we'll say let list equal, we're going to go to document.childNodes. And we'll just follow the structure. So the very top, the child nodes is going to give us two elements. We want that index 1 dot. Doing it again, we'll go to child nodes. And this time we want index 2 for the body dot child nodes. And this time we want index 1, which is that ordered list. All right, so this should do it. What we're going to do now is we're going to console log this list. Make sure we got everything right. And doing a refresh here, you can see, look at that, we got the ordered list. And here you can see the elements inside of it. That's really cool. So that's how we can traverse the structure, just by going through the children. So now you can also grab a node's parent. To see that, we can say console log list.parent element. Doing a refresh, we see it's the body, which makes sense. Now, if you want to work with this a little bit more dynamically, you can just type it out in here. If that's what you prefer to do, you're not just going to be able to type it like so. You're going to have to get rid of these curly braces. I think that'll do it. There we go. When we have the curly braces in, the items are just scoped to these curly braces. So after we get to line 7, it's gone. In this situation, list is not going to exist. See? Now, nodes can also have siblings. So let's see what that looks like. We will console log list.sibling, and you can see we have next sibling and previous sibling. Let's go with next sibling and see what we get. You can see we get that text, which is annoying, so we just can skip that by going to .next sibling. Refresh, and we get the button. So structurally, that makes sense. We have the ordered list, then we have the button. So those are some of the basics. You can see there are a lot of other options. So just to see some of them, you can type document, and just typing in child, you can see we have all these different possibilities. So what we're going to do is in the next video, we're going to talk about getting elements by tag name and getting elements by class name. That should be pretty fun. So be sure to subscribe and go check out the next video. Hey, what's going on everyone? Welcome back. This video, we're going to continue our discussion on working with the DOM. This video should be pretty simple, but it's still important. All right, so what are we going to be doing in this video? Well, we're going to be using get elements by tag name and get elements by class name. So in the previous video, we learned how to work with nodes by grabbing child nodes. This one's going to be a little bit different. I'm going to get rid of these console logs and we'll start fresh. So right now we are grabbing a list by basically starting at the root and going through the tree. Although that works, it's not exactly the most sophisticated methods of grabbing stuff. So let's get rid of that junk. So what we're going to do is we're going to grab all elements by a particular tag name. So to do that, you say document.getElementByTagName. And what does it mean by tag name? Well, you can look in here if you want some overwhelming guides, but what I'm going to do is I'm just going to put li. So this is an example of a tag option, list item, that'll grab all of the list items. Now we do have the option of grabbing all the ordered lists, and then we would have those collections. But since we only have one ordered list, I think it's fine just to grab the list items directly. So if you wanted to work with all list items, here's how you would do that. So just to see this, we can do a console log, and we'll just put list. Refresh this bad boy, and you can see we get this HTML collection. We have the first list item, which has the class border, the next list item, which is plain, and then we have the next list item, which has the ID special and class border. So those just kind of describe what the HTML structure is. And looking at our HTML, that is in fact correct. See, class border, ID equals special. So that's our structure. So the object returned from this is of type HTML collection. If you want to know more juicy details about this, I'd encourage you to look up some content about it. Basically, as you get more familiar with DOM manipulation, you can start adding elements to this, and you can start removing elements, modifying it. But basically, all I wanted to cover right now was just get it by tag name, and also to get by class name. So we'll also replace this by class, do a refresh, and also we should update the class. We'll put border, since we have two items with that class, and now we have two elements. So there's a lot of different flexibility, and going back to just the get, you can see all these different options. So thank you guys for watching this video. What we're going to be doing in the next video is talking about node types and node names. So that'd be a lot of fun. Be sure to subscribe, and I'll see you in the next video. I forgot what it was called for some reason. Hey, what's going on everyone? Welcome back. This video, I wanted to talk about node types and node names. So each node inside the DOM has a node type, and they also have names. Now, if you want a lot of juicy details about this, there's this guide by Mozilla. So looking at this node type constants, we can see there's a bunch of stuff in here, but the important ones is number 1 and 3. So the first one here includes elements such as paragraph, div. We use this all the time. Any elements is going to be considered an element node. And then the next one is the actual text inside an element. So the stuff inside of the paragraph, for example, is a text node. So element nodes and then text nodes. Those are the two types of nodes that I think you guys should know about. And you can ignore all this other crap. So what we're going to do is we're going to take a look at our DOM structure by going to our, which way is it? I'm lost. We're going to check out our DOM structure by going to the console and saying document.childNodes, and here we can see a little bit of information. Going into the HTML, the second one there, going into the child nodes, into the body, into the child nodes, into the OL, so the ordered list. Here we can start seeing some good stuff. The thing I'm interested in is if you scroll down, get to the ends, you can see node type is 1. An ordered list is of node type 1, which makes sense because it's an element. So let's expand into this a little bit more by going into the child nodes. So expand that, and let's expand the first list item, so home right here. Looking at the node type in this one, we can see it's also 1. So list items are also considered elements. Now what I want to do is I want to expand the children for this one, so specifically child nodes, not the actual children property. So expand child nodes, and you can see we just have this text, which is actually an important text here, and the value is home, as you can see a couple times throughout this. In this situation, the node type is 3. That's because it is the actual text inside an element. You can use this information programmatically to check the node type. So as an example, we will create a list like we did in the previous videos, and we'll just say document.get element by tag name, and we will pass in a list item in here. And what we can do is we can do a conditional if list index 0 dot node type has the value 1, then we know this is an element, and we'll do an else if list 0 dot node type is 3, then we know this is text. And it seems silly to do this now because we already know it's going to be an element, but it's always good to know how to do things programmatically in case we're working with something and we're not sure what it is, or we need to treat it differently based on the value that we get. In this situation, we're just kind of hard coding it of something we already know, but that's not always going to be the case. So doing a refresh, let's see what we get. We get element. I'm also going to just console log the element so we can see it. List 0. Refresh, this is what it looks like. What if we do dot child nodes? Let's see what we get. Refresh, we get a node list, and index 0 is text. So let's grab index 0, like so. Doing a refresh, we get home. If you wanted to check that, all we would have to do is say node index 0 dot child nodes index 0 dot node type. So this would be checking the actual contents of this list item. And what we're going to do is we're going to put this inside of the else if as well, but change the number to 3. So that way we're checking for the right stuff. Here, let's expand this a little bit. So here's what's going down. We are checking this value right here to see if it is of type element or of type text. Doing a refresh and we get text, which lines up, right? Because if we go in here and say node type, console log it, look what we'll get. We get 3. Awesome. Nodes also have a name, so you can go in here and you can say node name and see what that is. And you can see it's text. Backing up just a little bit, we can see that the list item is going to be li. So you can look up possible node names, you can work with these programmatically, all kinds of possibilities, but main thing you should know is that things have a node name and a node type. 1 is an element for the node type, and 3 is text for the node type. That's all I got for you guys in this video. What we're going to do in the next video is talk a little bit about text nodes. Hey, what's going on everyone? Welcome to this video. Today we're going to be talking about something that might be obvious to some, but maybe not for others. So if you already understand this, don't worry about it, but it might still be good to go through this content. So what are we going to be talking about? We're going to be talking about the children nodes of a text type node. So you can see in the previous video, we clarified whether something was an element or text. Well, we're going to be talking about this section right here, the text part. So let's clean this off for a minute. Let's just go back to our list. Basically, we're just getting all of the list items in our DOM structure, which looking at our HTML, you can see we have 3 list items. And that's what we're going to work with. So right now we are working with list items, but what I want to do is I want to just make this real simple for us. And I just want to create one paragraph element. We're just going to put some important information in there. And now we're going to access this from our JavaScript. So we'll just say paragraphs, and then we'll just get elements by tag name, and we'll pass in the P. We'll console log this bad boy and see we get an HTML collection with one entity, the index 0. Now the reason I said paragraphs, even though there's 1, is because of the type we're working with here. We're working with a collection, it just happens to have only 1 index. So if you want to just have paragraph, then what you need to do is you need to grab the first element inside of here, and you use the 0 index for that, which will grab this one right here. Then we need to console log paragraph, and there you go, we have our paragraph right there. One downside to doing this is that this doesn't translate exactly the way I want to look at it inside of the console. It's not an exact representation. So in order to fix that, I'm going to get rid of that and go back to paragraphs, and then we can just traverse the structure that's given. So doing a refresh, now we can expand this paragraph tag and see all of its data. Let me scoot this over just a little bit. So the first thing I wanted to show you guys is that this thing has child nodes. And inside of here, one of these is text, which contains important information. So it might be odd to you that a paragraph element has child nodes, which includes this text. It's almost like an extra step, because doesn't a paragraph just contain text? Like, why do we have to have child nodes? Why is the text its own node? Well, that is just the way it is structured inside of JavaScript, but paragraphs can actually have multiple nodes. So I wanted to show you guys an example of that. Inside of index.html, what we're going to do is we're going to put some stuff inside of this paragraph. For example, we can put a strong element, and we'll put important inside of it. This is used to indicate some emphasis on something and often shows up bold. Doing a refresh, you can see important is bold. When we expand this, going into that paragraph, into the child nodes, you can see we now have strong and text. So strong has child nodes as well, which includes the text, which includes important. Going back to the paragraph, we also have the text, which will just contain information. You can see that a paragraph can have child nodes, and each section is just one of those nodes. So this section here was one of the child nodes, and this section here was one of the child nodes. Another thing you might want to notice is that when we're working with a node that is of a text type, so you can see that in node type being 3, it's going to have a property called node value right here, node value information. If we go into a node that's not node type 3, it's not going to have that node value. So for example, going into strong, you can see on here, we have node type being 1 and node value is null. We're going to expand on this in the next video, where we're going to differentiate between element nodes and text nodes a little bit more. Then we'll get into modifying the DOM by changing node values and so forth. So it should be a lot of fun. Be sure to subscribe, and I'll see you guys in the next video. Hey everyone, welcome back. This video, we're going to be talking a little bit more about element nodes and text nodes and a little bit of their differences. It's going to be a lot of fun because we'll start to learn how to modify the values showing up on the page and all kinds of other cool stuff, so it should be pretty exciting. So we talked about the two common types of nodes. We had 1, which is an element, and 3, which is a text node. So for example, inside of this, we were grabbing all paragraphs, and the very first element is, of course, our paragraph inside of our HTML file, which is right here. So we have a paragraph which says important information, where important is in strong. Now let's take a look at the DOM structure over here. Expanding the paragraph, you can see we have child nodes. One of them is strong and one of them is text. The text is the information, and then you'll have to expand strong and go down to its children node to see the important text. As mentioned, text nodes are going to have a particular property called node value. So expanding this text here, you can scroll down and see node value right here. See that it says information. Now this is node type 3 text. If we're working with node type 1 an element, the node value is not something we can use. So to see this, let's go into the strong and look at its node value. Right now it's null. What we're going to do is we're going to work with this node value inside of JavaScript. So what we'll do is we'll grab the paragraphs index 0. That's going to be the first paragraph. Then we'll go into child nodes and grab the first index, which should be the strong. So let's just console log, make sure we got what we're working with, what we want to work with anyways. Doing a refresh, you can see it is in fact this strong element. So then what we can do is we can say node value, and we can give it a value such as llamas. Let's expand this HTML collection and take a look. Go into the child nodes, go into the strong, and we can see we have this node value is still null. So text nodes, you can change the node value. Element nodes, you cannot change the node value. If we set the node value on an element, nothing happens. So usually, with the exception of inputs, you can just change the text that appears on the screen by changing the node value property. So for example, if instead of grabbing the strong node, we actually grab the text inside of it, we can do that by doing another child nodes index 0 and then set the node value, doing a refresh. You can look at the HTML and look at that, it switched to llamas. There's various ways to do this. There's node value, there's inner HTML, text content. There's a lot of different properties that you can use to change the values in the HTML. This is just one. If you want, you can look up some of the differences between the others. For example, here you can see the different options that you can try, and they are all pretty much used to change what shows up on the screen. That's all I got for you guys in this video. In the next video, we're going to be talking about something. I'm not sure what, but whatever it is, I know it's going to be awesome. So please be sure to subscribe, and I'll see you in the next video. Hey, what's going on, everyone? Welcome back to your JavaScript series. This video, we're going to be talking a little bit about event listeners when it comes to modifying the DOM, primarily because oftentimes you're going to want to change something on your web page as a result of some event happening. We've done a little bit of this throughout the series, but this is just a little bit more for some practice. So let's take a look at our HTML. You can see in here we have a paragraph, an ordered list, and then a button. Now we've been able to attach event listeners to this button very simply by saying document.getElementById. And this is fine, it works great. We might actually work with the button a little bit in this video, but I want to actually work with our ordered list. So what I'm going to do is I'm going to access our ordered list first. So we'll say let list, and we will do document.getElementByTagName, and we'll say ordered list, and this needs to be in strings. So then what I want to do is I just want to console log this list, and it is an HTML collection with one ordered list. Now if we want to attach an event listener to an event, we need to have an actual node, not a collection. So what we can do is we can say let our list, and we can assign it list index 0. Then we'll console log our list. Refresh this, and we got our order list right here. Now some of this we don't really need, so I'm just going to get rid of everything that we're not working with right now. Doing a refresh, and there we go. So we're accessing this ordered list right here. Now we should be able to say our list dot on, and here we get a bunch of events. Now what we'll do is we'll do on mouse over, and we'll assign this a function, and we'll just console log like so. Doing a refresh, each time I move my mouse over this list, you can see the number of times it's been outputted on the console increases. So we can do pretty much anything inside of this, just like any function. So for example, we could change the list by saying rList.childNodes, and then we'll grab the first node, which will be this home. And you know, why not? We'll just change it a little bit. We'll change the node value to house. So let's do a refresh. And when I hover over this, boom. Okay, it didn't do quite what I was hoping. So let's take a look at this. Let's take a look at the HTML collection, which has our ordered list in here, and take a look at the child nodes. You can see I actually changed this one where I want to change this one. So that's where those stupid automatic text nodes can mess you up. Doing all this relative grabbing can be dangerous because if you ever update the HTML, all the numbers are going to change. So I'd prefer in general to grab things by ID or class. It's a little bit more structured, a little bit more safe, but it never hurts to practice with this. So we'll actually want to grab index 1. Now do we refresh when we hover over it? Oh, that didn't work either. Looking at the structure, we actually need to go into the list item and then grab its child nodes, which is where we can get that text. So let's do this one more time. We'll go dot child nodes index 0 dot node value, set that equal to house. Refresh, and there we go. Now it's working. The alternative would just be use an ID, so you could say ID, whatever you want to call it. We'll just call it home, and then inside of the JS we could say document.getElementById, pass in home. We can also just use inner HTML and set that to house. We'll get rid of this one and do a refresh. And you can see that works just the same, but it's a lot cleaner and a lot easier to do. You can also do an on mouse enter and on mouse leave if you want it to change back when you leave. So for example, we could do something with this button here. Say document get element by ID. I think this has the ID click me. And then what we'll do is we'll assign this to a variable so we can reference it again. And we'll say button dot on mouse enter. Here we will reveal something, such as setting the inner HTML to revealed. So we'll do a refresh, hover over this, it says revealed, but I want it to go away when we leave. So to do that, we can just say button dot on mouse leave and set this to a function. And then we'll do the same exact thing, but this time we'll put the original text, which is click me now. Or maybe we'll even do something else. Hover over me. Now check this out. Go in, it says revealed, and then when we leave, it says hover over me. So maybe that's a way you could do like some note cards or something if you want to study. You could reveal the answer, and then you could take the mouse off when you want to move to the next one. You can also affect other elements inside of the event listeners. It doesn't always have to be the same element. So for example, we could just say our list.remove, and that'll just remove the list. So I should probably put that in one of these event listeners. So I'll put that on mouse leave. So as soon as we leave the button, our list will disappear. Kind of useless, but just to show you guys. And there you go. So thank you guys for watching this video. In the next video, we're gonna be talking about something new. I think we're gonna be talking about, I don't know, DOM attributes or something. I don't know, I guess we'll see when we get there. Thanks for watching, guys. I'll see you in the next one. Hey, welcome back everyone. This video, we're gonna be talking about attributes. So some elements will have attributes rather than child nodes. For example, an input. So inside of index.html, we can put an input in here. It'll look something like this. Input ID, we'll give it some ID. We'll just say input, and this is gonna be type text, and then we can give it a value. And then we can just put some random thing just to show you guys. So we'll just say tacos, yum. Awesome, and then we'll unnet. All right, so these are examples of attributes, and we can see these in our DOM structure. So where would you find these things inside of the DOM structure? For example, if we wanted to find stuff and work with that programmatically, how would we do that? Well, it's not an actual child node because it's not an element. It's not like we have a paragraph tag or an ordered list tag. We just have an attribute. So it's going to be a little bit different. So what I want to do is I want to, inside of the JavaScript, I just want to, actually we'll just leave that blank. Let's take a look at it over here. We'll say document and explore it. Shrink that down a little bit. Give a little bit of room here. Let's actually do document child nodes, which will give us what we want. This is a node list, and we want this second one, which is this HTML. Going into the child nodes, and then into the body, and then into the child nodes, and then into the input. And now take a look at this. When we go to child nodes, it's empty. There's nothing there for us to grab. We actually need to find these attributes, and those will show up here. So expanding this, you see ID, type, value, and tacos. So value is what we want. We would expand that. And then looking in here, we can find node value is stuff. So that's where that value resides. So we can easily access this value property inside of JavaScript by saying document.getElementById and passing in the ID, which in this case is input. And then we use the value property. It's not showing up here, but it'll work. So value, and then we can give it a value such as a couple exclamation marks, and this will be a string like so. So take a look here. When we do a refresh, it switches to the exclamation marks. So that is how you can access that value a little bit easier. Now there's two methods you might also want to know. That is has attribute, and we can put in an attribute name here such as tacos, and then we'll just console log to see what the output is. Save and refresh, and we get the value true. So that's how you can check if an attribute exists. You can access all the attributes by using the attributes array. So we can say attributes, refresh, and you can see them all here as a series of nodes, ID, type, value, and tacos. Now the other method I wanted to talk about was get attribute, which we can pass in an attribute such as tacos, and it will give us the value. So tacos are yum. So sometimes you'll see people use HTML just to store values to describe something, even if those don't really have any use inside of the actual page. So for example, value here will actually show up here, but tacos doesn't actually do anything. But it can still be used programmatically to store some value, so it doesn't necessarily mean it's not useful. It's just not useful for the page display. So that's kind of your introduction to HTML attributes and how to work with those inside of JavaScript. Now, one thing I did want to mention is that these things are going to be lowercase when we grab them in the element. So for example, if we change tacos to tacos, and then inside of the JavaScript, we said .attributes. Doing a refresh here, looking inside of here, you'll see tacos is lowercase. This doesn't make a huge difference though, because if, for example, we say get attribute and we put some crazy capitalization in here, it should still pick it up. Refresh and we get the value yum. All right, so that's what you need to know about attributes when it comes to the DOM. Thank you guys for watching. Be sure to subscribe and check out the next video because we're going to be talking about probably adding nodes, which is pretty cool, but we'll see. All right, guys, I'll see you in the next video.
Hey, what's going on, everyone? Welcome back. This video is going to be really awesome because we're going to start adding nodes to the DOM dynamically in JavaScript, which should be really cool. So how's this going to work? Well, what I want to do is I want it to where I click this button and something is appended to this list here. Consider this like the basics or the basis for maybe a to-do list, and we want to add to-do list items. So what's this going to look like? First thing, I want to get a reference to this button. So this button is right here and has ID click me. So say document get element by ID click me, and we will assign this to a variable so we can reference it. So we'll say let button and assign that. And on click, we want something to happen. So we'll say button on click and assign it a function. So the way you create an element is you say document.create element, and then you can pass in the type of element, and we will pass in a list item. So we want to add another list item to this list. Now, what does a list item require? It actually requires us to set the text for it. So here's how you would do that. First things first, let's just console log this node that we just created. Let's assign it to a variable called node. We'll say let node, like so. So we can console log it, click the button, and we get this list item, but there's nothing inside of it. So to do that, we actually need to make a text node to put inside of it. So to do this, we can say document.create text node, and we put the value here, such as new, and you can assign this to a variable or you can use it directly. So what we'll do is just say node.append child and pass this in. So refresh, click me now, and then look at that. We got list item new. Now, in order to get this list item to show up on the page, all we got to do is append it to this original ordered list. So in the HTML, we have this ordered list here. That's what we're going to do. So let's give this an ID. We'll say items, and let's change up some of this stuff inside just so it makes a little bit more sense. So maybe this is clean house, upload vids, eat Chipotle. Chipotle is my life. All right, now we can access this ordered list by using the ID. So we'll say let list document get element by ID items. So that's our list. And then all we do is say list dot append child. And what are we going to append? We're going to append this original node. So pass that in right here. There we go. Refresh, click, and look at that. We're getting new items. So the structure is we start with this node, which is the empty list item. We append a text node, and then we append the entire thing to the list. Now, something cool we could do is actually put the thing we want to add inside of this text box. So instead of putting just text here, what we could actually do is put the value for this input. So to do that, we can just say document.get element by ID. I think the ID is input, and then just say value, not node value, just value. All right, refresh, do that, and you can see it says stuff. Change the input, and there we go. That's pretty cool. Now there's a lot of different methods we could use to determine where we want this thing to be put.
You can look up those if you want. So instead of append child, you can use insert before, and then there's various tricks you can use to put it second or third or whatever you want to do. Now what I would challenge you guys to do is figure out how to remove an element. So if you want to do that, you can look up how to use the remove child method, and that'll teach you how to do that. So that is how you can add nodes to the DOM. Pretty useful, pretty cool. I know we're not creating some beautiful app, but with enough time it would get there because we can make this super awesome shopping list and, you know, deploy it on the App Store, make millions. Thank you guys for watching. Be sure to check out the next video. It's a really important one, as always, but it's extra special. So be sure to check it out.
Welcome everybody to the conclusion of this series. Hopefully you've enjoyed this 100-part series. Now this is the 100th video, so I should probably, you know, conclude and say my goodbyes and say how proud I am. But all I'm going to tell you guys is that you need to continue working because we did not cover enough material in this series. Yeah, I know, there's always more to study, so do enjoy the progress you've made, but there's a lot of other things that you could pick up that would help your development. So here are some things you might want to consider. One, now that you understand the JavaScript basics, start learning some more advanced stuff. So go study the event loop and how the pages are constructed and how the browsers work with them. All that boring technical junk, you can go learn that stuff if you're interested. I would also really recommend trying to master a framework. Now, just so you guys know, there's a new framework about every 2.5 seconds. So you need to just pick one that you think is going to persist for at least a couple of days. So maybe go with the most popular ones and the ones that are rising in popularity. So right now, React is a big thing, but by the time I upload this, it'll probably be obsolete. So React, there's Angular, which I think React is kind of taken over Angular. There's also Vue. So those are the 3 big ones right now. And with that, that allows you to build single page applications very easily. It allows you to create more sophisticated applications. On top of learning the frameworks, I would learn some backend. So if you want to try Node.js, that's the backend version of JavaScript, which will allow you to basically take requests from a web browser, do some backend processing, and return some data. So that's a really good thing if you want to make some more complex applications versus just a front-end application. I'd also consider learning a database, so you might want to check out MongoDB. That's just a recommendation, but you can pretty much use anything, but I do have a video on MongoDB if you want to go check that out. Now, one thing I was hoping to get to but didn't quite cover in this video was classes. Obviously, this is a big part of JavaScript, especially if you go into React, that's all they use. But constructors are really the fundamental piece to that. So if you understand the constructors, learning the classes is more just learning the syntax. The result is going to be the same. So go check out classes inside of JavaScript and go master those. The next thing I would try to learn is a little bit more with working with APIs. So doing API calls inside of JavaScript, learning how to do things asynchronously and working with promises. There's pretty much a never-ending field of things you can study in that. So you can go do that. And other than that, the only advice I would have is to just have fun. Yeah, it's a pleasure having the honor teaching you this stuff, and I hope it was helpful. If you guys are interested, I will consider doing other series based around JavaScript. So whether it's an advanced JavaScript or maybe just a little piece of JavaScript in more depth, or maybe going into some of these frameworks. So what I would like for you guys to do is to leave a comment in the comment section saying what you liked about this series and what you'd like to see more of. So that's all I got for you guys in this video. Please be sure to subscribe, and I'll see you guys in the next series. Peace out.